Visualize your ever-changing infrastructure. Follow request traces through distributed environments, and get code-level visibility with always-on production profiling. Cut through the noise with automatic anomaly detection, and discover bottlenecks by mapping service dependencies. Datadog ingests all of your logs from any source, helps you optimize front-end performance, and secures your production environment with real-time threat detection. See inside any stack, any app, at any scale, anywhere. Join thousands of customers who rely on Datadog for full stack visibility. Start a free trial today.
What will I build today? Whatever it is, it has to be smart and connected. An app, an experience, a company, my company. Whatever it is, I'll need the right tools, all the tools. I don't want anything holding me back. What will I build today?
AG Charts is a modern open source charting library built for TypeScript, React, Angular, and Vue. Get started by simply providing your data, defining your series type, and then creating a chart. AG Charts provides over 25 different chart types, enabling you to visualize your data in any way you need to, from simple to complex. Learn more and get started for free at aggrid.com/charts.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Datadog, you can monitor your infrastructure, apps, and security posture in one place. Instantly visualize your ever-changing infrastructure. Follow request traces through distributed environments, and get code-level visibility with always-on production profiling. Cut through the noise with automatic anomaly detection, and discover bottlenecks by mapping service dependencies. Datadog ingests all of your logs from any source, helps you optimize front-end performance, and secures your production environment with real-time threat detection. See inside any stack, any app, at any scale, anywhere. Join thousands of customers who rely on Datadog for full-stack visibility. Start a free trial today.
What will I build today? Whatever it is, it has to be smart and connected. An app, an experience, a company, my company. Whatever it is, I'll need the right tools, all the tools. I don't want anything holding me back. What will I build today?
AG Charts is a modern open source charting library built for TypeScript, React, Angular, and Vue. Get started by simply providing your data, defining your series type, and then creating a chart. AG Charts provides over 25 different chart types, enabling you to visualize your data in any way you need to, from simple to complex. Learn more and get started for free at aggrid.com/charts.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code, so your customers can actually buy your product and you can get back to whatever it is you do for fun.
With Datadog, you can monitor your infrastructure, apps, and security posture in one place. Instantly visualize your ever-changing infrastructure. Follow request traces through distributed environments, and get code-level visibility with always-on production profiling. Cut through the noise with automatic anomaly detection, and discover bottlenecks by mapping service dependencies. Datadog ingests all of your logs from any source, helps you optimize front-end performance, and secures your production environment with real-time threat detection. See inside any stack, any app, at any scale, anywhere. Join thousands of customers who rely on Datadog for full-stack visibility. Start a free trial today.
What will I build today? Whatever it is, it has to be smart and connected. An app, an experience, a company, my company. Whatever it is, I'll need the right tools, all the tools. I don't want anything holding me back. What will I build today?
AG Charts is a modern open-source charting library built for TypeScript, React, Angular, and Vue. Get started by simply providing your data, defining your series type, and then creating a chart. AG Charts provides over 25 different chart types, enabling you to visualize your data in any way you need to, from simple to complex. Learn more and get started for free at aggrid.com/charts.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
What's up, everybody? My name's Phil Nash. I am emceeing here at JSNation, which is one of the biggest, most exciting JavaScript conferences we've got in the world today. We're here in Amsterdam with over 1,000 JavaScript developers here to learn about the biggest, best news in JavaScript and everything you need to know about how to build apps in 2025. This here is the community track where we're running some of the talks. It's an enormous big black box, which is absolutely fabulous to be part of. And when it's full of people, you can really feel the JavaScript buzzing. We're also going to go have a look now at the community area and see what's going on outside as we go around the event. There is a coffee break on right now, so there's probably people just packed up and trying to get hold of their coffee. Great. going to wave at people as go by. Hi, we're on camera. You want to say hi? Are you enjoying the event?
It's amazing, yes.
Fantastic. Got coffee already? Excellent. Yes. No, you're out of coffee. That's fine. We've got our sponsors here in the section here. So we've got hands on table, talking with people, giving away bits of Lego, which is always cool. AG charts on this side, which is great fun. Let's go have a look at let's go say hi to the registration desk. Excuse us. Hello, registration desk. How are you doing? We're on camera. Come say hi. It's our wonderful organizers. We've got arts and crafts. For our lunch tokens are getting cut up. It's very important stuff, the lunch stuff. All right, let's pop around the other side, see the other sponsors down here. I'm going to go backwards now. Hi, everyone. What do we got? We got Datadog down here showing enormous amounts of data on screen. This is great. We've already been talking about performance as part of the event so far, and showing their tracking of stuff is just wonderful. And then coffee over there. Let's head on outside and see what's going on in the sunshine. It's an absolutely beautiful day in Amsterdam, which is getting people outside and in the sun, which is it's pretty cool for developers. We're walking into people, it's great. I want to say hi. Do you want to say hi to this is just the scene. You having a good day at JSNation so far?
Yes.
Learned anything good?
Everything was good.
Everything's been good.
Yeah.
Excellent.
Perfect.
Awesome. All right. Let's go see what's going on over here. We've got food trucks and people just hanging out, sunglasses in the sunshine. You would almost wouldn't think it was a developer event going on right now because everybody is just enjoying the sun. And I love that. I'm going to bust into some more people. Hi, anybody want to be on camera? Say something? Don't want to be? No, let's move it on. Whoa. Right, let's head on this way. I'm going to go backwards because we're going to say hi. How's everybody going? Having a good day? Do you want to say anything on camera?
Hello, Australia.
Say, you just got here?
Yeah.
Okay. Well, you're enjoying the sunshine at least.
Yeah, of course.
All right. I'm excited about, what's the next talk you're excited about?
The next talk, we are going AI in the browser.
AI in the browser, Thomas Steiner. Yes, awesome. I'm going to be there too. That's going to be great. I'm looking forward to that. I'm talking about that stuff myself later. Come see that later.
Really?
Yeah, upstairs. After lunch, 2:10.
Okay.
Come see my talk about AI in the browser. Yes.
How do you have so much energy after such a flight?
How so much energy after such a flight? Because this is a place full of energy and community.
Yes,
and
I
so
remember
it should
from
be.
2 years ago.
Yes. Look, you got to have energy at a place like this because there's so much.
Absolutely.
Everybody's bringing the energy. That's what's going on.
Yeah, definitely. Cool.
What are you excited about seeing now?
So I want to see Tobias Cooper's one.
Tobias Copers? What's he
Yeah.
talking about?
Turbo Pack.
Turbo Pack. Yes.
Yeah.
Awesome.
You see, I learned the schedule.
Yes. Cool. All right. I will leave you for now. We're going to go this way. Okay, we got a sweet station out here. So this is all new to me. I haven't even been out here yet, so it's great to see what's going on out here. There's foam bananas and cherries and stuff like that in the middle. But it's just so good to see everybody in the community just kind of talking and chatting with each other together and finding out what's going on and hopefully learning from each other. That's kind of all of what this is all about. You having a good event?
Yeah. And the last talk about the performance was amazing from
Yeah?
the guy from Microsoft. Yeah, I really like it.
That's Alex Russell, right?
Yeah.
Yeah, fantastic. Are you going to go change anything about your applications on what he said?
Probably yes. I will bring it to my team and said, guys, come on, we don't want to use iPhones anymore. Let's go for low budget devices and let's try to increase our user engagement. So,
That's fantastic. Yeah, no, I have a Motorola G4 at home, which is a terrible device, but wow, it's good for testing on. Yes, I think there's an Alex Russell approved mobile device. Awesome, thank you, thank you. We're gonna go back inside. Let's go back inside and see what's going on right back over there. Come with me. I'm just blown away by everything going on out here. It's so nice to just see everybody having a great time. Thank you. Okay. Right, we're going to head back inside. I'm going to eventually get a coffee myself because this is, as I said, it's coffee break right now. There's people enjoying their times and caffeinating up because there is a lot more event to go. We've got 3 more sessions, a lot more content to talk about. Let's head on around and just see. We've got one more sponsor over here in the corner, Sentry, who are doing great things also for application monitoring. So we've been talking a bunch about performance already this morning, and so monitoring those kind of performance and then errors, of course, is super important. And so if you're watching this and you're not here, you really should think about coming another year. Like, JSNation is an incredible event, and we would like to invite you to the next one, of course. Then, of course, tomorrow is React Summit. That is going to be an enormous event too, talking about everything in React that we need to know. And you should be there for that too. But hopefully, if you are enjoying this online, there are online talks to be watching as well, and that is for you too. So it's been wonderful running around and talking with you here at JSNation. I'm so sorry, and like I said, I invite you to the next one. Enjoy all the online talks, and thank you so much for exploring the conference with me. Thank you.
What will I build today? Whatever it is, it has to be smart and connected. An app, an experience, a company, my company. Whatever it is, I'll need the right tools, all the tools. I don't want anything holding me back. What will I build today?
AG Charts is a modern open source charting library built for TypeScript, React, Angular, and Vue. Get started by simply providing your data, defining your series type, and then creating a chart. AG Charts provides over 25 different chart types, enabling you to visualize your data in any way you need to, from simple to complex. Learn more and get started for free at aggrid.com/charts.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
because they make up everything.
Now, tell me the capital of France.
Of course, the capital of France is Paris.
Now, I want you to roleplay a sentence, and I will be able to ask you
Ho, ho, ho! Merry Christmas, little buddy. What can I bring you this year?
I was hoping maybe a lump of coal.
A lump of coal? That's a bit hard, isn't it? How about a nice, warm, cozy blanket instead?
That'll work too.
Perfect. I'll make sure to wrap it up nicely for you.
Alrighty, welcome back everyone from lunch, and also a big welcome to our audience that is joining us remotely. Let's wave to the camera, Scott. Hi everyone sitting on your couch or joining us from your office maybe. Yeah, welcome to JS Nation.
Yeah, let's do another set of introductions. My name is Scott Talinsky. I am the co-host of the Syntax podcast and an executive producer over at Sentry. So if you like web development challenges and fun educational stuff, check us out on YouTube.
All right, and my name is Floor. I live in the Netherlands, and I work for a big Postgres company called EDB. So if you love talking about Postgres, if you're using Postgres, let's chat today.
So let's have a look at the stuff we're going to be doing as we go on today. Please note all of this info can be found on our website, JSNation.com.
Perfect. So today's speakers will have Q&A sessions on stage right after their talks. So please use Slido to ask your questions. That goes for our remote audience as well, of course. How this works is you go to Slido, you enter the code 0612, or 0612, ask your question, and make sure that you start with the name of the speaker that you're asking your question to, so that we can make sure that you're in the right track and we're asking the right question for our right speaker.
After we had a Q&A on stage, the speakers will have a separate Q&A in a hybrid format, so please join them and talk to them on Zoom. If you're here physically, the Q&A spot is located on the first floor, which is the balcony, when you make your way to the residence track.
Perfect. And in our schedule, we also have a couple of discussion rooms planned. Those are hybrid as well. The first one coming up is 2:45 is Can Vanilla JavaScript meet today's demands or not yet? And at 4 p.m., we'll have AI and the modern developer. So for our remote audience, to participate, you join the Zoom link on the watch page where you're also following this stream, so it should be easy to find. And for our in-person audience, everyone here, you go to the right corner of this ground floor.
And a little bit about the navigation online and how to join this or that activity. If you're watching the conference from home, you can see 2 tabs with 2 tracks, a video player and a timeline underneath. You select the activity you would like to do, and you'll get to the right place immediately, be it a Q&A session or a discussion room.
Perfect. And we want to see your posts blow up all over Blue Sky, LinkedIn, Instagram. You can use it to use maybe pictures that you were taking today or anything that you're learning today. And if you're watching remotely, show us how you're watching. Maybe you have a perfect setup with snacks at hand. Make sure to share that with us as well. We love to see those kind of posts. Make sure that you use the JS Nation hashtag so that we can find your posts.
Be sure to join the Discord server. Find the link on the website or the email you received from the organizers. Joining Discord means you won't miss any announcements, and as a bonus, you'll get to hang out with remote speakers and attendees.
Fun. And as always, we want everyone to feel safe and have a good time during the event. We have a code of conduct that is available on gitnation.com/COC. Please go read it now if you haven't already. And at any time, if you feel like something's happening that is not quite right, you can send an email to coc@gitnation.org, and we'll take care of it right away. We do not tolerate harassment in any form in any of our channels, so that also includes Blue Sky, Twitter, and the Discord server as well.
If you're in the market for a new gig, don't raise your hand, but check out the open positions on our amazing sponsors Promote at jsnation.com/jobs.
Exactly. And if you're on the website already, make sure that you check out all of the digital perks that we have as well. The sponsors offer really great swag.
Feedback is a gift if you're in the giving mood, and you think you know what will make this event even better, please share your thoughts. So navigate to jsnation.com/feedback to find the form. We'll duplicate it at the end of the day via the newsletter if you missed it.
Perfect. I think this is you.
Well, thank you very much. So before we introduce our next speaker, let's meet our gold sponsor, Fusion Auth. Fusion Auth is a developer-first, customizable customer identity and access management platform that makes outsourcing authentication feel like a first-class experience. Don't forget to pass your questions via Slido during the talk, and we'll ask them after the talk. Slido code 0612. Our next speaker is Joshua. Joshua is the creator of Transformers.js, bringing the power of machine learning to the web. His talk, Transformers.js, state-of-the-art machine learning for the web. Learn about Transformers.js, an innovative JavaScript library for running state-of-the-art machine learning models 100% locally in your browser. Joshua, the stage is yours.
Hi there, everyone. My name is Joshua, and I'm really excited to talk to you today about Transformers.js. So first up, a little introduction. Starting with who am I? Well, I'm a 25-year-old machine learning engineer from South Africa, and one of my main goals when I joined Hugging Face in 2023 was to bring the power of machine learning directly to the web and to your browsers. One of the missions at Hugging Face is to democratize good machine learning, and incorporating and expanding our Python libraries and our ecosystem on that front to the JavaScript developer community was really important, and that is where this project came from. So, and lastly, I'm very passionate about open source. Creator of, Transformers.js, Kokoro.js, Ginger.js, I think you see a pattern there, and a few more. So maybe a quick step back. What is Hugging Face? Well, Hugging Face is a platform where the machine learning community is able to collaborate on models, datasets, and applications. We have a very large community, a very large and growing community, and if you have any models, datasets, or spaces, or applications as we like to call them, we'd love you to join and share those demos on our platform. So yeah, if you want to search for models on the Hugging Face Hub, we have around 1.7 million pre-trained models that you can search for, with a bunch of filters and tags that you can select to basically filter down your search from the 1.7 million to something you're really looking for. It stays up to date, and of course you can select the Transformers.js library tag as well to ensure that you can see which models are compatible with the Transformers.js library. We also have a large selection of datasets. So in this demo, you can see that if you have a dataset you'd like to view, you can go to the dataset viewer and then even interact with it with natural language, and then that'll be converted into a query where you can basically select data in an interactive way from the dataset. And lastly, spaces, which is what we call our application directory. You can also search for, if you want to, let's say, generate a 3D model from an image, then you search that in the interface, and it'll pop up with something that you can use. And this is where our community really shines. We have a very large community of people who really want to showcase their applications, the models that they've created, and this is the best way that people have been able to showcase their models directly from the browser. And we also maintain a large collection of open source libraries. You may be familiar with the Transformers library, diffusers, safe tensors, tokenizers, just to name a few. But today we'll be focusing on one in particular, Transformers.js. So what is Transformers.js? Well, Transformers.js is a JavaScript library that allows you to run state-of-the-art pre-trained models directly in the browser. The goal is to make it extremely easy to use, allowing you to create and add machine learning functionality directly into your web applications with as few as 3 lines of code. Of course, I mentioned before, we're fully open source, publishing everything on GitHub, and it's very community-driven development. So people would like a feature request, they make open up an issue on GitHub. We love the community when we're able to collaborate in that way. Just another indication of the growth over time. So this is our unique monthly users of the Transformers.js set of models. We're at around 1.4 million unique monthly users currently, and this is basically up double from what we saw around 6 months ago. And the trend is continuing upwards. We're really, really grateful for the support and the people who have been able to create really cool applications with the library. And also, just a little bit of development timeline for those interested. It's a relatively new project, so the idea was basically to, the origin of the library was to basically take a pre-trained spam classifier that I had created in my spare time, and I wanted to run it as a browser extension. Unfortunately, nothing really existed at the time to allow me to do so. So the next logical step was to do it myself, to basically try get my pre-trained model in the browser. There were luckily a lot of really great libraries that I'll tell you about shortly that really allowed me to put everything together in a way that allowed me to run the model in the browser. The V1 release of Transformers.js happened in March of 2023, and at that point, we only supported around 5 different architectures, but as you'll soon see, the number slowly and then quickly started to grow. So next V2, the next logical step was to do a complete rewrite from CommonJS to ECMAScript. And at that point, maybe 2 months later, we were at 19 supported architectures. And then V3, which is our largest release yet, was basically introducing WebGPU and WebNN support. And then we were able to support 119 different architectures. And then where we are currently, we're at around 155 different architectures, and there's a lot of things planned for the library, which I guess I'll cover shortly. And once again, just a huge shout out to our community all over the world, creating demos, contributing to the library, and posting to social media about what they've created. It's really, really, really great to see from our side as well. So thank you. And one more set of slides on statistics. We're at around 1 million NPM downloads in the last 30 days. And at the bottom, number of JS deliver CDN requests for those who don't want to install via NPM. So what can Transformers.js do? Well, we support a variety of tasks. We like to classify them into text, vision, audio, and multimodal tasks. And you can see some of the lists here. Like I mentioned before, we support around 155 different architectures across 27 different tasks. So whether it's text classification or, let's say, speech recognition, text-to-speech, those kinds of things. And we have around 1,850 ready-to-use models on the Hugging Face Hub. So as you'll soon see, you just have to replace the model ID with a model that you like or that you're fine-tuned, and you're able to hopefully run it in the browser. We also have really great integration in different browsers. So Chromium-based browsers have really good WebGPU support, for example. So Chrome, Edge, Brave, browsers like those. Transformers.js actually powers the the Firefox AI runtime in collaboration with Onyx Runtime. And then lastly, Safari, which actually just a few days ago announced that WebGPU support will be shipping in Safari 26 beta. And that means that it will be able to run Transformers.js models in Mac OS, iOS, iPad OS, and even Vision OS, which is really exciting. Just a few benefits of why you'd want to run models in the browser. So number one, security and privacy. Since none of your data, and especially none of your sensitive sensor data, like microphone or camera input, gets sent to a remote server, everything happens locally. Of course, real-time applications is a huge benefit because there's no network latency. Let's say, for example, real-time background removal, you don't have to send a picture of your screen every single frame, which would just be completely it just does not make sense. And then lower costs, both for developers, because they don't have to pay for inference or server costs, and then also for the user, where you're using your own compute, so you don't have to use API keys or anything like that. And then I think a huge benefit of distributing over the web is that it's highly scalable. All I need to do to share an application with everyone in the audience today is to give them a link, and they can run it on their device. And another reason, like you may have seen a few days ago, is when OpenAI or ChatGPT was down for quite a few hours. So that's another benefit of running on device. And then also, we greatly benefit from the versatility of JavaScript. So as I mentioned, we're able to run in browsers. But that's only one part of the story. We have support for, you can run in Node.js, Bund, all these different runtimes, your favorite libraries or frameworks, whether it be React, Next.js, Svelte, Angular, all of these. And then we have support for different build tools, I guess. And then, of course, the environments, where you can basically, if you want to run in a web worker, as a browser extension, serverless in maybe like super-based edge functions, or desktop applications with Electron. Those are all possible. We're also working on native web GPU execution in collaboration with Onyx Runtime and Onyx Runtime Web, which will greatly improve support for GPU-accelerated applications, for example, in your Electron applications or let's say an edge function. And then another goal of ours is to be able to implement and run in React Native with GPU support as well, but those are some things we're working on. Quick slide on how does it work. So you first take your model that you've either trained in Python land, or you can use one of our pre-converted models. And there's a few sets of libraries like Optimum or Onyx Runtime GenAI that you can use to convert your models from PyTorch, JAX, or TensorFlow to the Onyx format. And Onyx stands for Open Neural Network Exchange. It's basically a format that allows for highly interoperable machine learning experiences. And then you write your JavaScript code. So in this case, just a few lines of code to run Whisper. And then behind the scenes, it uses Onyx Runtime to be able to run your model in either WebAssembly on CPU, WebGPU on GPU, or with WebNN on CPU, GPU, or NPU. So let's see how you would start maybe adding ML to your web applications. So just a few lines of code. Number one, you import the library. Number two, you create a pipeline. And then number three, you run it on some input. And you're also able to specify a custom model. So as your second parameter to the pipeline function, you can specify the model you'd like to use. And then some other options. So you have the initialization parameters. So if you want to specify whether you want to run on GPU, so web GPU, as well as quantization settings like Q4, F16. That's in the first step. And then in the second step, add a runtime parameters like the maximum number of tokens that you'll be generating. A quick little overview of what WebGPU is. It's meant to be the successor to WebGL and is a new web standard that allows you to run it's a modern API for accelerated graphics and compute. And more importantly, it's a general purpose API, which means that we can run machine learning operations, which is really, really important. And you can enable WebGPU support by just specifying the device as WebGPU. It's a little bit limited availability, as I was mentioning earlier, but we hope to see browsers move towards better support in future. And then WebNN as well. You can also specify the device by saying WebNN, either maybe if you want NPU, GPU, or CPU. You can also specify that in this case. And then a quick slide on what quantizations. You can because it's very important, because browsers are extremely resource limited, we encourage users to quantize their models and reduce the precision in exchange for lower resource consumption, lower memory consumption, and lower bandwidth to the user, because they need to download it once, and then lower memory consumption at runtime. And then we also expose different maybe APIs that users would like to achieve a little more control. So for example, a segmentation demo like this. Maybe some factors to consider as you are developing for the web. Bandwidth is important, so the user needs to download the model once, so you encourage them to choose models that can run on the target hardware. Accuracy versus speed, what level of quantization are you going to use, and what latency and precision is required. Device features, what browser APIs are required, maybe microphone input, and WebGPU support is one of the top ones. And then target devices, are you building for mobile, desktop, and anything in between. Maybe just a quick run through of some applications that you can build. So of course, privacy-focused chatbots. Being able to run LLMs in the browser is maybe not new now, but the performance we're able to achieve is quite remarkable, especially on WebGPU. So in this case, a 4B model running at around 90 tokens a second on an RTX 4090. And then on this Mac here, running a 1.7B model at around 130 tokens per second, which is really great to see. Really major improvements, and major improvements still coming. We've got, with the native WebGPU, I think there's a lot of improvements that we can still make. Real-time captioning, which is an example of taking a webcam input and using a vision language model to describe what you're seeing. We're using small VLM, which is a model that Hugging Face created. And then we also support reasoning models. So if you want to enable like DeepSeek R1, this is a distilled version of DeepSeek R1. And it actually performs, according to their benchmarks, at the same level as GPT-4o on different math benchmarks, which is very surprising to see like a 1.5B model performing at the same quality as some of these much larger closed source models. And then multimodal applications, so basically having text and image input, and then text and image output. So in this case, generating an image of a fox, like this is running locally in the browser. And you can also take an image and then, let's say, convert this image of LaTeX to the LaTeX code. Various other multimodal applications, like captioning, we also support. Speech recognition with models like Whisper is a very important and powerful, but also popular use case that people have been able to develop cool applications with. Text-to-speech with models like Kokoro, which in this case is a very small 82 million parameter model. I'll play a quick demo of the quality.
Kokoro is an open-weight TTS model with 82 million parameters. Despite its lightweight architecture, it delivers comparable quality to larger models while being significantly faster and more cost-efficient.
And so significantly better than maybe the robotic voices that you might be familiar with traditional browser APIs. We also have background removal models, which, like I mentioned before, it is one of those canonical examples of why you would choose in-browser inference. Image editing with models like Segment Anything. This is, people have actually been able to create Figma plugins that utilize Segment Anything. And in this case, it's only around 15 megabytes in size. So being able to run that in the browser locally is really great. And this is running in real time here. We also support a bunch of educational use cases, so being able to visualize the attention mechanism in vision transformers, being able to see what the models are focusing on. That's another example. Everything's running locally. And other educational tools like tokenization, like how tokenization works. Being able to run that locally is also a great use case. And also being able to visualize the models. So if you want to, I'll skip forward a bit, being able to dissect and really go into detail of what the models are how they're built. And this is powered by Netron. We also support mobile and desktop games. So in this case, it's a simple image classification model. And so you draw to a canvas, and then the model predicts what you're drawing. And the goal of the game is to, it's similar to Google Quick Draw. So it's the goal is to draw as many items as you can in an allotted amount of time. Another example, object detection. We have depth estimation, many normal vision applications. Music generation is another one. Quick sample, some lo-fi music. And one other one I would say is very important, and it's a very simple use case of semantic search, taking raw data, whether it's image, as you can see on the left, or audio, and being able to convert to embeddings, and then being able to do semantic search at runtime. And then this is a demo, the most recent demo, which is a conversational AI. And we will try run this. I remember what I think a previous talk with Thomas was, if the demo works, we applaud, and if it doesn't work, we applaud louder. So let's see if it does work. We're going to pull it up.
Hey there, my name is Hart. How can I help you today?
Hey there, I'm on stage at JSNation. Can you tell me a joke?
Sure, here's one for you. Why don't programmers like to watch old movies? Because they're too bugged to sit through.
Okay, now can you tell me what the capital of Netherlands is?
Sure, the capital of the Netherlands is Amsterdam.
And now I want you to roleplay as Santa, and I'm going to be a little boy asking you for a gift.
Okay, I'll be Santa. What kind of gift are you looking for?
Could I have a lump of coal, please?
I'm sorry, but as a character, I can't actually give you a lump of coal. But I can tell you that in the world of ice hockey, a lump of ice is a crucial part of the game.
The more you know. And one last live demo I'd like to show is using a small VLM running in real time. So what I'm going to do is click Start here and ask it, what do you see? And in this case, it says, with his hands on his chest, word hugging face on the shirt. I guess that seems right. So that's great to see. And let's continue. I think 1 or 2 more slides. Just some final thoughts. I would like to say that there are endless possibilities, and I guess would want to encourage you to maybe explore with in-browser, on-device machine learning, and be able to share what you create. We'd love to see it. And the last, if I leave you with one thought, it's always bet on JS. As Brendan Eich would say, first they said JS couldn't be used to build rich internet apps. Then they said it couldn't be fast. Then they said it could be fixed. Then it couldn't be multi-core GPU. Wrong every time. So his advice, always bet on JS. So naturally, I quote-tweeted him and said, then it couldn't run LLMs. Wrong every time. And he seemed to like that. So I hope we're on the right track and being able to build cool demos with browser AI, and we'd love to see what you build. So thanks so much.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
With Datadog, you can monitor your infrastructure, apps, and security posture in one place. Instantly visualize your ever-changing infrastructure. Follow request traces through distributed environments, and get code-level visibility with always-on production profiling. Cut through the noise with automatic anomaly detection, and discover bottlenecks by mapping service dependencies. Datadog ingests all of your logs from any source, helps you optimize front-end performance, and secures your production environment with real-time threat detection. See inside any stack, any app, at any scale, anywhere. Join thousands of customers who rely on Datadog for full stack visibility. Start a free trial today.
What will I build today? Whatever it is, it has to be smart and connected. An app, an experience, a company, my company. Whatever it is, I'll need the right tools, all the tools. I don't want anything holding me back. What will I build today?
AG Charts is a modern open source charting library built for TypeScript, React, Angular, and Vue. Get started by simply providing your data, defining your series type, and then creating a chart. AG Charts provides over 25 different chart types, enabling you to visualize your data in any way you need to, from simple to complex. Learn more and get started for free at aggrid.com/charts.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
All right, it is time to meet our gold sponsor, CodeRabbit. CodeRabbit delivers context-aware AI code reviews that merge your PRs 4 times faster, reduce bug count in half. It's also available for free for open source. Don't forget to pass your questions via Slido during the talk, and we will ask them after the talk. Slido code 0612. In the meantime, our first discussion room will start in a moment, and we will run in parallel with our next activity. So feel free to join the room on the ground floor in the right corner or on Zoom if you are a remote attendee. Check the link in the timeline below your player. All right, and our next speaker, Ali Lagat from AG Grid. And his talk is Ally and Interactive Canvases. Learn how to leverage the DOM tree structure to allow users to interact with your canvas using the keyboard and a screen reader. Find out about tricky gotchas and how to work around these. Ali, the stage is yours.
Here we go. Okay, cool. Here we go. All right. So thank you, everyone, for coming here today to watch my talk about accessibility and interactive canvases. So just a real quick introduction. My name is Ali. I'm a former game developer. I have worked with Lara Croft and Sonic the Hedgehog in the past. Great people, by the way. I love them. Nice people. And so now I work at a company you may have heard of called AG Grid. And I work on the team which does the charting component. So here, this is basically our website. I'll just quickly show you what it is so that we're all on the same page. So essentially, yeah, it's a framework-agnostic library for drawing charts, such as bar charts like this. We also can draw financial charts. We also have some map charts here as well. All different types of charts. One of the key features of our library is that it is rendered using a HTML5 canvas as opposed to an SVG, which is what most other charting libraries uses. There are some few exceptions. So as you can see, like this toolbar here, those are just regular HTML5 buttons. But specifically for this talk, I'm going to focus on the canvas rendering part of AG charts. So the problem space that we're dealing with is when you're rendering a chart, the big question is, should I be using an SVG image or should I be using a canvas? I'm sure most of you are already familiar with the concept of these two, but just to make sure everyone understands, let's quickly go over the two, like the pros and cons. So an advantage of the SVG is that, so that's basically a vector-based rendering system. It's rendered by your layout engine like Chrome or Safari. And it has an XML hierarchy where all of the shapes and everything are defined by some XML tags. Canvas, on the other hand, that's just a single HTML element. And the JavaScript developer is responsible for writing all the rendering logic for actually drawing the code. And so you don't have a hierarchy. You just have that single element. The two are basically very, very similar to one another. So as you can see, these two images, they're exactly the same image. One of them is rendered by an SVG where you say, OK, I want a circle here, I want a rectangle here, and I want a polygon. Same thing here with the canvas, but it's written in JavaScript as opposed to XML, where you're saying I want a circle, a rectangle, a triangle, and so forth. And so the main advantage of an SVG is that because you have these XML tags inside your DOM, you can basically, as I'm going to show you right here, if you inspect here, you can set some additional attributes onto the elements. So for those who aren't familiar, there is this concept called aria, where you can basically say, for example, raw button. This will tell the screen reader to treat this element just like if it was a regular button. Let's try to see what happens now if we turn on the screen reader.
VoiceOver on Safari, comparison. Button, less than, button, 3 items, button, button, button. You are currently muted.
So, as you can see, because now I've set those roles on those XML attributes, the screen reader is able to pick it up and says, OK, these shapes are actually buttons, so I'm just going to treat them as buttons. Then you have to add other handlers like the keyboard and mouse input handling. But you can basically tell the screen reader, here, this is what the buttons are. We cannot do that with the canvas because it's just that single element. So how did I get around this? Well, basically, the solution that I found was to just, quite simply, hide the canvas. Well, not completely hide it, obviously. We still draw it on the screen. But there is this attribute called aria hidden. We set that to true to tell the screen reader, just don't pay attention to this canvas. Nothing important here. And then what we have is we've got this concept called proxy elements. And that's essentially just some HTML elements on top of the canvas, but they have transparent background, or they're not drawn. They're there in the tree, and they're there in the DOM, but they're not drawn. So like if I were to show you here, I can basically mimic the same result I had before with the SVG. If I were to go here we can do the same thing we had before. Let's set the role to a button. Now let's do the same thing as well with the other ones. Yes, here we go. And then here as well with the triangle for completeness. Cool, now let's go back into full screen and try this out.
Aria hidden, true, heading level 1. The solution, hide the use of after, button, 3 button, button. You are currently on a button inside a group.
So
to click this button, press Control, button.
That is the core of, oh dear, that is not what I wanted to do.
Safari, dialogue.
Sorry about that.
VoiceOver off.
OK, cool. Yeah, so basically, that's the core of how I've implemented accessibility on a canvas. It's just basically completely hide it and re-implement the entire tree and say, this is where all the stuff is, basically. So let's talk a little bit more about these proxy elements. What are the key elements of it? So the most important thing is you must not set the display to none, and you must not set the visibility to hidden. because these two properties actually remove it completely from the DOM, and they remove it from the accessibility tree, and then your screen reader is just going to ignore that completely. So we don't want that. Instead, what we want to do is you want to set like a transparent background, so like opacity 0, or you can set background to just transparent and make it a transparent color. Then another thing you want to do is you want to make sure that your proxy elements will have a focus indicator. This is important because some of your users may not necessarily be using a screen reader, but they still require to use the keyboard. You can think of someone, for example, who has like perfect vision, but they've got some sort of mobility impairments. And so it's important to make sure that we also style it, to make sure that we have like some focus indicator to tell the user what they're currently using. And then the main positioning we want to use is position absolute with a container that's common with the canvas, so we can make sure everything aligns up properly. So here, I'll show you an example. I've set here this property here, focus visible, and that tells it to show it when I'm using a keyboard, but not when I'm using the mouse. So here, if I were to click on here, you see it says I've clicked a square, I've clicked a triangle, I've clicked a circle. But if I then press the tab key, here my browser automatically detects, oh, now you are a keyboard user. So it's started showing the focus indicator around it. And if I press the space key, then yeah, then it basically clicks as I want. If I turn on the screen reader,
voiceover on triangle,
it also
button,
properly tells me triangle, square, circle. In this example, I also added some text to these buttons so that it actually tells me what it is that's going on. Let's have a quick look with an AG chart. So here is a very, very simple chart. I say very, very simple because it's not actually a chart. It doesn't have any data. But the reason we don't have any data is that we don't really use this technique for the data. We use a slightly different technique that I'm going to get into. But we do use this technique for the legend. So that's what I'm going to demonstrate. So as you can see, if I press, I can basically click these and something happens. Well, nothing really happens. It just fades in. But yeah, I can click these buttons here. I can also use it with the keyboard. As you can see, there's a focus indicator that's telling me which element I'm currently using. And it works very well with the screen reader as well.
Voiceover, next legend page, button. Now search text field. Oops. You are currently find the downloads.
No, thank you. Don't look, that's
dialogue.
Confidential.
Next search text. You are currently on a mission
no,
control.
Close your eyes, close your eyes, close your
Safari,
eyes.
dialogue, entering legend, leaving next legend page. But search text field. You are currently on find a search
I think it's because
someone.
Okay, basically,
previous
if you
legend
press
page button. You are next legend previous legend page.
There we go. There
button.
it says dimmed.
You are currently
as you can
on a
see.
button. Next
this
legend
one
page.
it says not
button.
dimmed.
Previous entering legend
and then you go
series
here.
6.
Every time that I press
Off on series
on off. Okay, now you shut up before a bit. Let me talk. Okay. Yeah, so basically, as you can see, I think you've sort of seen the concept. Every time you move around, the screen reader talks very, very assertively, like, this thing is going on, this thing is going on. But that's actually very good, because if you've ever seen a blind person using a computer, this is the madness that they have to deal with, just like, so that's good, that's nice. We've got a very responsive screen reader that responds to the input and output, so that's very good. So like I said, like you see, that chart didn't have any data. And the reason for that is that these proxy elements, they work well for UI components that don't update much and they don't move around so much. And they work very well for UI elements that already have some sort of area predefined semantic in the spec. So that example that I showed you, the legend items, those are just switches, which is a button that also has an on-off state. And then the pagination button, left, right, those are just regular buttons. So it works very well for that. Wait, oh, someone's sending me a Slack message. Okay, ignore that person, that's not important. But it doesn't work very well if you want to have like a completely customized control. That's one of the advantages of a canvas, is you can kind of draw whatever and just make up new controls. So let me show you a very simple example. So here I've got this new UI control that I've invented. It's called the ball. It goes to the right, and it goes to the left as well. So that's all it does, basically. It's a very, very simple control. But let's see what happens when I turn on the screen reader.
Dialogue, interactive canvas, new position 3, position 7, position 2, image, position 1, image. Voiceover off.
Okay, that's a very, very straightforward example, but it's pretty cool. Every time the ball moves, it tells me position 1, position 2, position 3, 4, 5, 6, position. So that's nice, cool. It's like every time the ball moves, immediately the screen reader is telling me what's going on. That's nice. So what's going on here? So basically, the trick that I'm using here is that I'm treating the screen reader announcements just like a video stream. Like I said before, I'm a former game developer, and so if you're not familiar with how video rendering logic works, we typically will use a data structure called a swap chain, which is basically just two images. So one image is drawn onto the screen, onto the display, and another image is hidden somewhere in the back, and the graphics card will be drawing on that image. And then when the next frame is ready, you swap around the purpose of those two images. That new image comes shown in the front. Then the old frame, the old image can be reused, and the graphics card can then draw the next frame. That's the exact same concept that I'm using here. So I've got two proxy elements. I've got one that's always visible to the screen reader, and another one that's always hidden. But it's there, it's ready. I can update the text value and make that one visible whenever I want. And the method that I use for swapping these buffers is the focus method. The reason why this works very well is that, well, first of all, a canvas, you can kind of conceptually think of it like a video feed, because basically you draw something, and after a certain amount of time, maybe after a few milliseconds or after a few hours or whatever, it draws another image. So it's kind of like a video feed in a way. So this mechanism we're using, it syncs up very well with the update pattern of the canvas. And another thing that I noticed is that assistive technologies such as screen readers, they handle focus changes very, very, very well. Like I had tried different approaches, such as using an ARIA alert or having an ARIA label that you update occasionally. But there was always that odd one out, that odd browser that wouldn't work, or that odd screen reader, or that platform. Like there was always something somewhere not quite working. But the only thing I found that works very, very reliably is focus changes. This works on every single browser, on every single screen reader, and on every single everything that I have ever tested. So let's kind of have a look at this demo a bit to understand what's actually going on. So let me just walk you through the code. So here we've just got some input handling, and we draw the ball. The rendering logic isn't important, so I'm not showing that. And then what we do here is the actual swapping. So we swap around the purpose of these two proxy elements that we've got. And then what I do is the new one that's about to be shown, I update the text value, the ARIA label of the announcer, and I set it to visible. And then the other one, I set that to invisible. Maybe let's make it hidden. And then we do the focus, which is actually the swap. And so let's have a look at what happens when that moves around. So the main thing, the first thing you want to look out for is this style property. So you'll see one of them is always on display block, which means visible, and the other one is on display none, hidden. As you see, as I move left and right, these keep switching back and forth, block none, block none, block none, block none, block none, block none. The next thing you want to look out for is this text value. So I always have to update the text value of the next one I'm about to show. So here, if I want to go to the right, I need to update this to position 2. Now that becomes visible. I want to go to position 3. I have to update this one, position 3. But oh, I pressed the wrong button, that's why. OK, position 3. Then you press again. That one goes to position 4, and so forth. And so that's basically the mechanism we've got. We've just got a stream of announcements that we keep swapping back and forth, and so they will assertively keep announcing things. That's very cool. I like that. That's nice. We've got a really good product here. But we can do better. As I've said before, it's very, very important to make sure we have a focus indicator. So we can use that focus visible property that I was mentioning a while earlier. Just a quick reminder, the focus visible pseudo class, what it means is, if you read the spec, it's like loads and loads of lots of words. But roughly what it means is like hide all of this stuff for a mouse user, but show it for a keyboard user. More or less. That's more or less what it means, right? So we're going to use this pseudo class and add some stuff in there to show a focus indicator. And we can use any kind of shape we want. A square, a rectangle, a circle, a Pikachu, anything we want. Like, it's amazing. It's great. Let's have a look at that. So here we go. Same demo as before. The main difference is, you see, I've set my announcers to be invisible, opacity 1. However, when focus visible is enabled, I want that to be visible. Then I've got some styling here for a focus indicator. And what I've done here with my announcers, the only difference is I've added this child element, which is the focus indicator, which means when one of these announcers comes into focus, if necessary, we will also show a focus indicator. So basically, if I were to click this with the mouse and then move left and right, this is the same thing as before, but nothing really is happening because I'm using the mouse. But you will notice that here, these bounds are being updated. And that's because I'm updating the bounds of a focus indicator that's currently not shown. But if I click here and then I press the tab key, wow, look at that! It's a circle and another circle. Wow, that's cool. So I move this around, and then it tells me exactly what it is that I'm manipulating. That's very, very cool. I mean, here it's kind of pointless because we've only got one ball. But if you were to use your imagination, what if we had like thousands and thousands of balls everywhere? Like, how would you know which ball you're moving? You would have no idea. But now, we know, because we've got that little focus indicator around the ball. And it's not a square, it's a circle. That's so cool. Like, I didn't even know we could do that, but we can. So yeah, let's have some quick examples, real-life examples, not just some boring ball. Let's see what we can do. So here, let's turn on the screen reader as well.
VoiceOver on Safari.
So wait, let me
Dialog,
first show you
VoiceOver
how it would be without a screen reader. So you can click here to enable, disable some series. If I click on a thing, it tells me this thing has been clicked. Yes, OK. And with the screen reader as well, I can do the same thing
VoiceOver on
with the keyboard.
You are currently next legend page, but image. Entering legend content, leaving 2017.
Then I can press the space key and it
1.798K image.
The clicked value.
You are currently on entering legend leaving legend 2018, 2019.
And
entering
I can come
legend
here
offshore
and hide
land
these
off
things.
landfill leaving
And every time I move, it's
2017.
You see, as I said, the thing that's nice is that the screen reader is very, very assertive and responsive. Like, there's never a case where it's like not announcing something or it's waiting for some other announcement to end. As soon as I press anything on the keyboard, it will cut off what it's doing and announce what's the most recent state. And that's good, because that's exactly how you want to make it as accessible as possible. Because like I said, someone using a screen reader, they'll just be like going all over the place. You gotta be quick. I ain't got no time to waste, all right? So yeah, that's very, very cool. Let's try another example. So here, we all like a good, we all like a good, a pie or a donut, pastries. I'm more of a croissant guy, or I'm Belgian. We say coucou chocolat as well for like little bread croissants. No, wait, not bread croissants. It's a bread. Yeah, whatever. That's not important. That's not important. But basically, the main thing I want to show you here is that we really can make a focus indicator any shape we want, right? Okay. So if I were to hover over these things here, you can see, okay, the canvas is being updated. We're updating the frames because you can see that the highlight is changing. Okay, that's cool, that's cool. But if I come in here with a keyboard, whoa, cool, look at what it's doing. Look at that focus. Oh, that's like a little sector thing in this. That's like a little triangle with an arc thing. That's so cool.
60,000 image.
And we do this as, no, shut up, thanks. So we do this as well with the maps. So like if you've got a map of the USA, the focus indicator will go like everywhere. And they will do the same thing with like Brazil and then Africa and everything. And it's so cool. Any shape you want, you can do that. Because we just use an SVG image, we set that path. So that is essentially, in a nutshell, that's kind of how we have got a canvas that's accessible. There's a lot of more details and like little nitpicks here and there, but that is the gist of how it works. So I'd be happy to answer any questions you have. That's a QR code that you can or cannot scan, up to you. It's the source code for this specific slide deck that will show you exactly what's going on. The code is a little bit messy, but who cares? Whatever. We're learning here, right? We're learning. So yes, that's all. Please feel free to ask me any questions.
What will I build today? Whatever it is, it has to be smart and connected. An app, an experience, a company, my company. Whatever it is, I'll need the right tools, all the tools. I don't want anything holding me back. What will I build today?
AG Charts is a modern open source charting library built for TypeScript, React, Angular, and Vue. Get started by simply providing your data, defining your series type, and then creating a chart. AG Charts provides over 25 different chart types, enabling you to visualize your data in any way you need to, from simple to complex. Learn more and get started for free at aggrid.com/charts.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
With Datadog, you can monitor your infrastructure, apps, and security posture in one place. Instantly visualize your ever-changing infrastructure. Follow request traces through distributed environments, and get code-level visibility with always-on production profiling. Cut through the noise with automatic anomaly detection, and discover bottlenecks by mapping service dependencies. Datadog ingests all of your logs from any source, helps you optimize front-end performance, and secures your production environment with real-time threat detection. See inside any stack, any app, at any scale, anywhere. Join thousands of customers who rely on Datadog for full stack visibility. Start a free trial today.
will I build today? Whatever it is, it has to be smart and connected. An app, an experience, a company, my company. Whatever it is, I'll need the right tools, all the tools. I don't want anything holding me back. What will I build today?
AG Charts is a modern open source charting library built for TypeScript, React, Angular, and Vue. Get started by simply providing your data, defining your series type, and then creating the chart. AG Charts provides over 25 different chart types, enabling you to visualize your data in any way you need to, from simple to complex. Learn more and get started for free at aggrid.com/charts.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Let's have a quick break here before we get into the lightning talks.
With Datadog, you can monitor your infrastructure, apps, and security posture in one place. Instantly visualize your ever-changing infrastructure. Follow request traces through distributed environments, and get code-level visibility with always-on production profiling. Cut through the noise with automatic anomaly detection, and discover bottlenecks by mapping service dependencies. Datadog ingests all of your logs from any source, helps you optimize front-end performance, and secures your production environment with real-time threat detection. See inside any stack, any app, at any scale, anywhere. Join thousands of customers who rely on Datadog for full stack visibility. Start a free trial today.
What will I build today? Whatever it is, it has to be smart and connected. An app, an experience, a company, my company. Whatever it is, I'll need the right tools, all the tools. I don't want anything holding me back. What will I build today?
AG Charts is a modern open source charting library built for TypeScript, React, Angular, and Vue. Get started by simply providing your data, defining your series type, and then creating a chart. AG Charts provides over 25 different chart types, enabling you to visualize your data in any way you need to, from simple to complex. Learn more and get started for free at aggrid.com/charts.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
With Datadog, you can monitor your infrastructure, apps, and security posture in one place. Instantly visualize your ever-changing infrastructure. Follow request traces through distributed environments, and get code-level visibility with always-on production profiling. Cut through the noise with automatic anomaly detection, and discover bottlenecks by mapping service dependencies. Datadog ingests all of your logs from any source, helps you optimize front-end performance.
Here, let's get going into our lightning talks. So, here we have our lightning talks. Our first talk is from Mark Auth. Build versus open source versus buy.
All right, let's face it. Nobody, except for the CTO at FusionAuth, and maybe one or two of you out there, wake up in the morning excited to build an authentication system, right? It's a little bit like getting pumped to put a lock on your front door. Not necessarily thrilling, but necessary for the safety of you and your family, or in this case, your customers. In addition to that, logging into your application is often your user's first experience with it. It needs to be seamless, secure, and scalable. Basically, I have 3 approaches to this problem. You can build it, buy it, or use open source. Hi, I'm Marco Bastelli. I'm a developer relations engineer with FusionAuth. Been developing for over 25 years, and I love helping developers reduce the overhead of development so they can focus on the things that bring value to their application. So why authentication matters? Is anyone going to use your application just because of the great login experience? Probably not. However, authentication is the core, critical component of any system. Whether it's an app, a website, or an API, ensuring only the right users can access the right resources is at the core of digital security. Data breaches, unauthorized access, privacy violations, these are just some of the costly consequences of a weak or flawed authentication system. How costly? $100 billion. Just kidding. On average, for the global security breach, we're talking about 4 million euros. The question isn't if you need authentication, it's how you're going to implement it. Let's start with the build option. This is like cooking your own meal. You can season it, make it exactly how you want it, right? You control everything from the user experience, the workflows, to the security mechanisms. But let's be honest, it's not easy. There's a lot of things to get right. Password management, multi-factor authentication, session handling, encryption, and more. Plus, it doesn't stop after the initial build. Just like you can't stop maintaining a house after it's built, you have to maintain your authentication system. Now let's talk about purchasing authentication. This is a bit like ordering from a reliable restaurant. You don't have to spend all day in the kitchen cooking the perfect meal, picking out the ingredients, hoping it's safe, because a professional's doing it for you. When you buy an authentication system, you get a ready-made, secure, and scalable solution maintained by experts whose sole function is to focus on security. This is particularly important, like when you think about the complexities of modern security. Stuff like multi-factor authentication, single sign-on, passwordless, like these aren't real easy just to whip up yourself. Systems available for purchase feature enterprise-level security features and the flexibility that developers need. While developers may have to learn a new tool, it's generally pretty easy to integrate it into your existing system. And then customize it for your business requirements and trust that security patches, feature enhancements are all handled by a dedicated team. Now let's talk about the third option, open source. This is a bit like a community potluck. If you don't know what a potluck is, it's where everyone brings a dish to the meal and you all share. And it's great, you get to try a lot of different food and it's free. And the open source community has built a lot of powerful, flexible authentication frameworks. Stuff like OAuth, OpenID Connect, like these are widely used and trusted. And with open source, you have the flexibility to modify the system however you want. But open source isn't without its challenges. While the initial cost may be low, there's still the need for internal expertise to manage and secure and maintain it. Moreover, when something goes wrong, there's not necessarily a dedicated support team to help you out. Just like a potluck, if someone forgets a main dish, in this case a security update, you're left scrambling to patch things up. Now, when deciding between buying, building, and using open source, cost is a key factor. Building your own authentication can seem like a good idea initially, but it's high with the upfront development costs. On top of that, you have maintenance, scaling costs. This can grow into a job or several jobs. It's estimated about 1 to 2 million euro over 5 years for maintenance. Buying a solution generally operates on a subscription, which means a predictable price. Now, while there is a price tag associated with it, you're buying peace of mind. The maintenance, security updates, scaling, all handled for you. Now, a bit of a caveat here. When you're comparing costs, make sure you compare for your usage now, 6 months, a year, 5 years from now. You don't want to be caught off guard when your application is wildly successful. And open source can often look like the most cost-effective solution because there's no licensing fee. But remember, nothing comes for free, right? It's free as in beer. You can drink it, but you're responsible for it. You still need to maintain it, have internal expertise, security experts, and the cost can add up quickly. So after weighing the options, what's the right choice? Well, the truth is, only you can decide. Different companies have different priorities, resources, and needs when it comes to security, scalability, and maintenance. What works for one company might not work for another. Building your own authentication system is great if you need to take total control, but it's expensive and time-consuming. Buying a solution gives you security, scalability, and ongoing support. Open source solutions offer flexibility, but require in-house expertise to maintain it secure. Is building an amazing authentication system going to be a differentiator for your project? Probably not. So if you want to save time, reduce risk, and focus on your core business, often purchasing authentication is the best choice. Now for a quick plug, and because I'm most familiar with it, I'm going to use FusionAuth as an example. FusionAuth is a good choice because it offers many of the advantages that we talked about today. It runs locally or in the cloud, and while, like I said, it's not open source, but we do have a free edition, and we have support if you need it as well. We also have open source repositories for issues and feature requirements, so you can issue requests and follow them. I'm not saying you should use FusionAuth in every case. Again, only you can decide what's right for you. What I am saying is you should include tools like FusionAuth as part of your evaluation process when determining which is the best authentication for your application. Thank you.
Thank you so much.
You want me to grab this?
Somebody will. I think you can, yeah.
we didn't rehearse this part.
I think you can grab it, yeah.
All right.
There we go. Our next lightning talk is from Marius. No dependencies, no problem. Streaming AI over the phone.
Hi, thank you. With sound, yeah. Okay. Hi everyone, I'm Marius. I work on the developer relations team at Twilio, and that means I speak to a lot of developers who use our APIs, such as the text messaging API or the voice API. And one thing that a lot of developers recently wanted to build is an AI agent that can make a phone call or receive a phone call. Let me show you how this story often goes from a developer perspective. You have all the great models that you want to combine, one for automatic speech recognition, one for interrupt detection, then a text-to-speech model. You combine them all together, and in theory, it works nice, but then they quickly realize latency. The latency is just you say something, you wait, nothing happens, and then you say something again, and then the model starts to talk, and that kills the entire experience. So they need to find a way to work around this. And something that we provide as Twilio is that you can basically left shift a lot of responsibility on our infrastructure, such as automatic speech recognition, text-to-speech, and we work with best-in-class providers such as 11 Labs or Google Cloud to provide these services, and you just need to focus on the configuration, and what you actually need to do in the end is to host a WebSocket server that receives text, and then you can process it with your own LLMs. You can post it to a LLM that runs close to your machine with low latency, and you just stream text back. And actually, you can build an agent in 3 minutes. Let's do that together. So I use Bun to host a simple web server. You can just, for the fun of using a new stack every now and then, I expose it on port 5050. And then I have this fetch function that the only thing it does, it upgrades HTTP to WebSocket, and then I attach a data object so I can recognize the same stream again. It would make sense to use the phone number here, but I would just use a timestamp because I would be the only one calling it anyway. And then in the WebSocket configuration, I just have a callback when the socket is open. When it's closed, let's format it a bit. And then the interesting part happens here, when a message comes in. I pass the JSON payload, and then when the message is of type prompt, which it will mostly be anyway, I log this to the console, and for now, let's have a hard-coded answer to say, that's a great question. And then I log it to the console, and I just stream it back. And what I also do is I log the other types so you see them, but we don't have to worry about them for now. OK, let's give it a run. I run my server. I expose this port to the internet. And if I go over here to my configuration, you see whenever a call comes into a phone number, it connects to my WebSocket server. This is I use 11 Labs for text-to-speech, this particular ID of the voice, and this is the starting sentence. Let's call it, and let's hope it works. You should hear a ringing. Is the audio? Oh, let me maybe check.
That's a great question.
Oh. Hey, what's the capital of France?
And that's a great question.
You see, I always get the same response back. Why? Well, because I don't do anything here. I just say return a static response, but you saw how fast the latency was. So if I look at the logs, you see the text-to-speech and speech-to-text happened instantly. Okay, now let's actually involve some AI here. And if I drill down into that, let's auto-import it. You see, what do I do here? Well, I have an if statement to see, do I already know this conversation ID? If I don't know it, I just use the GPT-4o mini model. I add a system prompt and the prompt of the user. I add a web search tool, and I make sure to store the history on the server side at OpenAI. And then if the response comes back, I save it. So when I ask another question the next time, the if statement is triggered here, and then I can refer to the previous conversation, so I don't have to carry on that messages array all the time. I just have to add the most recent prompt. Let's try that again. I restart the server, call it again.
Hello, you are connected to the AI voice assistant powered by Twilio Conversation Relay.
What's the capital of France?
The capital of France is Paris.
And the one of Germany?
The capital of Germany is Berlin.
And who won the UEFA Nations League last weekend?
Portugal won the UEFA Nations League final against Spain on June 8th, 2025 in Munich. The match ended 2-2 after extra time, and Portugal secured a 5-3 victory in the penalty shootout.
So you got the idea, right? And here I was logging the response time from OpenAI to the console. You could tell when it had to do a web search, it took a little bit longer. Things you could do, you could say, oh, you could add a message like, oh, let me think about it, and then you trigger the request. So there are ways to work around it to make it appear quicker. But you can already tell basically the latency from speech to text and text to speech was basically 0, I would say. And then you only had the one from the LLM, which is probably also not the best on this network on my local MacBook. But that's my demo, and whoop, just like that, the latency problems were gone. Thank you, I'm Marius. If you have questions about this or other AI use cases with voice, our booth is up there. You can find me in the next break. Thank you.
Thank you so much, Marius. All right, our next lightning talk is from Charlie. How to build an open telemetry SDK in 7 minutes.
Reset the entire screen. Okay, let's go. I want to show you how you can add observability to your application with just one line of code. Who has worked with OpenTelemetry before? Maybe a quick show of hands. Oh yeah, not too many, but still quite a few. OpenTelemetry is an open source framework which provides a standardized set of tools and APIs for collecting, processing, and exporting telemetry data. Why do we need that? There is the notion that the more information you have, the closer you are to the truth, and the more wisdom and power you gain from it. Mapped to OpenTelemetry or to observability, this would mean that the more signals your application is emitting, the more aggregated telemetry data you have, and the more insights and actions you can take out of it. Let's look at 3 examples. First one would be an uninstrumented app, basically a black box because it doesn't emit anything. Second would be a manually instrumented app, where you, the developer, is deciding which signals you want to send to the observability backend. And third is kind of the sweet spot, where we have an automatically instrumented app, meaning you just write the application code, and some library or SDK is magically gathering the telemetry data behind the scenes and sending it to your backend. Let's look into this a bit more in detail with the example of fetch. An uninstrumented fetch call would be a basic fetch call. It fetches data, and then life goes on. Manually instrumented fetch call, in the case of OpenTelemetry, would look something like this. You have a tracer, which is an OTel component, which starts a span. A span is just a word for a single operation that is timed and that measures things. So here we start the span, we call fetch, and whenever the fetch call ends, we end the span, and that's how we measure it. You see, there's quite a lot of code to maintain, so let's look at the sweet spot where we want to land. An automatically instrumented app, where we just import our SDK, we call init, and then we use fetch as we have always done before. Let's maybe look behind the scenes of this init call. How can we, behind the scenes, make fetch emit these telemetry signals? We do this by using a technique called monkey patching, which many of you are probably aware of. It is a technique where we modify a module or a function, and we extend the functionality without updating the core functionality of it during runtime. In the case of fetch, this could look something like this. Since we're still in JavaScript world, we can basically do what we want. So we just take the global dispatch, store it away, and then override the global fetch with the tracer start span call that we've seen earlier. So every time in the user code we call fetch now, it will be traced automatically. A more modern way of doing this would be to use a JS proxy, which you can think of basically as a middleman between the function or module you want to patch and the code that is calling it. How does OTel come into play here? As I mentioned earlier, OpenTelemetry provides a standardized way of doing things. And by this, I mean tools and APIs like this instrumentation base class that you can see on top, which we just extend for our custom instrumentation. There is some scaffolding around, so we want to specify which module we want to patch. We can specify a version range, but then the important part is marked in red here, where we basically do what we've just seen before, monkey patching a specific functionality of a module that we want to trace. Coming back to our init call. This would be a very basic example on how OpenTelemetry setup could look like. It includes several building blocks. It's not too important what we're using here at the moment, but the important thing is the register instrumentations call that is marked in red. Here you see we provide an array of instrumentations, one for HTTP, one for Express, and our custom OTel instrumentation that we just wrote earlier. The key point here is that HTTP and Express are community maintained, so they are external. So that's the power of OpenTelemetry. Since it provides a standardized way of doing things, we can just mix and match community-based libraries and our own instrumentations. As you all know, JavaScript is kind of a dynamic ecosystem. And since we don't want to reinvent the wheel every time a library or a new framework is coming on the market, you could think of all of these white boxes here as its own SDK. And each SDK comes with its own default set of instrumentations. So again, OpenTelemetry here can provide a better way or a way of improving the observability data within the ecosystem. Imagine you have a new framework that's, or library that is coming out. You can just pick the parts you need, and you have a standardized way of instrumenting things out of the box. So what did we learn? OpenTelemetry provides a standardized way of doing things, which is why we can trust what we can trace. Building SDKs can be quite hard, so you have to make sure that you can only use what you can really maintain. So pick the right tools. And last but not least, observability is important, because you can only fix what you can actually see. Thank you.
Thank you so much, Charlie.
Thanks.
Our next talk is by Jeremias, The New Defaults of the Modern Web.
All right. Reset. Oh, it's back on purpose. Yeah, it's all good. Okay, thank you. All right. I will start with a really short and fast retrospective on my career, because right now I'm doing documentation and dev stuff for Storyblog. But like more than a decade ago, I was working for marketing agencies on a lot of different type of websites. Some of them were landing pages. Actually, my first project was the Microsoft Windows 8 launch landing page. That's how you can tell that I'm really old. Also did like brand guidelines. Promotional and movie sites, some of these movies were like really well known. Can't mention right now, but after the talk you can come and ask me. And probably my favorites one were like social initiative programs. These sites were super different visually and on design, but on the bare bones, they were actually quite similar. And we were doing the same thing over and over again. These experiences were really scrolling immersive sites. You would get like full height panels. And when you scroll, you would get these kind of indicators because you could never see below the fold that there was more content to be explored. So we will always have this kind of like helping CTAs. And we would have like scroll snapping, so you would actually never see this. Every time that you try to scroll, we would stop that, hijack, and show you the next panel. And then when the panel became visible, we would run some animation, even some videos or WebGL scenes. This was not the only thing that these sites had in common. They were also full of hacks. We were actually like twisting the arm of all the browsers. We were trying to do stuff that wasn't actually possible with the native web. The code was really hard to maintain because of these hacks were accumulating over and over again. We were adding a bunch of code. Remember, these sites had like really heavy assets, images, videos. So on top of that, a lot of code, super. You had to wait a lot on a mobile network to actually see the sites. And even after you loaded everything, the performance was actually quite bad because it was full of hacks. And I kept reflecting a lot how much CSS and the web APIs have improved on the past 5 years, maybe, and how much I would have loved to have like the new CSS, but like 10 years ago. So this talk is about this feeling of the new defaults of the modern web that would allow me to build these sites in a better way, super fast, because this is a Lightning talk and I don't have a lot of time. That's my name, that's what I do, that's where I live, that's my face, and that's me on Blue Sky, and that's my blog. Let's cut to the chase. First problem, we wanted full height panels on each section. In desktop, of course, it's like super easy, but the problem were mobile, actually. Mobile, you have this kind of like browser UI elements that would get into the way that would modify the height of the viewport. And sometimes these UI elements would cover important information. Some of them were like these CTAs to scroll. And so this was not a detail that we could overlook. So we found out that our users on mobile will like rest their thumb on their screen while waiting. I think that everybody does that. So we created this hack where on touch start, we would recalculate the height of all the panes, and then we would actually remove the event listener. The problem is that the user might not do that. We think that they might do that, but they might actually rotate, scroll. So we had to do that for all the events, which was not cool, and I didn't like it. I need to be honest, it worked, but it didn't feel right. It didn't feel right. So yeah, that is now one line of CSS. It's just that. That's if you don't know that unit, that's like DVH. That's dynamic viewport height, and that unit adapts when somebody with something actually. This kind of like UI elements from the browsers actually cover part of the viewport, and that's cool. That's not hacky. That's dynamic viewport units. That's the name of the API. Scroll animation, as I mentioned, we had this kind of CTAs that you would click or tap, and then next panel would scroll. Of course, there's no native option for that 10 years ago. So what we would do is that we would access to the offset top of the next pane that we wanted to show, we would get the scroll container, and we would, with a library, animate the scroll top property of this container. Issues: every time that you access these kind of properties, like offset top, you would trigger a layout recalculation on the browser. Not cool. And also, animating scroll top, like, it's not GPU accelerated, so the performance was like actually quite bad. Right now, super simple. You can just use a scrolling to view to the panel. It's actually super old API. It's present in Internet Explorer. But the main difference is that now we have scroll behavior on CSS, which just with one line on the scroll container, you get this done. And that is a scroll behavior. Next thing, scroll snapping. The thing that I mentioned that would never happen in these projects is this kind of like half of one panel and the other half in one panel. We will block you every time that you wanted to scroll. And the way that we did that was, guess, a hack. We would detect when you were trying to scroll. We would prevent default. So actually not scroll was happening, but we will still get the coordinates of that event. And we would calculate the direction of that. We would get, which is the current pane, call a function, and we would animate that pane out and the next one in. Yeah, again, not cool, because I can tell you that the main thing was not performance here maybe, but breaking the browser like native scrolling inertia didn't feel right in UX. Some sites even do that today, I don't know. So not cool. The solution, scroll snap as a CSS API. 2 lines, basically you set the type on the container and then the align one on the pane, and you got it done. That's just no JavaScript. This is probably my favorite CSS API. So powerful in just 2 lines. It's amazing. Scroll interception. I told you that we wanted to animate some stuff every time that a new panel comes in. So yeah, no native option 10 years ago. So when we wanted to intercept that panel, we needed to listen to scroll. And every time that you scroll, we would get the offset top again. And we would get the current pane given that position. And after that position, we run some animations. And after that animations, we need to clean stuff up. This is because performance was such a problem that we will like remove some assets, stop some animations on other panes that were not active. Yeah, it still didn't work, honestly. When you had like some panels off screen, like, I don't know, running some WebGL or some videos, it was really actually quite tricky. And right now, you have the intersection observer API. And that's super simple because you just check if the panel is intersecting, you run the animations, and for a super easy performance gain, you just can unobserve the target. Cool, intersection observer. That's actually quite old, so it's present in all browsers. Web animations, as I told you, every time that we intercepted one of these panels, we wanted to animate pretty much everything that was inside it, because we were really into motion design. And specifically, we were doing complex animation flows, so we wanted promise-based animations. We didn't have that. There were actually great animation libraries. There was GreenSock, was one of my favorites at that time, but it had no promises. It was all callbacks, and it was actually quite hard when you needed to animate, I don't know, more than 7 elements, and these animations were actually quite convoluted. So for animations, yeah, we created our own promise wrapper for GreenSock, which added a lot of code on top of the other code that we had. So we didn't like it. And right now, you have an animate function for each HTML element. You just grab the HTML element, call .animate, pass an array of transforms that you want to do, and the most interesting thing is that this returns an animation object, and that animation object has a finished promise. You can await and await and await and await, and that's actually or promise all for if you want concurrent animations. That's super cool. That's just 1 line. Amazing. Web animation API. And the last thing that I'm going to talk about today is view transitions. You might have heard of it because it's actually quite new. It's only on Chrome and Chromium. But the main thing is that just for this thing, we had to use a framework. I'm not against frameworks, but these projects were not hard to build because of the web applications feature, but because of these hacks. But then on top of that, we had to actually use a framework just to use this transition and animate the page when they were like swapping and revealing. And right now, you have a view transition API available for you. So that's quite cool. And the result is actually a web like this, just like fully animated, super controlled scrolling. You can see how the elements flush in, super nice. You can see it feels natural because it's actually the browser scroll inertia. I'm not hijacking anything here. This is not a video or nothing. This is actually an application. It exists. You can scan that QR code or just write that web URL. And also the code is available on GitHub. You can also scan that QR code and get the code. Like, actually, super simple, literally like 20, 30 lines of code for both CSS and JavaScript. And that's it. Thank you so much.
Thank you so much. All right, our last lightning talk is going to be Brian, a JS dev's guide to not dismissing blockchain.
All right. Am I live? All right. Thank you to the GitNation team and the Algorand Foundation team for making this possible. I'm the last person between you and your coffee break, so I'm going to try to make a JS dev's guide to not dismissing blockchain as interesting as possible. I'm Brian Whippo. I lead the DevRel team at the Algorand Foundation, and you can find me on most platforms by the handle Silent Rhetoric. So, why am I talking to you about blockchain in 2025, right? Blockchain had the peak of inflated expectations, and you probably think we're down in the trough of disillusionment, but I'm here today to use my 7 minutes to convince you that actually we're climbing up the slope of enlightenment, and in some cases have reached that plateau of productivity as a technology. So, I'm going to do that in 2 steps. I'm going to talk about some inspiring things that are being built with blockchain technology, and I'm going to show you how easy it is to build on blockchain with Algorand TypeScript. So I'm going to show you some code. Cool. So on background, Algorand is a high-performance layer 1 blockchain, like Ethereum, but better, quantum secure, and as of yesterday has been up with 0 downtime for 6 years. So we're very proud of that. And we've learned over those 6 years that blockchain is not a good solution for everything, but it is a good solution for a few categories of problems. One of those categories is disintermediation. This is where you're removing a middleman, removing a broker from some market and enabling people to transact directly with one another peer-to-peer. Another is data integrity. This is where you want to use a public immutable ledger to record data so that people can verify that something has actually happened. So the publicity of the blockchain is an asset. And finally, market access. So using this technology as infrastructure to tokenize assets can open up new opportunities to do things that really aren't possible or practicable with traditional infrastructure. So I want to talk about a few of the businesses that are running right now live on Algorand mainnet, because I think this stuff is pretty cool. So one, at top right, you'll see a picture of a plane. TravelX is an airline who has tokenized plane tickets so that if you can't make your flight, you can resell your plane ticket. They've created a secondary market for the plane tickets and increased their revenue by 4% in the process. Another example is Lofty. This is a startup that is tokenizing real estate, and that allows people to invest in shares of a house or a business, a commercial property, for as little as $50, and then those people can manage the property by voting on blockchain about decisions. And then finally, I'll touch on LabTrace. LabTrace is a company that has integrated blockchain into MRI machines so that researchers that are taking MRIs to image cancer, for example, can prove that the images that they've taken of a tumor shrinking are in the right order, right? Because they've been time-stamped on a public blockchain, and they have had no opportunity to fraudulently rearrange the photos to make it look like that tumor is shrinking based on the cancer treatment they've developed. And there's many more businesses running on Algorand today. So we've really arrived at the point where the theory that you may have heard about years ago is actually live in production now. So let's talk about a little bit of code. So one of the things we've learned along the way is blockchain development is hard. We appreciate everyone in this room has a whole stack of technologies in their application. And if you want to use blockchain, then you also have to deal with a blockchain network. And within the blockchain network, there's a virtual machine, so a constrained execution environment, which can be a bit of a black box and difficult to program. Historically, you've needed to learn a special purpose language to build on blockchain, something like Solidity, maybe Rust, or some kind of like Pythonic language. So we wanted to make it more accessible for developers, and we're excited to come to JSNation to tell you about Algorand TypeScript. So this is a TypeScript framework that takes syntactically and semantically correct TypeScript and compiles it down to the bytecode that runs in the virtual machine on blockchain. So you don't have to learn another language to do this anymore. So the way that we achieve that is through a compiler called Puya. So you write real TypeScript using all the same tools in the development environment that you know and love, and it goes through a couple of syntax trees and intermediate representations, and ultimately becomes the bytecode that runs on the blockchain. But you don't have to worry about the 6 bottom layers. You just have to know how to write TypeScript. So Teal is the assembly language you used to need to know to program smart contracts on Algorand. This is totally impenetrable. You're not really supposed to be able to understand this. However, with TypeScript, that same hello world looks like this. So this should be familiar to everyone in the crowd because it's real TypeScript, and you know what that does. We have a couple of other examples as well. So this is an asset transfer. This is just paying someone in a stablecoin, for example. Or if you wanted to transfer a share of one of the houses that's tokenized through Lofty's business, you would just use a very simple method to create an asset transfer, indicate who you're sending it to, what asset you're sending, and the amount, and send it through. So again, this is really, really accessible because we've abstracted away a lot of the complexity of blockchain. And finally, this is the blockchain version of a key value store that many of you will know and use in your applications. We call them boxes, and storing a key value pair on blockchain is as simple as a couple of lines of code like you see here. So if that felt easy to understand, and we hope that it does, scan this QR code. We have an incredible onboarding process where you can go from 0 to developing a smart contract in 5 minutes. We run workshops where our DevRel team will take you through the learning process in one sitting. And there's a ton of other resources available as well. You're welcome to pop into our Discord and say hello or follow us on X. So thank you very much, and I won't keep you from your coffee break.
So in 10 minutes, we'll have our last discussion room for today, AI and the modern developer. And for on-site attendees, go to your ground floor in the right corner, and remote people can join the Zoom. And now it's a 30-minute break.
With Datadog, you can monitor your infrastructure, apps, and security posture in one place. Instantly visualize your ever-changing infrastructure. Follow request traces through distributed environments, and get code-level visibility with always-on production profiling. Cut through the noise with automatic anomaly detection, and discover bottlenecks by mapping service dependencies. Datadog ingests all of your logs from any source, helps you optimize front-end performance, and secures your production environment with real-time threat detection. See inside any stack, any app, at any scale, anywhere. Join thousands of customers who rely on Datadog for full stack visibility. Start a free trial today.
What will I build today? Whatever it is, it has to be smart and connected. An app, an experience, a company, my company. Whatever it is, I'll need the right tools, all the tools. I don't want anything holding me back. What will I build today?
AG Charts is a modern open source charting library built for TypeScript, React, Angular, and Vue. Get started by simply providing your data, defining your series type, and then creating a chart. AG Charts provides over 25 different chart types, enabling you to visualize your data in any way you need to, from simple to complex. Learn more and get started for free at aggrid.com/charts.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
With Datadog, you can monitor your infrastructure, apps, and security posture in one place. Instantly visualize your ever-changing infrastructure. Follow request traces through distributed environments, and get code-level visibility with always-on production profiling. Cut through the noise with automatic anomaly detection, and discover bottlenecks by mapping service dependencies. Datadog ingests all of your logs from any source, helps you optimize front-end performance, and secures your production environment with real-time threat detection. See inside any stack, any app, at any scale, anywhere. Join thousands of customers who rely on Datadog for full stack visibility. Start a free trial today.
What will I build today? Whatever it is, it has to be smart and connected. An app, an experience, a company, my company. Whatever it is, I'll need the right tools, all the tools. I don't want anything holding me back. What will I build today?
AG Charts is a modern open source charting library built for TypeScript, React, Angular, and Vue. Get started by simply providing your data, defining your series type, and then creating a chart. AG Charts provides over 25 different chart types, enabling you to visualize your data in any way you need to, from simple to complex. Learn more and get started for free at aggrid.com/charts.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
With Datadog, you can monitor your infrastructure, apps, and security posture in one place. Instantly visualize your ever-changing infrastructure. Follow request traces through distributed environments, and get code-level visibility with always-on production profiling. Cut through the noise with automatic anomaly detection, and discover bottlenecks by mapping service dependencies. Datadog ingests all of your logs from any source, helps you optimize front-end performance, and secures your production environment with real-time threat detection. See inside any stack, any app, at any scale, anywhere. Join thousands of customers who rely on Datadog for full stack visibility. Start a free trial today.
What will I build today? Whatever it is, it has to be smart and connected. An app, an experience, a company, my company. Whatever it is, I'll need the right tools, all the tools. I don't want anything holding me back. What will I build today?
AG Charts is a modern open source charting library built for TypeScript, React, Angular, and Vue. Get started by simply providing your data, defining your series type, and then creating a chart. AG Charts provides over 25 different chart types, enabling you to visualize your data in any way you need to, from simple to complex. Learn more and get started for free at aggrid.com/charts.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
With Datadog, you can monitor your infrastructure, apps, and security posture in one place. Instantly visualize your ever-changing infrastructure. Follow request traces through distributed environments, and get code-level visibility with always-on production profiling. Cut through the noise with automatic anomaly detection, and discover bottlenecks by mapping service dependencies. Datadog ingests all of your logs from any source, helps you optimize front-end performance, and secures your production environment with real-time threat detection. See inside any stack, any app, at any scale, anywhere. Join thousands of customers who rely on Datadog for full stack visibility. Start a free trial today.
What will I build today? Whatever it is, it has to be smart and connected. An app, an experience, a company, my company. Whatever it is, I'll need the right tools, all the tools. I don't want anything holding me back. What will I build today?
AG Charts is a modern open source charting library built for TypeScript, React, Angular, and Vue. Get started by simply providing your data, defining your series type, and then creating a chart. AG Charts provides over 25 different chart types, enabling you to visualize your data in any way you need to, from simple to complex. Learn more and get started for free at aggrid.com/charts.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
With Datadog, you can monitor your infrastructure, apps, and security posture in one place. Instantly visualize your ever-changing infrastructure. Follow request traces through distributed environments, and get code-level visibility with always-on production profiling. Cut through the noise with automatic anomaly detection, and discover bottlenecks by mapping service dependencies. Datadog ingests all of your logs from any source, helps you optimize front-end performance, and secures your production environment with real-time threat detection. See inside any stack, any app, at any scale, anywhere. Join thousands of customers who rely on Datadog for full stack visibility. Start a free trial today.
What will I build today? Whatever it is, it has to be smart and connected. An app, an experience, a company, my company. Whatever it is, I'll need the right tools, all the tools. I don't want anything holding me back. What will I build today?
AG Charts is a modern open source charting library built for TypeScript, React, Angular, and Vue. Get started by simply providing your data, defining your series type, and then creating a chart. AG Charts provides over 25 different chart types, enabling you to visualize your data in any way you need to, from simple to complex. Learn more and get started for free at aggrid.com/charts.
Oh, you were right. I was wrong to question you, you know. All right, welcome back, everyone. We're going to have a couple more talks today. I hope you're excited. I hope you all had your ice cream. I know I did. That was a good little surprise there. All right, let's meet one of our gold sponsors, Focus Reactive. Focus Reactive is a specialist agency building fast, scalable website with Next.js and headless CMS. They're the trusted partners of Vercel, Shopify, Storyblok, and Sanity. Of course, you've heard this many times today, but just want to repeat, if you have any questions for our speakers, make sure that you use Slido to post those questions, and we'll make sure to ask them to our speakers. So our next speakers are Eva and Barry. Eva and Barry are from the Google Chrome team working on Core Web Vitals and the Chrome User Experience Report. In their talk, supercharge your debugging with the new features in Chrome DevTools. They will unleash the full potential of some new game-changing features, reveal hidden gems and shortcuts that will transform your debugging workflow from a slog to a supercharged sprint. So Eva and Barry, the stage is yours.
Hello, everyone. I'm Eva.
And I'm Barry.
Just in case it wasn't clear who's whom. Thank you so much for coming back after the coffee break. I know it's a bit late in the day, but I hope you still have a little bit of energy left for all the DevTools magic we're going to show you today with Barry. So, yeah, let's get started. We've seen a lot of interesting talks today, and one of the universal conclusions we can draw from them is that web development is becoming increasingly complex. Especially with the rise of AI tools and processes, the developer tooling landscape is developing very quickly. And Chrome DevTools are no different. They evolve so fast that it is sometimes difficult for us developers to keep up. As a matter of fact, the research shows that as developers, we actually rarely diverge from the workflows that we know and like. We are an efficient and task-oriented folk. We really like to stick to what we like and what we know, even if it means we miss out on some productivity gains down the line. Especially in a complex tool like DevTools, the new features that are introduced incrementally sometimes are hard to simply notice. Even when they're there in the UI, straight in front of our eyes, our trained blindness teaches us how to simply go around them. And a conference like this one is a great opportunity for us all to take a step back, take a fresh perspective, and soak in all the newness that was introduced. In this talk, we will try to inspire you to try out all the new features that were added to Chrome DevTools recently, and to get a productivity boost as a result.
Today we're going to be talking to you about a lot of the various improvements we've been making to DevTools, primarily in the performance debugging space, and also some exciting AI insights later on. Because let's be honest, what's a conference talk today if it didn't involve AI? So let's start with some updates that are near and dear to my own heart, the performance panel improvements. Over the last couple of years, we've completely reimagined the performance panel to make it much easier to find and fix performance issues. So I want to dive in and show you some of the things we've been working on. Anyone that's used the performance panel before will know that it's quite an intimidating panel. A performance trace includes an awful lot of data, and it's really great for being able to dive into that issue, but it's really overwhelming, particularly for new users, and it takes a long time to really understand how to use it properly. Well, we wanted to fix that, but at the same time, not ruin the experience for all those hardcore developers, power users, that do depend on this complexity. So we've tackled the problem with a number of changes in the panel that we believe solves that intimidation issue, and we're going to talk through them today. And it all starts when you first open the panel. This is what you used to see, a big old empty space with not much information on it at all, and just telling you to do a full performance trace. We wanted a gentler introduction to performance analysis, something that didn't require taking a trace immediately, even before you know what you're looking at. We're calling it the live metrics screen, and it's the first improvement we're going to talk about today. Now, when you open the performance panel, this is what you see. It'll immediately show you some details about the performance of the page that you're visiting. And it really is live. As you click, type, and interact with the page, and scroll down, and even click on other pages, the panel is continually updating with your performance metrics. This helps you identify exactly what performance bottlenecks you have, whether it's on page load or through particular interactions. The live metrics screen is centered around the 3 core web vitals. These are 3 metrics that Google introduced 5 years ago to really measure. I'll give a quick summary of how your page is performing. We have LCP, or largest contentful paint, which is the loading metric and shows how long it took from your click until the largest bit of content was shown on the page. CLS, or cumulative layout shift, says how much the content moved and jumped around, which is really quite annoying. Whenever you load a page and you start reading and an ad pops in and you lose your place and you're like, what's going on? And finally, interaction to next paint, which says how responsive to your website is to interactions. When you click on something, do you immediately get some sort of visual feedback, or does it take a while and you're not even sure if the click's been registered? And as you can see, this website looks great. It's all green.
Well, Barry, it's all green and nice because maybe you're developing it on your fancy laptop and on a high-speed internet. Are you sure that our users are experiencing the same on their real devices? We've heard today from Alex how it looks in real life, right? We know that there is a disconnect between developers, what they see on their powerful laptops during development process, and what users see on their devices. Actually, a huge part of the Core Web Vitals initiative was to convince the site owners of the importance of using field data, which is measured by real users on the real devices. Now we've made it really, really easy to see this real user data directly in DevTools in Performance panel. You can use the button on the top right to pull that field data on. Data comes from CRUX, the Chrome User Experience Report. It's a source of anonymous real user experiences collected by Chrome. Once you set it up in that field, the data is pulled from CRUX, and DevTools will automatically display the field metrics next to your local metrics for the URL you're currently viewing. If you develop on localhost and there is no real URL to speak of, you can map your local host to your production URL to still get that matching numbers next to each other. This allows us to compare the performance metrics we're seeing to what our real users are seeing.
Oh, and as you can see, maybe loading's a little bit slower for the real users who aren't on fancy high-end laptops. And that's the desktop data. But when we switch to mobile, we automatically load the mobile data, and you can see it's even worse. So at this point, we know we've got two issues to solve, our LCP and our INP. Fortunately, you can configure your dev tools to act more like, to better emulate what your users are actually seeing. Use the settings panel on the right. If we zoom in, you can see, for a start, the Crux data tells you exactly the breakdown of your website and your website visitors. Here we see most of our visitors are on mobile, and that's pretty normal these days. As Alex said earlier, we're in a mobile-first world. It also tells us that 75% of our users are on slow 4G throttling. So rather than having to guess what to do, you can use your real data to actually set that. So let's set that. And we're also going to set some CPU throttling here. Now, it recommends 4x slowdown, but to be honest, that's just a default. It doesn't explain exactly why you're doing that. Now, this data that we're going to set here doesn't come from Crux, because we don't have that data in there. But we do have this new nice calibrate option that we've added at the bottom. And when you click on that, it will give you this option and actually calculate some calibration for your laptop. So you simply run the calibration. It'll run some hardcore processing, see how fast your computer is, and then suggest some custom multipliers for you to use. Here we see a 3x slowdown is recommended for my laptop for a mid-tier device, so we choose that. Then when we reload the page, we see that our local metrics are more closely matching the field metrics that we saw our users getting. So at this point, we're now in a good place to actually debug this performance, because we should be able to replicate exactly what they're seeing.
So performance trace can actually give you much more information than the live metrics screen alone to really help you understand the performance issues. It might take a longer while to record, though, so it is best to use the live metrics Barry just showed you to do some quick checks or experimentation, and only record the full trace when you want to dig deeper into some specific problem. You can record the trace using the buttons on the bottom right, or there are also available two smaller shortcuts in top left for your convenience. You can either record a specific user interaction, like a series of clicks or a scroll, using the record button, or trace a full page load using record and reload. Let's go for a record and reload for now.
After a few seconds, you'll be presented with this. I'm going to say this detailed, kind of scary view. Now, we've made an awful lot of improvements to try and make this view more useful and make it easier to navigate around it. Oh, sorry, missed that. To make it easier to navigate around this trace view. There's some of these are shown in the video. We're not going to have time to cover all of these today, but check out the blog post at the bottom, and some of the other blog posts in this series to get more details on that. And the reason we're not going to have time is I want to talk about one particular improvement we've made to that with the Performance Insights panel. Many of you may be familiar with Lighthouse, which presents a summary of your page experience, including the well-known performance score. As well as those scores, Lighthouse has a wealth of data in its performance audits. But Lighthouse can't show you the deep performance data that the trace view shows. And flicking back and forth between the Lighthouse panel and the performance panel is a bit annoying, to be honest. But what if we could bring those two things together? And that's exactly what the Lighthouse the Insights sidebar does. You get a number of insights here in Lighthouse style. Sorry, you get a number of Lighthouse style insights in this sidebar, and they're listed in rough order of what we think is a priority for you to look at here. And we didn't just transfer these insights from Lighthouse. We looked at them, we retired some old ones, we merged some together, we tried to make them more useful. So we did a complete audit of Lighthouse, if you will, and came up with better insights. And we're now bringing those insights back to Lighthouse, because we want the same experience whether you're looking at Lighthouse report or whether you're looking at a trace view, rather than this just disjointed experience that you used to have. But the really powerful thing about the insights in the performance panel is that the insights in the trace view are fully interactive. Clicking on any of the insights automatically zooms the trace to the appropriate time span. It filters out the irrelevant data and highlights the important data. We even overlay additional data, such as LCP subparts, to really help you understand the trace view. With performance insights, you can quickly see the render blocking requests, layout shifts, network dependency trees. You can use insights to zoom into exactly where large DOMs causing your page performance issues, or highlight third parties or forced reflow issues. But we aren't done yet. All that information is fantastic, but what if you don't know what it actually means? We want to make the insights sidebar as user-friendly as possible, independently of your expertise level, so for performance experts, but also for newbies alike. So we added one more friendly feature to it, the Ask AI button. When you click on the Ask AI button, you're taken directly to the AI assistance panel, it passes to the AI, for context, the details of the insight you're looking at and the part of the trace. You can have a conversation with Gemini here based on your performance page data. You can even suggest some example questions, but you're free to type whatever questions you want. If needed, it also has the ability to probe back to the trace for extra information as your conversation progresses. In the end, you should get an exhaustive explanation together with suggested actions you can try out to fix the issue.
Speaking of AI assistance, you can find it in other places too in Chrome DevTools. For example, here I'm looking at one specific insight, which is called legacy JavaScript. And here I can see the name of the script that is causing some trouble in my performance. But it's not instantly clear for me what script that is or what does it do. By clicking on the script name, I'm taken straight to the sources panel. In the sources panel, I can see the source code of that script, but it still looks fairly cryptic to me. Fortunately, I can use the little Ask AI icon next to the script to ask a question directly about the script. For example, what does it do, or what it is responsible for. Here I learned that it is the core part of my Next.js page setup, and it is responsible for routing and rendering of my Next.js app. Very similarly, in the same insight, I can click, instead of the name, I can click on the icon, network icon next to the script's name. This time, I'm taken to the network panel. And here again, in a very similar way, I can use the same AI icon to invoke the AI assistance panel. And now, it's my network request that is being passed as context. So I can ask questions regarding headers, caching, payload, security, or get ideas of possible network-related improvements. You can use the predefined prompt as starting point, or craft your own queries to drive your investigation further. As you can see, this AI assistance panel is fairly versatile, and you can do a lot with it. Now, with the new AI capabilities built into DevTools, you can even fix code for you straight in DevTools. Let's have a look at that. When you inspect element in the Elements panel, the little AI icon lets you interact with Gemini and ask for advice regarding this element's layout or styling. With prompts like, can you center this element on the page for me, or why is this text overflowing its container, it can not only give you an actionable piece of advice, but even produce a patch of code that would fix the issue. If you are more visually inclined and prefer to use images instead of text, now, thanks to the multimodal input, you can do it too. Here's an example. This is a website, and on this website, we have a few video thumbnails listed. And we immediately notice that one of those thumbnails stands out and is not cropped like the others. With the camera icon next to the prompt, I can easily grab a snapshot of that part of the page to help the LLM understand which thumbnails it should fix for me. Gemini analyzes the page and proposes a patch for me. With just a few clicks, we get the issue resolved, and now all the thumbnails are nicely trimmed and aligned. Gemini proposed a code patch that we've seen briefly on the previous screen. As well as seeing the changes in the AI conversation flow, you can see the code it alters on the page highlighted in the Changes panel. The change AI made on this page is temporary, though, a bit similar as if you were editing styles by hand in the Elements panel. This means that if I reload the page, the changes will be gone, And, it's kind of sad, so we decided to change it. Let's have a look at that. Let's say the website I was just developing a moment ago, with the help of AI assistants, is actually a local project, and it runs on my local host. In my case, the folder containing my project is called DevTools Cinema. Now we can take the AI assistance to the next level. Let's say I'm happy with the patch AI suggested earlier, and I would like to save it to my local code base. All the magic happens in the Unsaved Changes section at the end of the AI conversation. Because my local folder is connected to DevTools Workspace, I can see the name of the folder, the DevTools Cinema, and this nifty Apply to Workspace button at the bottom of the section. When I click it, thanks to the source maps and some more AI magic, the AI agent will find the most appropriate file and appropriate place in that file to apply my fix, even though my code is compiled from SAS or uses a JS framework like Next.js, for example. This allows me to persist the change to the local files and make my fix permanent. So how can we set up that workspace? Generally, you need to connect the local folder to DevTools and grant appropriate write permissions. You can either do that manually in the Workspace tab in the Sources panel, or just the same way you would do in any modern IDE, or you can rely on the new automatic workspaces discovery mechanism. It works like this. You need a JSON file that describes a path to your local folder. If you are on localhost and expose this JSON on a particular URL you can see on the screen right now, it will be automatically detected by DevTools. And an option to connect will be displayed in the Sources panel. You can add such endpoint to your local server yourself, or you can use one of the integrations. For example, Angular has support already built in, and for Vue-based applications, there is a plugin that you can use. Nuxt also showed interest, and we hope to get more frameworks on board soon. To learn more about what is possible with AI assistance in DevTools, make sure to check out the AI assistance homepage on developer.com DevTools section.
And the great thing about this is we're not showing you the future. These features are all available in production Chrome now, from Chrome 137, which is the production version that you should all be using. They're available without Gemini subscription, so we'd really encourage you to have a go, try them out. If you've been afraid to go into performance tracing before, have a play. It should be much more friendly. And the AI features are not just AI features we're throwing in there for the sake of them. We really find them quite useful for debugging and getting help understanding your code. To use the AI assistance, you'll need to be logged in and to explicitly enable it in the settings. The first time you try to use it, it will direct you to the screen to turn these settings on. And if you're in an enterprise policy, you can also use to control the feature if you prefer to turn it off. All the AI features are still under active development, so we do want to hear feedback from you. Play with them, have a look. If you discover any bugs, any issues, then let us know either in socials, contacting Eva or myself, or by using our public bug tracker.
Well, today we covered a lot of topics. We talked about performance panel improvements, including live metrics, field data, environment settings, and performance insights. We showed you the dedicated SKI feature in Insights, and how AI assistants can help you in sources and the network panels. Finally, you've seen how AI can fix some styling bugs and generate code that can be saved to a local workspace. We really hope that you enjoyed the talk and you get a chance to try out all the new features next time you open DevTools. Give it a try, and hopefully you will see some productivity soar as a result. To stay up to date, please subscribe to our YouTube channel and check out regularly developer.com for our updates. I've been Eva, and I'm mostly DevNook on socials.
And I've been Barry, and you can find me at Tune the Web and the most social websites. We hope that was useful for you, and I think we have a little bit of time for questions. And I also encourage you to come to us afterwards in the Q&A section, where we can show this working on your site. Thank you very much.
What will I build today? Whatever it is, it has to be smart and connected. An app, an experience, a company, my company. Whatever it is, I'll need the right tools, all the tools. I don't want anything holding me back. What will I build today?
AG Charts is a modern open source charting library built for TypeScript, React, Angular, and Vue. Get started by simply providing your data, defining your series type, and then creating a chart. AG Charts provides over 25 different chart types, enabling you to visualize your data in any way you need to, from simple to complex. Learn more and get started for free at aggrid.com/charts.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
With Datadog, you can monitor your infrastructure, apps, and security posture in one place. Instantly visualize your ever-changing infrastructure. Follow request traces through distributed environments, and get code-level visibility with always-on production profiling. Cut through the noise with automatic anomaly detection, and discover bottlenecks by mapping service dependencies. Datadog ingests all of your logs from any source, helps you optimize front-end performance, and secures your production environment with real-time threat detection. See inside any stack, any app, at any scale, anywhere. Join thousands of customers who rely on Datadog for full stack visibility. Start a free trial today.
What will I build today? Whatever it is, it has to be smart and connected. An app, an experience, a company, my company. Whatever it is, I'll need the right tools, all the tools. I don't want anything holding me back. What will I build today?
AG Charts is a modern open source charting library built for TypeScript, React, Angular, and Vue. Get started by simply providing your data, defining your series type, and then creating a chart. AG Charts provides over 25 different chart types, enabling you to visualize your data in any way you need to, from simple to complex. Learn more and get started for free at aggrid.com/charts.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
With Datadog, you can monitor your...
Alrighty. We're continuing. Let's hear from one of our gold sponsors, Storyblock. Storyblock is an API-first headless CMS built by developers for developers to make content management fun and collaborative. As always, make sure that you have Slido open on your phone so that when you think of a question, you can post it directly, and we make sure that we ask our questions to our speakers. Our next speaker is Paolo. Paolo is Svelte ambassador and maintainer, and in surprise, Svelte secretly sending signals. We'll hear about how Svelte 5 runes utilize signals to enhance composability. These are words, man. And in his talk, Paolo will explore their intricacies by building a reactive signal-based system from scratch. So Paolo, the stage is yours.
Okay, welcome everyone to my talk. It's called Surprise, Svelte Secretly Sending Signals. Before we begin, a small presentation is due. Who am I? I am Paolo Ricciuti. I come from Campobasso, Italy, the land of pizza. And you can find me on Blue Sky as paolo.ricciuti.me or on GitHub as Paolo Ricciuti. I'm a Svelte ambassador and a Svelte maintainer. And I work as a senior software engineer at MinMatter, which is super cool because I get to work with Svelte, but also to teach Svelte, both at meetups and conferences, just like this one, but also in my day-to-day job because we do what's called team augmentation, which means that we join your team, we help you hire, we teach you Svelte and best practice. We even do workshops. So if you want, you can scan this QR code and also get JSNation 25 code for 25% off. And we also have a subscription API, not API, service, so that if you don't have a full-blown project, you basically get access to our expertise, like in Slack, and you can basically like ask us to review a code and stuff like that. But it's demo time, because this will actually be 100% live coded, because apparently I hate myself. So let's switch to VS Code, where we are met with the most useless demo. It's a counter that doesn't work unless you keep the party going. And then you can like type here, and it will update on top. But the interesting bit is how everything is wired. So this is wired with the old way of doing reactivity in JavaScript files in Svelte, which is with a writable store. The writable store is basically the observer pattern, and you can see an implementation here. It's like 20 lines of code. And how you use it is also very simple. Like, you just declare the writable state, and you can subscribe to it, and this function will be invoked whenever the state changes. And then, like, this is a vanilla project, so you are wiring up the button click listener, and this is how you update the state, which is, but let's look at the implementation. So you pass an initial value, you store the value here, and then you have a set of subscriber. A set is just a fancy array with no repetitions. And then you have a subscribe function that take a function as input, store it in the subscriber, invoke it with the current value, and then return a function to unsubscribe. Then you have the set function that just like set the new value, like the value to the new value, and then loop over every subscriber and call the function with the value. The update function is even easier because it's just calling the set function, and the value that you're passing in is this get new value function. Now, as you can see, like using the store, the writables, is not really pretty. And Svelte is famous for its vibe, like we want to do stuff simpler. So allow me to introduce you to the proxy API. So I can do const p is equal to new proxy. The proxy API is very simple, and basically you get an object like this, and then the second argument is actually a series of traps. And just like a network proxy where you can interject a request, you can basically interject operations on your object. For example, there is the get trap, and the get trap, you get the target and the key that you are trying to access, and you can return target at key for the default value, but you can also add, I don't know, console.log getting key. And if you do this, and I need something here, if you do this, and if I try to do console.log p.name, and if I save, you can see that in this case, I'm getting the value, which is Paolo, and I'm getting name, which is a sort of side effect. But what we are really interested in is the set function. So you can get a target, the key, and the value. And obviously, you can get the default behavior with target at key is equal to value. You need to return true, otherwise you will get an error. But even here, you can do some side effect, basically. So if I save, and if I do p.name is equal to JSNation, and I save, you can see that we are getting setting name JSNation, and then we are getting the actual value. So basically, we can replace this with our set function. And so instead of returning this object, we can do return new proxy. Now, we need to pass in an object in this case, so we cannot pass literal values anymore. In Svelte, we don't have this limitation because it's a compiler. So I can remove this because since it's an object, the user can just access the object directly since it's a reference. And here I can basically do set. I get the target, I get the key, I get the value. And then I can basically do the same thing that I was doing here. So I can basically set the target at key equal to value to update the value. I need to return true, as I've said. And then we can just call our list of subscribers, the function again. So obviously, you may notice now we have a problem because we don't have a way to subscribe to it. So for the moment, let's do something dirty, and let's return a tuple, And the first argument will be our subscribe function. So basically, I can do exactly this inside this function. And obviously, I don't need the value anymore because it's not there. Now, we can update our code now, so we can remove all of these. And we need to, for the moment, we need to update this to get the subscribe out of it. We need to update all this state.subscribe to just be subscribe. We say that we don't need this $state as input anymore, because now we are just doing, we are just accessing the state by default. And now the fun part is that we can update all of this code, and here we can just do state.count++, which is much, much nicer. And we can do the same thing here. We can do state.checked is equal to e.target.checked. And can remove all of this. And then we can do state.value is equal to e.target.value. And we can remove all of this. Now, if I did everything correctly and I save, we should have literally the same. And it's not, obviously. What did I miss? Subscribe. Did I miss something? Oh, what? How it was there? Yeah. Should be this. Yeah. So now this is literally the same thing as before. So it works and it's fine. Now we can go home. It's fine. No, the problem is that let's say that I do console.log running, and if I save, obviously now it's running the first time, and if I uncheck the checkbox, it's running, and we kind of expect that because checked changes. And if we change the number, it's running again, which we kind of expect because count changes. But if I uncheck and then I change count, it's still running, even though the UI is not really changing. But I mean, this maybe is acceptable. The thing that is really not acceptable is this. If I change the value, even though I'm not using the value here, I'm still running that code. So I don't want to do that. And the reason for this is that we are using a set, so this means that we only have one set of subscriber for all the keys. I can change this if I do map. So a map is just a fancy object. And so basically what I want is I want to have a new set for every key that So obviously, we need a way to get the key. For the moment, let's do something dirty, and let's do this. We loop over every key of keys. And then if the subscriber does not have a key, we create a new set for it. And then we do const deps is equal subscribers.get key, like this. So we get the set of subscribers. And now we can just do deps.add the function. So we add the function to this array. We can remove this, and we can basically do the same to clean up everything. So we can remove all of this. We get the dependency, and we do delete function. So what? We actually need that. OK. So basically, now we need to update our code in even an uglier way, because now we need to manually specify our subscription. So I need to do checked. I'm interested in checked, and I'm interested in count here. For this, I'm only interested in checked. And for this, I'm only interested in value. Now, if I did everything correctly, and I say, oh, I need to do something else. I need to change this to be the key. So I need to get the subscriber of that specific key. And since this can be null, let's also do this so that we are safe. And now it's not working, so I think.
You misspelled subscribers.
Ah.
And you have it twice, yeah?
OK. Oh, in both places, obviously. OK, now, if I save, this should work the same. And so if I click, it's running. If I check, it's running. The nice part, however, is that now I can change this, and the reactivity still works, but I'm not running that code unnecessarily. Now, obviously, like the DX of this, like I started this talk saying, okay, we can have a better DX, and this is actually way worse. So what I want really is that if I read something in a function, I want that thing to be a dependency of that function. Now, if you have used Svelte 5 a bit, we introduced runes, which use signals under the hood. And when you declare state, you declare it like this, $state. And then if you use something like function $effect, where you pass in a function, so if you use a function, if you use a stateful variable inside a function passed in inside the effect, then everything that you read will actually be a dependency of that. And we can actually do that because we kind of explored it before, but we can do get. And so we can know when we read something. So we can do target key like this. We can return target at key. And then basically, that's the point where we can subscribe. So instead of doing it here in the beginning, we can do it here. So if the subscriber does not have the key that we are looking, we create a new set. We get the dependency, and then we add the function to the dependency. Now, what is the function? Well, in JavaScript, there's no API to know in which function you are running into. But since we want this API, we can actually trick it, because a function is just a variable. So I can do let current effect is equal to null. And then here I can do current effect is equal to function. Then I can invoke the function. And then I can set back to the current effect to null. And this means that when I'm running this function, if I read something, this function will be invoked. And I can check if current effect is defined to know in which function I'm running. So I can say if current effect, then I will do this kind of stuff. So I do this, and obviously I need to rename function to current effect. And obviously now we need to change our code again, because we don't need to return subscribe anymore. We can just return the proxy, which is much nicer API. But we do need to change a couple of things. We need to change every subscribe needs to become $effect. And obviously, we need to remove this. So if I save, now everything should work fine. If I check, and it's working. If I check, it's working. And that's it. No, that's not it. There is a bug yet. Because if I now increase the counter, it's not working. And if I uncheck and I check again, then it updates. And the reason for this is because inside our effect, we are setting current effect to function. And then we run the function, and then we set current effect back to null. But this means that when we read the value, the second time that this function executes, we don't set current effect before running the function. This, however, is actually very simple, because we can do function actual effect, and we wrap all this code inside this actual effect. We invoke it the first time. But then current effect become actual effect instead of function. So this means that now every time we rerun the function, so in this case, if we increase count, it's not a dependency, then we check, and now count is a dependency, because before running the function that update count, we actually update current effect to actual effect. That's it? Not yet, because if we uncheck, now we still have a dependency on count, which is a bit weird because we are not reading count the second time. The UI is not changing. So the reason is that we are adding something to the subscriber set, but we never remove something from the subscriber set. However, since every time we run the effect, we explore a branch, we can actually, before running the effect, remove that effect from the dependency of every key that has that effect as a dependency. It's a bit convoluted, I know, but it's actually very easy to do. We can do deps is equal a new set. So this is the set of all the set that contains effect as a dependency. And instead of just passing the object, we can pass deps and the function like this. So now, when we add the dependency, we add the function here, and then we do current effect.deps.add deps. So we are adding this subscriber set to the dependency of this effect. And now what we can do is, before running it, we can loop over let dep of deps, like this, and we can do dep.delete actual effect. So we remove this function from every key that has that function as a dependency. We can also clear the set just for good measure. And now, if we save, this should work just fine. And if we click here, we are not getting extra rerunning. And when we check back, we don't get a dependency on count anymore. And we can do it, and we can click it and unclick it and stuff like that. There's still one bug left. If I do this, state.value is equal to JSNation. And if I save, the moment I type something here, it's frozen. I cannot type anymore. The reason for this is because up until this moment, our effects are synchronous, which means that by the time you reach this line here, this code here in the effect already ran, which means that when you set state.value to JSNation, this input.value runs before this state.value. And so we set input.value to JSNation, and then we set state.value to the input.value. To fix this, also because it's very inefficient, like we are basically running the code twice here when we don't need to run the code twice, we can just implement a very basic batching, which means that we can do const toRun is equal a new, guessed it, a new set, and then we can do function schedule, and inside the schedule, if toRun.size is greater than 0, then we know that we already scheduled something, and we can just return. And then we can queue a microtask, which means that it will go to the next microtask, and then we can loop over every function to run and invoke it, and then in the end we can clear to run. And now we need to update this so that we can schedule every time. And then, instead of immediately calling the function, we just add the function to the queue. And if I save, this is working, and it works, and it's not rerunning code unnecessarily, and that's it. Now, this obviously, it's much more complex in Svelte. So if you go in Svelte, in the Svelte repo and try to look for this code, there will be no such thing as this code, because in Svelte, it's much more complex because we need to deal with transition and animations that have their own problems. There is also the derived situation that I'm not exploring this. However, this is the very bare bone implementation of how signals work. So if you know this, you can pretty much just figuring out some reactivity problem that we are having. And this is not even just related to Svelte. If you are using a signal-based framework, which is a lot nowadays, with this mental model of how signals work, you can figure out reactivity problem. For example, a lot of people are kind of puzzled by the fact that count is not a dependency initially. Now you know why, because to get a dependency, you actually need to read that code. Another thing that kind of trips people off is when I do await 42, and if I do async here, and I save, this actually stops working. And the reason for this is very simple. If you have an async function, after the first await, this runs in the next microtask, which means that since we are doing this here, we are setting the current effect, we are invoking the function synchronously, and then we are setting it back to null. By the time you read checked and you read count, current effect will actually be already null. So these are the kind of stuff that trips people off when they are thinking about about signals. And with this very basic mental model, you can now figure out why it's happening, why something is happening. If you're interested, the code is on github.com/mainmatter/signals from scratch. There is the initial code and then the final code. And if you have any question, I'm here for it.
All right.
What will I build today? Whatever it is, it has to be smart and connected. An app, an experience, a company, my company. Whatever it is, I'll need the right tools, all the tools. I don't want anything holding me back. What will I build today?
AG Charts is a modern open source charting library built for TypeScript, React, Angular, and Vue. Get started by simply providing your data, defining your series type, and then creating a chart. AG Charts provides over 25 different chart types, enabling you to visualize your data in any way you need to, from simple to complex. Learn more and get started for free at aggrid.com/charts.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
With Datadog, you can monitor your infrastructure, apps, and security posture in one place. Instantly visualize your ever-changing infrastructure. Follow request traces through distributed environments, and get code-level visibility with always-on production profiling. Cut through the noise with automatic anomaly detection, and discover bottlenecks by mapping service dependencies. Datadog ingests all of your logs from any source, helps you optimize front-end performance, and secures your production environment with real-time threat detection. See inside any stack, any app, at any scale, anywhere. Join thousands of customers who rely on Datadog for full stack visibility. Start a free trial today.
What will I build today? Whatever it is, it has to be smart and connected. An app, an experience, a company, my company. Whatever it is, I'll need the right tools, all the tools. I don't want anything holding me back. What will I build today?
AG Charts is a modern open source charting library built for TypeScript, React, Angular, and Vue. Get started by simply providing your data, defining your series type, and then creating a chart. AG Charts provides over 25 different chart types, enabling you to visualize your data in any way you need to, from simple to complex. Learn more and get started for free at aggrid.com/charts.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Amazing. Quick announcement, if you have seen your badge and it looks like it's yellow and green, that means that you have a duo ticket and you can just join us tomorrow. You don't need to check in, you don't need to go to the registration desk again. You can just walk on through. We'd love to thank our silver sponsors once more. Let's give it up for TypeSense, Bloomberg, and Code QA. Thank you so much. Of course, Slido is still totally in effect, so make sure that you ask all of your questions and we'll pass them on to our speakers. Speaking of speakers, we'll continue with our next talk by Charlie. Charlie is a senior research engineer at CrowdStrike, the author of Practical Machine Learning in JavaScript with TensorFlow JS, and overall just a creative technologist. In their talk, Motion Control with Multimodal LLMs, Charlie will take you through research experimenting with building motion-controlled prototypes using LLMs in JavaScript. Charlie, the stage is yours.
Thank you. Thank you, and welcome to my talk about motion control with multimodal AI. I gave a longer version of this talk recently at another conference, and a colleague of mine watched the recording, and she was like, oh, it's like a magic show. So hopefully, if everything works well, it will feel maybe like a magic show, but then you'll also understand how it actually is all built. So I was briefly introduced. I'm going to go quickly over this. So yes, I'm a senior research engineer at CrowdStrike. I go by Dev Charlie online usually. I'm an author, front-end master's instructor, so I've been doing kind of things with machine learning on the web for about like 8 years now, but primarily using TensorFlow JS before, and this is going to move on to the more recent advancements with multimodal AI. Overall, I guess I'm a self-proclaimed creative technologist, so I like to push the boundaries of what can be done with JavaScript and the web platform, and sometimes try to use tools to kind of make it do maybe what it wasn't necessarily built to do. And outside of tech, I've been spending a big part of the year trying to have hobbies that are non-tech related. It includes diving, running, hiking, playing drums, learning German, and I also got my radio license earlier this year. It's a very niche hobby, so I don't know if anybody here knows what it is, but in case you do, my call sign is KO6HPR if one day you hear me on the radio. But let's start by talking about previous experiments. So when I introduced myself, I just talked about TensorFlow.js, and I want to cover a little bit the things that can be done with that tool, so then you'll understand a little bit why I'm also experimenting with this with multimodal AI. So there's a few different models that you can use with TensorFlow.js, and one of them is about pose detection. It's called PoseNet or MoveNet. There's a second one as well. And usually you get key points. So forget about the green lines. It's like the red dots. Depending on the model, you get a different amount of key points. And these key points are raw data. So it's coordinates, x and y coordinates relative to the screen. And with this data that you get, you can build something like this. So this is a clone of Red Light, Green Light, the game from Squid Game. So if you have not watched this series, basically you have a doll, and when it looks at you, you're supposed to like not move, and when the head is turned, you're supposed to like, or in this case, run as close to the screen as you can. Otherwise, like you die. Basically, if you move when the doll is looking at you, you die. And I wanted to recreate something using PoseNet, and then you start thinking, well, how do I actually code like the fact that I'm not moving or moving? So we're not going to answer that question in this talk, but if you want to think about it later, it's pretty interesting. So you can decide, do I use all of the key points in the body? Do I only focus on some of them? What does it mean, like in terms of logic, and things like that. But if you want, you can also focus on only some of the key points. You don't have to use all of them. So in this other example, it was a clone of Beat Saber, where originally the UI was an open source repo that was on GitHub, and it was supposed to be connected to a headset via like using WebVR. And you were supposed to be able to connect this app to joysticks using JavaScript, but I didn't have a VR headset, and I was like, I have hands, so I can just like play Beat Saber with my hands. So I was basically used two of the key points from PoseNet, so my right wrist and my left wrist, and then I kind of used these directions or these coordinates, translated them to the VR world, and being able to kind of like play Beat Saber with my hands. Another model that you can use is one that is specifically around key points on the hands. So right hand and left hand, and here I think you have about 21 key points, and you can build something like this. So I started thinking, well, what if you could augment the tools that you already use, but add some kind of motion detection to it as well? So that was interacting with Figma. So it's not necessarily that all of a sudden you will build entire interfaces just with your fingers, but what if you just were augmenting the type of things that you can do? In this example, I think I was using just like a pinch gesture to be able to drag shapes around. And then here in this GIF, it's like basically when I move my hands like this. But when I do like a palm gesture, then this is a zoom. And you would also have to write that own logic. It's like, what's even a palm gesture versus like a fist or something? And then you measure the distance between your hands, and you can do whatever you want with it, really. And finally, another model that you can use is around more face detection key points. This one has more than, I think, 450 key points all around the head. And what I focused on specifically is to build a tool to focus on gaze detection. And with this, you end up having even more questions, not only technically how do you build this, but even in terms of human-computer interaction and user experience. If you only have two inputs, left or right, how do you write something? And here it's kind of like reimagining the keyboard as well. So, if you have a keyboard and you want to select the very last letter, you could technically, like, as you're looking right, like select, go letter by letter, but that would take a while. So then you could rethink the keyboard and see, okay, if I split the keyboard into two lists of letters, and let's say I want to write the letter W, and it happens to be in the right column, then you look right quickly, and then it splits that column again into, and you end up with like kind of like a binary search, and you end up being able to select a letter that's like far on the keyboard but faster. And then you would select it with like blinking, for example. But with this same concept, then you can start thinking, well, what would it mean to code using only two inputs, left or right? And it's a nice exercise to be thinking about our interfaces in the way that we actually interact with our tools in general. And again, it's not necessarily that you would have to replace entirely writing with your eye movements, but even in terms of thinking about what it means to code, now we can ask whatever, ChatGPT, and it will spill out a code sample. But before you'd be, okay, when you code, there's only a certain amount of things that you can do, or there's only a certain amount of ways to define a function. So you would kind of have a list of the available things that you can do, and then you could also have like a tool where, again, like the keyboard before, you would look at sides of the screen to select what you want to do. And then you can use like snippets on VS Code, especially for React, where if you want to create a function, then you would look to the side where the function option is, and then when you blink, it would almost like simulate that you're doing a tab, and then it would write the component. So this works really well. Like, it's kind of fun to be working with these coordinates. But at the same time, it means that everything that I'm doing is that I, as an engineer, have to define what these gestures are. So for example, if you're using the hand and you do a thumbs up, it's like, well, how do you code what a thumbs up is? If, for example, you were doing like, oh, well, if I don't see the tips of my fingers because they're folded, and let's say if the angle between my thumb and the rest of my hand is like, I don't know, 90 degrees, then it's a thumbs up. But then what happens if a user is like tilting their thumb a little bit more? All of a sudden, it's not 90 degrees, even though you know I'm still doing a thumbs up. So it becomes a little bit more difficult to have something that can be shared by a lot of people. So then I started wondering, OK, can LLMs be used for motion control? So I know that when you think about LLMs, you think about language, so text. But let's say more recently, we're talking about multimodal AI. Actually, that's not what I'm going to show. So yeah, it's like LLMs or multimodal LLMs, multimodal AI. It's like feeding or augmenting what you're giving the LLM, and we're starting with pictures. But the inspiration for what I'm going to show in this talk is something like this. It's called the Room E project by Jared Ficklin. It goes all the way back to 2013. So I've been wanting to do this for 12 years. And in this example here, there was actually a Kinect sensor. It's like basically like a depth sensor. And in his example, he was looking at how tech could be added to like almost like room-sized computing, and you would be able to communicate with devices with voice and gestures. So in this example, there's two lights, and he was pointing at the light, and he was like, turn this light on, and then turn that light on. And it would kind of understand based on gestures and what you're saying, which light to turn on, and it would understand the commands turn on or turn off. But in this example, again, it's using a Kinect, and I think they don't even sell the Kinect anymore. So I wanted to see if we could do things with what's in the browser and all in JavaScript and something kind of like similar. So hopefully, if the demos go well, we should see that it is kind of getting closer to something that's possible. But again, it means that hopefully as well, there's not that much code involved. And now that people are getting used to interacting with AI anyway, we could get to a point where things like this would require maybe just a camera, and the rest would, like AI would kind of understand what you're trying to do. Or it would learn about your gestures and the way you want to interact with interfaces, rather than as an engineer, you would create an app and you say, oh, the only gesture you can use to turn the light on is like pointing, and like, what if I don't want to point? And like, you could retrain your AI to understand what you want to do. So yeah, I mentioned multimodal AI. There was a few talks about AI today, so you probably know by now, but quickly, it's a machine learning system that can process multiple types of data, such as text, images, and sound. So here, because we're talking about gestures and we're going to use the webcam, it's mostly images that are then, they're going to be a label that's going to be then fed into an LLM, and this is where the LLM comes in and the text input. So the purpose of this is to research how or if LLMs can be leveraged to create motion control experiences. And usually when I do personal research, I also set myself a specific goal, because you can go on forever in research, and then at some point I kind of want to move on to something else. So my goal is to control a website or an IoT device with hand movements using Gemini. The only reason why I'm focusing on Gemini specifically is because it's free, and I'm doing this not as part of my job. I'm not paid to do this. So it would be interesting to kind of switch and see if using other models would be more or less accurate, or maybe there's different things that you can do. But in this talk, it's going to be Gemini specifically. So there's a few different approaches that you can take, or at least that I decided to take when going through this. So first of all, I was thinking, if we rely only on multimodal AI, first let's try with that. So Gemini takes screenshots, and it returns its best guess for the hand gesture that I'm executing, and then we can try to trigger stuff. The other approach is like, well, if I know TensorFlow.js, can I start to rely on multimodal AI, and then augment it with more like fine-grained data and gestures from TensorFlow.js? Okay, that would be like, second approach. And then the third one would be to do all like DIY, or at least the gesture recognition, where I would take screenshots from the webcam, I would convert it into vector embeddings in JavaScript, save it in a custom vector DB, and then use Gemini only for the function calling. So if you're thinking maybe about privacy, when I'm giving images of myself to Gemini, I don't know where it goes. I don't know, if it's used to train something else, and maybe you don't want that. So if you are creating your own custom system, you could still use Gemini. Then when the label of your gesture is returned from your vector DB, you could then just rely on the LLM like Gemini. You wouldn't have to augment it with images and stuff. So full disclosure, this third approach, I'm still working on it, so I'm not going to be able to demo it today. But I think it's actually something that can work. It's just that this is ongoing research. So I still wanted to mention it, that this is one of the approaches that I'm trying. OK, so gesture detection with Gemini. I use their starter repo. They have something called like Live API, Web Console. It's a starter repo in React that kind of like sets the skeleton of how to use multimodal AI using Gemini. Again, my purpose or the point of my research is to focus on like the motion control part, so I didn't want to build something from scratch. So if you're interested, if any of the code sample that I'm going to show later, I'm going too fast over it or it's not enough, there's actually a starter repo that you can start from. So showing a few code samples. So at first, you have to start by configuring the model. So I've been using Gemini 2.0 Flash Experimental. It's kind of an old one now, as of, I think, 2 weeks ago. I think that now there's a new one that you can use, and I haven't tried it. I'd be curious to know if it makes the predictions better or faster or anything. But for my experiments that I'm going to show you, this is the one that I'm using. Then you can set certain configs, so you can tell the model if you want to have responses in text format or if you want it to talk to you. Here I have audio, so that hopefully if everything is set up properly, you'll also hear the AI like talk to me. But the most important part of it is your system prompt. So for my first experiment, I wrote something quite simple. I said, you're my helpful assistant, looking only at the hand in the stream from the webcam. Make your best guess about what the gesture means. Don't ask for additional information, just make your best judgment. So we're going to start with that one. OK. So here, hopefully, that should be zoomed in. So what's going to happen? I'm going to tell you what's going to happen, so that then if it doesn't work, you'll know. I won't be able to hide. But on the left column here, there's going to be basically the output of the model. And you should see, so in the center, I'm going to have the webcam. I'm going to make a gesture in front of the camera. And you should see the label of that gesture answered by Gemini. You will also, just to precise, I'm going to say a trigger word to start the functionality. In the end, what I would love is for it to work without having to like talk to it, or you can programmatically send like a start input, but I found that it was quite messy when I was doing this. So I'm just going to say the word like now, but it could be anything. I could say beep boop or whatever. It's just like a start command. OK, so camera is on. I should be all connected. OK, so now, wait. OK, now, OK, cool. So if you, I don't know if it was too small or something, but it said thumbs up and then it said peace sign. I'm not going to show like too many of them, but then you can experiment being like, oh, what can Gemini by default? Oh no, not that. Don't see the mess on my screen. So I'm going to just do that. And yeah, so what was cool here is that the only prompt that I said was like, just look at what you see and just give me a label. And there's a few gestures. I think it can also do thumbs down, or when I do like a stop, then it's usually like it comes back with the label stop. So I haven't tried with like so many gestures, but I'm like, OK, we can start by, if we only want to rely on Gemini, we can get some kind of labels. That's cool, but we want to move on. We want to do something, right, with this gesture or with this recognition. So now we're moving on to function calling because we want something to happen. And here we have to start by declaring some function declarations, which are schemas of like the way you're going to define or how your function is going to be kind of set up. So I have a function here. The name is going to be toggle light. I'm setting a few parameters, and I'm saying that this function should have a parameter that's a type of object, and the properties, it will have a property on. That will be a Boolean, and it's a light, and I'm just describing that this Boolean is going to be the light state as a Boolean, and I make it required. So Gemini should not call this function without the on property that should be a Boolean. And then here, that's like more classic front end, but just so you know that there's not really any magic there. I'm just sending, if the command on is true, then I'm sending to the API the string on or off. I'm using the LifeX light bulbs. So at home, I also have the Philips Hue light bulbs, but you have to connect them with a bridge to your router, and obviously I can't do that if I'm speaking at a conference. So these ones are really cool. As long as you're on the same network, everything, so I'm hotspotting off my phone, it works. And it has like little Wi-Fi chips and stuff in the light bulbs themselves. So yeah, here you just ping the API like you would do on your day-to-day job, probably. And OK, and one important thing as well is that I have to update my prompt to the model, right? Because at the moment, my first prompt, I just had tell me the gesture, but now I have to say, call the toggle light function provided. So once you have the gesture, call the toggle light. But I'm kind of not saying anything else. So, and I'm just passing the function declarations after. So I also wanted to experiment, what can I do with like a very small prompt? I don't have to like write a super big stuff. So let's see if that works. It should, this one should, I know there's a demo that's probably going to fail, but we'll see. OK, so what I'm going to do, OK. Should I tell you before or after? I'll tell you after. Okay. So, OK. Now, did he do it? Oh, OK. Now, that's cool. I'm actually surprised because when I rehearsed earlier, there was a bit of a problem. So what's interesting in that one is that I did not tell Gemini which gesture I was going to make, and I did not tell it the thumbs up means on, thumbs down means off. I just said, make a guess about your gesture, and then call the toggle light on with the on. Well, I mean, I didn't even say with the on property because that's defined in the schema. So what was interesting here is that, well, a thumbs up is usually like a positive gesture. So then, again, I hate talking about AI in like human words, but like it understood that I meant that, it's a positive gesture, so the Boolean should be on. It's a negative gesture, so Boolean should be off. Cool, OK. So far, so good. But what if I have multiple lights? At home, you probably don't have only one light. You might have multiple ones. So then, OK, what do I need to do then if I want to move on to being able to control multiple things? So this is where I move on to multi-turn function calling. I saw it recently called also compositional function calling. There has to be a difference somewhere. I do not know. But if you come across these terms, that it just means calling multiple functions. So the first step that we have to take is in our toggle light function in the schema, we have to add a light ID, right? Because obviously, to know which one that you're going to be able to toggle on, it's going to be either one or the other, so you need to pass in a light ID. That's going to be a number. The description is the ID of the light to toggle, returned by the getLight function. And here, we have to add another object to our schema. So we're going to add a function that's called getLight. And I'm going to add like a property that's going to call like details, basically. And here, I'm saying that it's a string, and the description that I gave it is like the detail about the light, usually a position. And the reason why I specifically in my experiment wanted to use a position is because I don't know the IDs of my light by heart. Even if I was talking to the AI instead of making gestures, I'm not going to say turn light ABC 1, 2, 3, right? So I want to be able to say turn the right light on or turn the left light on. And if you have any of those lights at home, you know that usually when you're setting them up on the app, you can set a custom name. So obviously, so the light on the right is called right light, and the light on the left is called left light. So what I want to try to do is point in different directions. It should understand the way that I'm pointing, either left or right, and then that will be passed to the getLight function, and it will filter through the names of my connected lights and then return the ID and pass it to the other function. So I have to update the prompt again, because now I have multiple lights. So I'm saying, look at which hand is making a gesture, right or left. I probably didn't need to add that, but just in case. And then call the getLight function provided with the correct hand position. Then make your best guess about if the gesture means light on or off, and call toggle light. I think what's interesting experimenting with this is that sometimes you change the prompt just a little bit and have totally different output, for better or worse. Yeah, sometimes it's not that great. But this is the prompt that I'm using for that one. In terms of tool call logic, I'm going to go through this quite quickly because you can look at the code on the repo. But when you use the live API for Gemini, you have different hooks that you can use. And on tool call, so when the AI figures out that you're trying to call different functions, we have two functions here, getLight and toggleLight. Here, it's going to list the functions that I'm supposed to be, or that the AI is supposed to be calling based on the prompt that I gave it. I have an array for the function response parts, because the response from getLight is going to be the ID. I'm going to have to pass it, or it's going to have to pass it automatically to the toggleLight function and things like that. So here, I just loop through the function calls. I extract the name, the arguments, the ID. I just call the function that it thinks should be the first based on the prompt again. And I'm pushing the response in the array, and then it's kind of send the tool response. It's necessarily, you don't have to necessarily really understand exactly what is happening here. It's just you have to understand that the AI will figure out on its own which function to call at what time and how to pass the response to the other one based on the schema that I provided. OK, so this is where there's going to be probably an issue with that one, and I'll explain why after. But the way that this demo should work is I'm going to point to the right. If I'm lucky, probably not, it should turn the right light on. And if I point left, it should turn the left light on. It will probably not work because, weirdly, they are whatever like vision model or whatever they use in the background is not very good at knowing right from left, which I thought was a problem that was kind of solved in computer vision. But let's say that if their model is more kind of tuned to detecting objects and not necessarily body parts, that might be why. But let's see what happens. So if this one fails, I kind of already know, so it's fine. OK. Now,
OK, I have toggled the lights off.
Well, I mean, I didn't want them off, but OK. Now?
I have toggled the lights on.
But it was saying on. Oh, well, OK. So
how are the lights now?
No. OK. So the thing is, I think I don't even remember which finger I was pointing with. But it turned on a light. So I don't know if it figured out right or left, but it did a thing. But again, this is where it's actually interesting that if you're trying to, so if I just talk to the AI, let's say, let me try something. Turn the left light on. No. OK. I'm just going to move on with that one. OK. So let me try that. OK, so this is not the most interesting one. So, OK, so again, maybe later on, or if at some point we can, I think at some point I was thinking, oh, this is where maybe I could augment it with TensorFlow.js, where TensorFlow would know the right from left, and then I could augment that. But this is where I'm going to move on to something else. So let's add TensorFlow.js to Gemini. So here, I'm building up each demo on top of each other. So we still have our getLight function, we still have our toggle light, but I want to set the color. So I want to use fine-grained data to be able to rotate my hands and change the color of the light. So I'm just adding to my prompt. Then if the user is making a palm gesture, I'm not describing what a palm gesture is. I said, if you see a palm, call the setColor function provided. I'm not going to go through what the setColor function is, because it's TensorFlow.js. It just detects the hands, and I do what I'm doing is I'm calculating the angle between the tip of my thumb and the tip of my pinky. And if you imagine a horizontal line, as I'm moving in degrees, basically, I'm changing the hue of the light bulb. I mean, that's what is supposed to happen. OK, so let's see if that works. So this is actually a really exciting one. That's why I want it to work. So just to explain before I do it, the thing is I might have to, OK, I kind of want to see if things are happening. So I might have to do that. Yeah, OK. So what I want to do is I want to kind of build on the demo before. So I want to point to a light. If I'm lucky, it will turn the correct light on. If it doesn't, I think I can still move on. Then I'm going to do the palm. And as I'm rotating my hand, it should change the color. I'm just going to open the console, because if it doesn't work, I'll know. And because it's JavaScript, I'll just refresh. OK. Now,
OK, I've toggled the light on your right.
Now?
I have set the color of the light on your right to red.
Oh, yeah. OK, I'm so happy. All right, cool. So it worked. Yeah. Now, I shouldn't be that surprised. But because it's generative, you also don't know if it's going to work or not, for better, or worse. But yeah, so that was cool. So it means that you can rely on what Gemini gives you out of the box, and then you can also customize with making kind of more interesting interfaces. So it was struggling a little bit. I don't know if you saw it was kind of slow. It's not usually that slow. So I don't know if it's just I need to update the model, or maybe my connection is not good. I'm not sure. So also, I'm over time, so I'm going to rush a little bit. So I'm not going to demo that one, but I want to talk about how I would necessarily do it. So I explained it a little bit at first, but I've been using a platform called DataStax. And you could have, again, because you can see the stream from the webcam in the browser, you can then take screenshots, transform that into vector embeddings. That will be stored then in a DataStax vector database with a description of my gesture. So I'm kind of creating my own custom database of gestures. But it doesn't mean that it would only work on me. It means that then if someone else is using my app, and somehow, transforming into vectors, there's a similarity between a gesture that I already have saved, then it could return the description of that gesture and then feed that to Gemini. So based on the description that you get, do something. And the reason why I wanted to experiment with this is, again, with Google, I don't know where my stuff goes. I don't know if they keep it. I don't know if they don't keep it. And you also kind of get, I know that it's very difficult to recreate an image out of vector embeddings. So for privacy, I feel a little better if I end up installing that in my house and it just looks at me all the time. I would rather know that I'm sending stuff to my custom DB rather than to Google. And also with the Gemini, if I'm doing a gesture that Gemini by default does not recognize, let's say it doesn't recognize, I think it didn't recognize like the Star Trek whatever sign, and it means that if I can train it, I can tell Gemini, hey, when I do this, turn the lights off. But if I refresh, then I'm losing it because it doesn't necessarily save your sample, at least not the free version. So if you do it like if you do this, but you save it into your custom database, then it will always be there. Anyway, so I'm getting to the end of this talk, so I added a few resources, but if you have any question and you want any kind of link, you can reach out to me on Blue Sky, probably more than Twitter. And I'm planning at some point to write a blog post about this, but because it's ongoing, and it will be there, but if you're interested, my website is charliejar.dev. There is already existing research of people who are actually researchers who have published papers about this, and otherwise, I just wanted to kind of and again, on the original inspiration, what I love about experimenting with this is that I feel like it's getting closer to something that could actually be happening only with a laptop. And it means that I really want people at some point to be able to, I don't know, turn these lights on, and then at home they just talk to kind of, I don't know, whatever AI device that they have, and they get to customize the way that they want to experiment with stuff. And in the end, we could have interfaces where you just boom, 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 and just it just learns what you do, and maybe you don't even have to talk to it. It just learns how you work, and you don't have to buy a Kinect. You don't have to have this really big setup. But it means that already 13 years ago, people were thinking about this. I'm still thinking about this, and hopefully maybe at some point, it can actually be embedded in the browser, because now Gemini API is in the browser as well. And we could be hoping, here I showed it with lights, but it does work as well with interfaces. I was thinking, oh, when I do this, refresh. When I do this, change tabs. And if it ends up being then in the browser natively, then people can build their own interfaces. Anyway, I don't know how much over time I am, but I'm definitely over time. So thank you very much for listening, and hopefully you want to experiment with stuff like that as well.
With Datadog, you can monitor your infrastructure, apps, and security posture in one place. Instantly visualize your ever-changing infrastructure. Follow request traces through distributed environments, and get code-level visibility with always-on production profiling. Cut through the noise with automatic anomaly detection, and discover bottlenecks by mapping service dependencies. Datadog ingests all of your logs from any source, helps you optimize front-end performance, and secures your production environment with real-time threat detection. See inside any stack, any app, at any scale, anywhere. Join thousands of customers who rely on Datadog for full stack visibility. Start a free trial today.
What will I build today? Whatever it is, it has to be smart and connected. An app, an experience, a company, my company. Whatever it is, I'll need the right tools, all the tools. I don't want anything holding me back. What will I build today?
AG Charts is a modern open source charting library built for TypeScript, React, Angular, and Vue. Get started by simply providing your data, defining your series type, and then creating a chart. AG Charts provides over 25 different chart types, enabling you to visualize your data in any way you need to, from simple to complex. Learn more and get started for free at aggrid.com/charts.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
With Datadog, you can monitor your infrastructure, apps, and security posture in one place. Instantly visualize your ever-changing infrastructure. Follow request traces through distributed environments, and get code-level visibility with always-on production profiling. Cut through the noise with automatic anomaly detection, and discover bottlenecks by mapping service dependencies. Datadog ingests all of your logs from any source, helps you optimize front-end performance, and secures your production environment with real-time threat detection. See inside any stack, any app, at any scale, anywhere. Join thousands of customers who rely on Datadog for full stack visibility. Start a free trial today.
What will I build today? Whatever it is, it has to be smart and connected. An app, an experience, a company, my company. Whatever it is, I'll need the right tools, all the tools. I don't want anything holding me back. What will I build today?
AG Charts is a modern open source charting library built for TypeScript, React, Angular, and Vue. Get started by simply providing your data, defining your series type, and then creating a chart. AG Charts provides over 25 different chart types, enabling you to visualize your data in any way you need to, from simple to complex. Learn more and get started for free at aggrid.com/charts.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
With Datadog, you can monitor your infrastructure, apps, and security posture in one place. Instantly visualize your ever-changing infrastructure. Follow request traces through distributed environments, and get code-level visibility with always-on production profiling. Cut through the noise with automatic anomaly detection, and discover bottlenecks by mapping service dependencies. Datadog ingests all of your logs from any source, helps you optimize front-end performance.
Thank you. Can I just okay. Oh, I get outside. All right. Scott, do you want to join me for a little bit of raffle fun?
Absolutely.
Awesome. So you've all participated in the Find New Friends challenge, and of course the main prize is that you won some new friends, but we'll also have a little bit of a raffle. We'll pick 3 winners from this bag that Scott is holding. We have a third and a second place that will get a GitNation t-shirt, and the main prize will get a Lego set, so that's really cool. Let's do this thing, yeah?
Yeah, let's do it. All right.
Completely unbiased, yeah, I'm not. All right, third prize goes to, would be really great if they were unfolded already. A DT Conde.
Are we here?
Are we here? I don't hear anyone shouting, so then I'll just continue, yes? Discard.
Give us a woo if you're here.
Yeah. You can take your time getting up here on the stage, but at least let us know that you're here. Katerina Novak?
No Will?
You do look like a Katerina Novak, for sure. All right. Oh my gosh, people. Senway, Anna?
Yeah, it's tight. This is tough handwriting there.
I feel like it's Z-H-E-N-W-E-I.
Yeah.
Woo!
Here, we'll send the T-shirt to the first ones, and this one will be the first place, just to save the time.
And who is first place?
Yeah.
This one, the last
All
one.
right, last one.
We'll get an AI to look at these names and figure out who to send the T-shirts to. And then for... Oh, awesome. We'll give the Lego set to you then. You thought you were getting a T-shirt, but no way. You're getting a Lego set.
How bad?
All right.
Congrats. Thank you.
Thank you so much.
And the next one.
Right.
All right, raffle number 2. Let's check how many steps you've done today. So who out there thinks they've done the most amount of walking today and can back it up? I totally believe that.
I had to go, up and down, up and down. I feel like I'm.
All right, so does anybody have more than 10,000 steps?
Okay, some hands.
All right, we got a couple of hands, okay. How about more than 15,000 steps? We have one. Do we have anybody else? Raise them high if you got anybody else.
I feel like we're at an auction.
All right, we got at least 2 here. All right. How about 20,000 steps?
If you claim 20,000 steps, we want to see proof, yeah? Do you want to reconsider? Okay.
All right, 25,000 steps?
I still see one hand.
Wow.
Come up here and show us.
That's a lot of steps.
Just a couple more steps, yeah.
I had to run all the way from the back.
It's fair enough. If you walk that much all day, it's fair enough if you're... we got...
I would have proved that, actually.
I don't know. Maybe you have a device, you know?
I just have
you were
muscles.
Oh, I thought you were just counting in your head the whole time.
Oh, no.
That's
just
pretty
feel
impressive.
it,
You just feel it.
Yeah. My body talks.
Sure. Do we award vibes? Yeah.
I guess so.
guess we do. You get a jump rope, so you can exercise even more.
Oh, that's easy. Yeah. I do that all day. Oh, thank you.
All right, that is it for the talks today, and also, I believe, the raffles today, so that's good news. Let's take a short moment to thank our media partners for helping us spread the word about this conference. We truly appreciate their support, and here they are on the slide. All right. It's a wrap, but of course, our remote audience, please don't go anywhere, because you have a whole half of all of the talks still ahead of you while we wrap up here.
What will I build today? Whatever it is, it has to be smart and connected. An app, an experience, a company, my company. Whatever it is, I'll need the right tools, all the tools. I don't want anything holding me back. What will I build today?
AG Charts is a modern open source charting library built for TypeScript, React, Angular, and Vue. Get started by simply providing your data, defining your series type, and then creating a chart. AG Charts provides over 25 different chart types, enabling you to visualize your data in any way you need to, from simple to complex. Learn more and get started for free at aggrid.com/charts.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
With Datadog, you can monitor your infrastructure, apps, and security posture in one place. Instantly visualize your ever-changing infrastructure. Follow request traces through distributed environments, and get code-level visibility with always-on production profiling. Cut through the noise with automatic anomaly detection, and discover bottlenecks by mapping service dependencies. Datadog ingests all of your logs from any source, helps you optimize front-end performance, and secures your production environment with real-time threat detection. See inside any stack, any app, at any scale, anywhere. Join thousands of customers who rely on Datadog for full stack visibility. Start a free trial today.
What will I build today? Whatever it is, it has to be smart and connected. An app, an experience, a company, my company. Whatever it is, I'll need the right tools, all the tools. I don't want anything holding me back. What will I build today?
AG Charts is a modern open source charting library built for TypeScript, React, Angular, and Vue. Get started by simply providing your data, defining your series type, and then creating a chart. AG Charts provides over 25 different chart types, enabling you to visualize your data in any way you need to, from simple to complex. Learn more and get started for free at aggrid.com/charts.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
With Datadog, you can monitor your infrastructure, apps, and security posture in one place. Instantly visualize your ever-changing infrastructure. Follow request traces through distributed environments, and get code-level visibility with always-on production profiling. With Datadog, you can monitor your infrastructure, apps, and security posture in one place. Instantly visualize your ever-changing infrastructure. Follow request traces through distributed environments, and get code-level visibility with always-on production profiling. Cut through the noise with automatic anomaly detection, and discover bottlenecks by mapping service dependencies. Datadog ingests all of your logs from any source, helps you optimize front-end performance, and secures your production environment with real-time threat detection. See inside any stack, any app, at any scale, anywhere. Join thousands of customers who rely on Datadog for full stack visibility. Start a free trial today.
Before we start with our first talk, let's greet our platinum sponsor, Hands on Table, Data Grid with spreadsheet superpowers. Don't forget to post your questions via Slido during the talk, and we'll ask them after the talk. Slido.com, use the code 0612, or scan the QR code, which we've now put up several times. And with that, it is time to introduce our first speaker, Sasha Grief. Sasha is the creator of the State of JS survey. His talk is The State of the Web. In this talk, we'll take a behind-the-scenes look at running the State of series of developer surveys, State of JS, CSS, as well as lessons learned and upcoming trends. Sasha, the stage is yours.
Okay, hi everybody, welcome to JSNation. My name is Sasha Grief, and today I'm going to talk about the state of the web. And now I realize this is a pretty broad topic, so more specifically, what I have learned about the state of the web through running web development surveys. So what do I mean by that? Well, every year I organize a bunch of open surveys online. Anybody can take them. The biggest one is probably the state of JS, but there's also state of CSS, state of HTML. And just out of curiosity, raise your hand if you've taken one of these surveys before. Okay, so quite a few people. So first of all, thank you for participating, because if you didn't, I probably wouldn't be here talking about it today. But I don't have that much time, so I want to jump right in and talk about the state of JS. The latest edition took place in November of last year. And as you might imagine, I asked developers a lot of questions. And that's actually what I want to do with you guys today as well. Because this is not going to be a boring old talk. It's going to be a live interactive quiz. Now, I know what you're thinking. They just showed you another quiz. I didn't know that. I thought I was being very original and very innovative. But at least my quiz won't have any trick questions about Greta Thunberg or Billie Eilish. And so, well, you might be thinking, how do I participate? How do I, keep track of my score? And you can do that using something almost all of us have today, which is this, your fingers. So you can count on your fingers. We will all start with 3 lives, and then for every wrong answer, you lose 1. And we'll see who makes it all the way to the end. There will only be 10 questions, so hopefully a bunch of you make it through. But let's start with a really easy one. What were the 3 most used front-end frameworks in the latest State of JS survey? So A, Svelte, Solid, HTMX, all great libraries, but maybe not the most widely used. B, Backbone, Knockout, and Mootools. Now, if you've never heard of these, don't worry, you haven't missed like the newest front-end library coming out the past couple weeks. It just means you're probably under 30 years old. And then C, React, Vue, Angular. So I think it's easy enough to figure this one out. Of course, it's C, React, Vue, Angular. Number 2, so in the survey, we asked not only what respondents use, but also how they feel about it. So people could say if they like or dislike the framework they use. And one framework in particular had a lot of positive opinions and came in first. And so which one do you think it might be? I'll give you a couple seconds to figure it out. The answer was C, Solid. So if we look at the data, these are the State of JS results. Solid is actually that yellow-orange line all the way at the top. And not only was it #1 last year, it has been #1 for the last 4 editions. So pretty impressive. #2 is Svelte, the green line, and then #3 is actually Vue.js making a comeback to get #3. So these are rankings, but if you look at the absolute value, you can actually see that most libraries are towards the top of the charts here, above 70% satisfaction. So I think that's interesting because we often have this image of JavaScript developers complaining about their framework and being quite negative. But the truth is, when you look at the data, people actually enjoy, for the most part, using those frameworks. And I think that's a testament to the work being done every day by the maintainers of each of these projects. So let's talk about TypeScript. Question number 3. Among survey respondents, there are more developers who A, only use JavaScript, B, use 50% JS, 50% TypeScript, or C, only use TypeScript. Now, this is among survey respondents, right? So it's not necessarily among the entirety of the JavaScript population throughout the world, but among the subset of respondents who took the survey, turns out the largest group is C, people who only use TypeScript. And if you look at the chart, it's actually quite striking that the largest bar here at the bottom is people who use 100% TypeScript, while at the top you have a few people who don't use it at all. And I think it goes to show that today TypeScript, not only is TypeScript mainstream, but it's actually becoming the default way of writing code for the web. So there's this thing called the TC39 committee, which decides on which features the JavaScript language is going to get next. And they consider a lot of proposals every year. But one of them is not a real proposal. So is it A, explicit resource management, B, temporal, C, reverse threading, or D, decorators? So which one do you think is the fake proposal? And the answer is C, reverse threading. That's not a thing. The other ones, though, are very real, and in fact, they are the first 3 results when we asked respondents which upcoming proposals they were the most excited about. And so #1 here by a long shot is temporal, which is going to be a new way to handle dates and times in the browser, and which hopefully will let us rely a bit less on third-party libraries like Moment.js and so on. Now, reverse threading, in case you're wondering, is something that has to do with bolts and screws. But who knows, we might have it in JavaScript too at some point. So, OK, I know, don't run away. I know it's not CSS Nation today, but I still wanted to include a couple questions about CSS. And in the survey, we asked respondents which feature they had enjoyed the most over the past year. So not necessarily something that came out in the past year, just something that they started using. And so which one do you think was #1? Has, add container, subgrid, or float right? It's probably not going to be float right, because even back then, nobody enjoyed it that much. But the real answer is actually A, has. Now, has is a really cool new CSS feature that lets you basically target an element not based on its parents, like you would usually do in CSS, but on its children, so what it contains. And it really opens the door to doing a lot of new things with CSS. And so that was people's favorite new feature. But you might be thinking, well, that's all well and good to have all these new fancy CSS features, but it's not really that useful if you can't actually use them in browsers. So that's what this next question is about. As of June 2025, which of the 4 major browsers support the CSS has selector? A, none of them. B, only Chrome. C, Chrome and Firefox. Or finally, D, all 4. So which browsers support has? And the answer is actually D, all 4. So there's actually this thing called a baseline indicator, which is a standard, a convention developed by browser vendors to let us know what's safe to use or not. And has the status newly available, meaning it is supported in all 4 browsers and has been, in fact, since December 2023. By the way, when you are browsing through the State of CSS survey results, you can actually click any feature and get extra info on it, including the baseline status and also links to MDN, Can I Use, and other resources. So another survey we did last year was the State of HTML, and I want to stay on the topic of baseline. So here's another question. If the baseline indicator says a feature is widely available, which is the final stage of baseline, it means it's A, supported by a majority of users, B, used by over 50% of the top 100 websites, C, supported by major browser for 30 months, or D, available at your local supermarket. So probably not D. But the real answer is actually gonna be C, supported by major browsers for 30 months. And that's the case of a feature like aspect ratio, another CSS property, for example, which might seem like it's fairly new, but in fact, it's been over 2 years, 30 months, since it became newly available, since it became well supported. So this issue of browser interoperability is something that we ask a lot about in the surveys, including here this question in the State of HTML survey, which is about the features that people would want to use but cannot because of poor browser interoperability, this is really hard to say, or browser support. And number 1 here is the popover API, followed by anchor positioning, and the View Transition API. Now, what's interesting to know, I think, is that there's actually an initiative from browser vendors called Interop, which is that every year they get together, so the Chrome team, Safari, Edge, Firefox, and so on, and they decide which areas to focus on to fix those problems so that we can all use these cool new features. And so in 2025, the focus areas are anchor positioning, backdrop filter, core web vitals. And what's cool is that one of the ways that they prioritize these features, one of the data points they consider when drafting that roadmap is the data from the State of HTML survey, the State of CSS survey, and so on. So I think it's quite cool to know that the browser vendors are actually receptive to feedback, and that one of the ways you can make your voice heard is by completing these surveys. But let's switch gears now and talk a little bit about AI. So we had another survey called the State of Web Dev AI, and there's a ton of AI surveys out there. A lot of them are even called the State of AI, so I'm not the only one. But what makes this one different is it's not a survey of AI developers, it's a survey of how web developers, like all of us basically, use AI, or maybe don't use AI, because that's really what I wanted to figure out, like how common is AI use really? So here's a question for you guys. What percentage of respondents to the survey do you think generate the majority of their code via AI? So not even like all their code, just more than half of their code. And I have to say the result kind of surprised me when I saw it, because it turns out only 22% of respondents fit in that bucket. So, yeah. So you can see here at the top of the chart is people who do not use AI at all. And at the bottom is the people who use AI for everything, and there's only 11 of them. And the majority is in the middle, or actually towards the top of the chart. And that's my case speaking personally. So I use ChatGPT from time to time to maybe generate a helper function or a component or some styles. But I haven't used Cursor or any of the newer tools to vibe code entire apps just before breakfast, like you see on social media. And I think that's still the majority of people in that case. So if you are like me, like a lot of survey respondents, still coding apps by hand, don't feel bad about it. Don't feel any FOMO towards the AI crowd, because I think we are still the most common use case. And finally, the last survey I want to talk about today is the state of devs. So this one took place in April of 2025. So it's very fresh, and in fact, it's so fresh that the data isn't even out yet, so you're getting an exclusive sneak preview of those results. The other thing that makes this survey special is that, unlike the other surveys, which were about JS, CSS, AI, this one was not about code at all. Instead, it was about all the other things that make us who we are, your career, your workplace, but even things like your health and hobbies. So as part of that survey, one thing we asked about was your job title. And it turns out there's one kind of job title in particular which is correlated with a higher income. So do you think it's A, developer, B, engineer, C, webmaster, or D, consultant? Now, as much as I personally would like webmaster to make a comeback, I think it's, the 90s are cool again these days, so who knows? Probably not going to be C. But the answer, it turns out, is B, engineer. So if you look at the data, here are job titles with median income. And if you look at all the engineer jobs, they tend to be at the top, while the developer jobs tend to be more towards the bottom. So with the caveat that correlation is not causation, just to be safe, I would suggest updating your resume and switching from front-end developer to front-end engineer, if you can. And finally, our last question of the day. The top hobby enjoyed by developers is A, video games, movies, reading, or sport. Now, hey, don't laugh. That's not fair. I think a lot of developers do enjoy sport. In fact, I do bouldering, so if anybody want to go climbing later, let's go together. But no, sadly, the stereotype is true. So for extra credit, does anybody want to guess what the most popular specific video game was? Just yell out some video game names. Yeah? Pac-Man? No, sorry. Maybe in the 1973 survey, Pac-Man would have won. But in the 2025 survey, the result was Baldur's Gate 3. Yeah. And that game came out not that recently, but I think it's so long that people are still playing it. Number 2 was Balatro, which I also played, but I had to stop pretty quickly because I could feel myself getting addicted by the minute. So let's count how many lives remaining we have. If you have 0 lives remaining, you didn't make it to the end, sorry, but you can still call yourself a developer. Now, if you have 1 life remaining, you survive, congratulations. You can upgrade your title to architect. So instead of front-end developer, you're now a front-end architect. It's the same thing, same job, but it sounds a lot fancier. If you have 2 lives remaining, you only made a single mistake. So you are a very reliable person. You can be lead, front-end lead, and lead us to our promised JavaScript future. We'll follow you. But now, if you have all your lives remaining, raise your hand. Let's see. Nobody? Really? I'm sure there's going to be at least one person. So hypothetically, if somebody had survived with all their lives remaining, they would deserve the ultimate title of engineer. So what have we learned today? Probably not much, but still. One, you can use more new CSS features than you think. Thanks to tools like Can I Use and Baseline, it's easy to keep track of new CSS features, and the browser vendors are doing a really good job these days of making sure that they quickly become supported. 2, TypeScript is now the default. It took me a really long time to start using TypeScript myself, but I think it's just the way the ecosystem is going at this point. 3, most developers don't use AI that much, at least not yet. People are talking about developers being replaced by AI. I don't think that's going to happen because, after all, there will still need to be people who write code manually, if only for AI to be able to plagiarize it. And then, finally, the web is changing fast, and surveys can help you keep up. Not only because when you take the survey, you are exposed to a lot of new features, new libraries that you might not know about, but also when you review the results, you can learn about upcoming trends, and the results themselves can serve as a jumping-off point to browse other resources. Speaking of taking surveys, there is a survey open right now, the State of CSS 2025, so you can go ahead and take it right now. Well, maybe not right now, wait until the end of the event. But yeah, I wanted to thank you for taking the surveys. Thank you for participating in my little quiz. And I hope you have a great JS Nation. Thanks.
So get your questions in over at Slido. Sasha, you can come right over here.
Oh, okay.
And while we let these questions come in and I get connected to the internet here.
Sure.
Yeah, let's kick it off with just a question I have for you. What is the biggest challenge in reaching people with this survey?
Wow, that's a great question. So I think it's a dual challenge. Here.
Oh,
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
With Datadog, you can monitor your infrastructure, apps, and security posture in one place. Instantly visualize your ever-changing infrastructure. Follow request traces through distributed environments, and get code-level visibility with always-on production profiling. Cut through the noise with automatic anomaly detection, and discover bottlenecks by mapping service dependencies. Datadog ingests all of your logs from any source, helps you optimize front-end performance, and secures your production environment with real-time threat detection. See inside any stack, any app, at any scale, anywhere. Join thousands of customers who rely on Datadog for full stack visibility. Start a free trial today.
What will I build today? Whatever it is, it has to be smart and connected. An app, an experience, a company, my company. Whatever it is, I'll need the right tools, all the tools. I don't want anything holding me back. What will I build today?
AG Charts is a modern open source charting library built for TypeScript, React, Angular, and Vue. Get started by simply providing your data, defining your series type, and then creating a chart. AG Charts provides over 25 different chart types, enabling you to visualize your data in any way you need to, from simple to complex. Learn more and get started for free at aggrid.com/charts.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
With Datadog, you can monitor your infrastructure, apps, and security posture in one place. Instantly visualize your ever-changing infrastructure. Follow request traces through distributed environments, and get code-level visibility with always-on production profiling. Cut through the noise with automatic anomaly detection, and discover bottlenecks by mapping service dependencies. Datadog ingests all of your logs from any source, helps you optimize front-end performance, and secures your production environment with real-time threat detection. See inside any stack, any app, at any scale, anywhere. Join thousands of customers who rely on Datadog for full stack visibility. Start a free trial today.
What will I build today?
Now it's time to meet another one of our platinum sponsors, Datadog. Datadog provides unified observability and security. So once again, don't forget to pass your questions via Slido during the talk, and we will ask them after the talk. Slido code 0612. Our next speaker is Matteo. Matteo is the co-founder and CTO of Platformatic.dev, with the goal to remove all friction from the back-end development. He is also a prolific open source author in the JavaScript ecosystem. His talk is The State of Node.js 2025. Matteo will talk about the state of Node.js 2025. Together, we'll debunk myths, highlight recent enhancements, and demonstrate its robust performance in today's tech landscape. Matteo, the stage is yours.
Hello. Hey. Hi, everyone. Thank you, Scott. So, me. Hi, hello. Lot of things. You're probably using my software. Last year, you all downloaded my things 30 billion times from NPM. So, don't tag me. We are going to talk about two things. You very often see, this is one of my favorite slides, by the way, see these kind of statements that XYZ will destroy Node.js. This was fun. And that XY will flip the default backend runtime from Node.js. This happened. These are quotes. OK, so this talk is to answer one question to all of you. Is Node.js dead yet? Every single one tried to kill Node.js, and I don't know. Is it still dead? Is dead? No, it's not. There's one secret, one really dark secret in technology, and like everybody that tried to destroy some tech. Well, the first secret is that a technology that was born in 1959 is on the rise again. Do you know what it is? It's frigging COBOL. It's frigging COBOL, OK? To be clear, this is a career in that kind of things, OK? So also jQuery recently released version 4, and is still powering a good chunk, most of the web so far. And by the way, if you're still using jQuery 1, you have a problem. But a lot of people still are. So, OK, hi, Node.js 16th birthday. OK, so Node.js is one of the most popular technology according to Stack Overflow, recently overcome by React, but still up there. Also, unfortunately, these graphs are not there yet. The last one was from 2024, then this site died. But it's a good comparison of the size of and growth of the NPM ecosystem versus the others. And it's, NPM and Node is essentially two sides of the same coin. And the NPM ecosystem did a phenomenal thing and is the most popular open source registry out there of things to download. Modulo usage is growing more or less 50% every year, and it doubles every 2 years. You're downloading a lot of modules, guys. I don't know. It's not going down. It's not slowing. So some important stats is half of the downloads are header files. Do you know why? What are header files? Header files, when you have a binary add-on and you install a module from NPM, if you haven't installed the binary add-on every single time, you are downloading the header files to compile that binary add-on. It's done automatically for you. You have to do nothing. But every single time you do that, you compile some things, it downloads these header files. So this is why it's so massively downloaded everywhere. OK. Also, a lot of downloads from Node overall were 271 million downloads for Node.js in December 2024, OK? And in May was 375 million downloads per month. So apparently, you guys are still downloading Node even more. I have no clue why. OK? You keep downloading new version. Well, I have some numbers here. OK? So first of all, you're not updating Node.js. So we keep releasing new version of download, new versions of Node, OK? And you're still downloading it. In fact, Node 12 is growing. Look over there. Oh, sorry. Why? Where is it? Come on. OK. And here we go. Node 12 over there. You see the red one is rising. This, I have no clue. Yeah. Anyway, you're not updating Node, OK? Are you? Why are you not updating it? So, first of all, quick reminder. Quick check for the audience. How many of you are using Node 12? OK, the downloads. OK, no, I'm joking. So Node 18 has gone out of support in April. Huge amount of people are still using Node 18. In fact, we are going back here. Is very funnily, is still downloaded 50 million times, in May. It's insane, OK? 50 million times in May, and is out of support. What are you going to do about it, guys? Sorry. OK. Node 20 is in maintenance mode. What does it mean? It does not getting new features. It's only getting bug fixes. It's getting, security fixes, but, on a best effort situation. Node 22 is what's so-called active LTS. And Node 20 active LTS means it's getting new features every single time. Okay, we are going to talk a little bit more about the new features that are coming and we have backported. In October, it will go into maintenance mode. And Node 24 is going to be the new active LTS. Please, guys, update. Something very important, and you can see it here, is that a lot of people skip a version, okay? So a lot of teams skip a version. This is Node 16, okay, going down, still downloaded, I don't know, 30 million times per month. I have no, sorry guys, I'm flabbergasted, okay? But a lot of teams are, you see that a lot of people are jumping from Node 16 to Node 20 straight away, okay? And, but the number of downloads are, as I say, growing and growing and growing and growing. The activity in the organization is growing, okay? A lot of pull requests open, a lot of PRs open in the project. Lot of things happening, a lot of new people showing up and contributing. In fact, there's been a lot of, more or less, the activity is going very well. Number of incoming pull requests is stable, but there is still a lot of new features, a lot of new things being worked on. So something very important is about updates, okay, and security. So the Node project works very hard to keep you all safe and give you a nice security release every quarter. Do you like our security releases? Maybe, probably not, okay? We don't like them either, but it's, we live in this world. We receive a lot and a lot of submissions, okay? Something about between 20 and 30 per month, which is a lot. Imagine that you need to, for each one of them, you need to triage them privately, and 90% are completely bogus. And it's a lot of work that happens underneath the scene. And it's a lot, there is a threat model, please read it. There is a lot of them are valid, but, And we usually respond very quickly. So we respond in less than a day. It's very active. And the time for triaging, so we respond, we say, hi, start some questions, and then we do the final triaging in a day or so, in a few days, which is pretty good. Some of these was funded by a fund called Alpha Omega. I don't know if you're familiar with it, but you probably should. It's great, and it gives us some funding to streamline our security and to have some people working on it. And this is the only amount of money that Node.js has, by the way. So if you think how Node.js is giving it to you, is volunteers, people, and generic love, okay? And in fact, the funding was cut in half in 2025. So you see, we got 300, 275, 300, and now 150. Okay. Few things that are coming to Node. First of all, we have require ESM. I don't know if you've heard. Okay, it's there. You can do require ESM. Okay, it just works out of the box, okay, if you're using latest Node. Also, .mjs is not needed anymore because nobody liked that Michael Jackson script. And so you can just run it, and it just works, okay? It will complain, tell you, hey, this is a warning. If you load files this way, it'll probably be a little bit slower, but do this to update. Anyway, finally, we run TypeScript out of the box. But the applause is for Marco Ippolito that implemented this and is speaking about it in extense in the next talk. So I will leave it to him to do. Look in the agenda, go watch his talk. It's fantastic. You should absolutely look at it. We hope to get this, it's unflagged in 24. And we hope to get it stable by the time the 24 goes LTS, which is very important. And hopefully, finger crossed, we can get it unflagged on node 22. We'll see. So very important thing, there was a change in V8 and that allowed us to improve the performance of OpenTelemetry tracing by roughly 7%, which is pretty solid, I would have to say. It also makes a lot of things based on async local storage significantly faster. So you probably want to check it out. There is a lot of new things coming with that, thanks to that. Anyway, async local storage got faster. Your OpenTelemetry integration got faster, which is great. I have some benchmarks if you want them. I need to open source that repo. Last but not least, explicit resource management or using. I don't know if you're familiar with this new feature of the C39. It's you can do using a variable. And that variable will be automatically, you can do essentially a finalizer or a deallocation when you exit the scope. It already works for timers, okay, and other APIs on Node 24, but we are in the plan on adding this through all of them. Why this is useful? Because you can essentially, you will be able to use a file or use a stream, and those will be automatically deallocated and cleaned up correctly, especially if there is a native resource underneath. And it's also worth sync and async, so it's pretty great. We stabilized the permission system. You know, a lot of companies have been complaining, saying, well, a lot of people say, oh, but Node.js is not secure. Well, we have the permission system, it's there. There's a lot of tutorials and things that you can use. And it allows you to essentially constrain the part of the file system that your process can read and write. We are also adding networking soon. Pretty good. So, are you still using Node? Are you using any of the modern features of Node, or are you still stuck in 2015? Okay. So, a couple more things. Node.js needs you. Node.js needs volunteers. Node.js needs collaborators. It's the key part there is Node. We need people. Why? Because Node.js is an open governance model. And what does this mean? Well, we are part of a foundation, and there is nobody that is actually paid by the foundation to work on the project. Okay? So, minus the security things. What does it mean? It means that Node.js is governed by its collaborators, and they contribute to the Node.js project. They are all volunteers. Some of them are volunteered by their company that gives you, a salary for putting bread on the table. But the project is run by the collaborators. What does the technical steering committee do? The technical steering committee is the governing body, and it always acts when the collaborators do not agree. There are 100+ people. What's the chances of 100+ people not agreeing? 100%. So anyway, not necessarily that. Usually people can find a compromise, okay? But generically, this is the situation. We said, so the technical steering committee, which I'm part of, set the release dates, quality, and so on and so forth. The bit is when we disagree, the TSC votes. Okay, that's what we do. When there is a disagreement, we vote. That's it. So this means that no one can control Node. Okay, there is only a very limited number of people of the same company, the Node.js TSC. So essentially means that Node.js cannot be controlled. And usually each collaborator has to compromise to achieve its objectives and goals. It's very important to note, open governance, there is no benevolent dictator, we tried all of that. We tried companies, the benevolent dictator, nothing worked for Node, okay? So it's a community project. What does it mean is there is nobody to fix your bugs, okay? So if you have a bug, probably the best person to fix your bugs is you. Let me clarify that. We could fix some bugs. You can probably try to find a collaborator to help you fix the bug, but most of the time, you are responsible for your own. There are a few companies out there that can help you if you want to contact them, but generically, the project is not, fixing your bugs. So, okay, I have 3 more minutes, and I have a few gifts for you. The first gift is an ebook that we wrote. Is free. You can download and scan. You pay with your email. 250 pages or something of goodness. So we condense a bunch of stuff. You can download. It's free. Okay. But you will get emails. Thank you. It's authored by Platformatic, my company. So that's it. Okay. Then I wanted to talk a little bit about some stuff that I released last year, which is an application server for Node.js, which makes your applications enterprise grade out of the box. What it does, it runs your application in it's streamlined multi-threading, running multiple Node.js applications within the same thread, within the same process using threading, and standardizing probe, logs, metrics, OpenTelemetry, and so on and so forth. These allowed us to do a few good things. Well, we made it run PHP. I don't know if you saw the announcement, but I'm going to recap. You can, thanks to our new tech, Platformatic tech, we are able to run PHP inside Node.js as a native add-on on a separate thread. So you could essentially create a single process in which you have your Next.js application and your PHP application. Now, I'm going to speed run an installation of WordPress here. So we have just downloaded WordPress, and I'm starting WordPress using npm start. And all of these works essentially inside Node, thanks to a native add-on that is compiled. That is a full version of PHP 8.4 compiled down. And you just need to essentially configure, install it, and it will just essentially work. How does it work? It runs PHP on a separate thread. And in that way, it can block and do all those things. Also, you can use it to run it alongside your, I don't know, Next.js application or either front-end stuff, which is pretty cool. And here I'm speed running it because I didn't have enough time. So anyway, what we do, we need to configure both apps. So we have the Next.js application here and the PHP application. So we have a PHP and we need to build next. Okay. And yay, fantastic. Build, and we build, you go. Multiple mistakes, you see. I'm human. And running it and npm starting it, and you see here is the full thing for PHP. It needs a little bit of tweaks for parameters and WordPress, and then Next.js is there. Now, how do you connect Next.js with PHP? You just need to change your page and specify a different URL, and then we can do. What we can do is we can have a full headless PHP rendered by a full blog rendered by Next. Cool. Thank you very much. I have the book. If you need any help with Node.js, please reach out. Matteo@platformatic.dev. Thank you.
What will I build today? Whatever it is, it has to be smart and connected. An app, an experience, a company, my company. Whatever it is, I'll need the right tools, all the tools. I don't want anything holding me back. What will I build today?
AgCharts is a modern open source charting library built for TypeScript, React, Angular, and Vue. Get started by simply providing your data, defining your series type, and then creating a chart. AgCharts provides over 25 different chart types, enabling you to visualize your data in any way you need to, from simple to complex. Learn more and get started for free at aggrid.com/charts.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
With Datadog, you can monitor your infrastructure, apps, and security posture in one place. Instantly visualize your ever-changing infrastructure. Follow request traces through distributed environments, and get code-level visibility with always-on production profiling. Cut through the noise with automatic anomaly detection, and discover bottlenecks by mapping service dependencies. Datadog ingests all of your logs from any source, helps you optimize front-end performance, and secures your production environment with real-time threat detection. See inside any stack, any app, at any scale, anywhere. Join thousands of customers who rely on Datadog for full stack visibility. Start a free trial today.
What will I build today? Whatever it is, it has to be smart and connected. An app, an experience, a company, my company. Whatever it is, I'll need the right tools, all the tools. I don't want anything holding me back. What will I build today?
AgCharts is a modern open source charting library built for TypeScript, React, Angular, and Vue. Get started by simply providing your data, defining your series type, and then creating a chart. AG Charts provides over 25 different chart types, enabling you to visualize your data in any way you need to, from simple to complex. Learn more and get started for free at aggrid.com/charts.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
With Datadog, you can monitor your infrastructure, apps, and security posture in one place. Instantly visualize your ever-changing infrastructure. Follow request traces through distributed environments, and get code-level visibility with always-on production profiling. Cut through the noise with automatic anomaly detection, and discover bottlenecks by mapping service dependencies. Datadog ingests all of your logs from any source, helps you optimize front-end performance, and secures your production environment with real-time threat detection. See inside any stack, any app, at any scale, anywhere. Join thousands of customers who rely on Datadog for full stack visibility. Start a free trial today.
What will I build today?
Bye.
What will I build today? Whatever it is, it has to be smart and connected. An app, an experience, a company, my company. Whatever it is, I'll need the right tools, all the tools. I don't want anything holding me back. What will I build today?
AG Charts is a modern open source charting library built for TypeScript, React, Angular, and Vue. Get started by simply providing your data, defining your series type, and then creating a chart. AG Charts provides over 25 different chart types, enabling you to visualize your data in any way you need to, from simple to complex. Learn more and get started for free at aggrid.com/charts.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
With Datadog, you can monitor your infrastructure, apps, and security posture in one place. Instantly visualize your ever-changing infrastructure. Follow request traces through distributed environments, and get code-level visibility with always-on production profiling. Cut through the noise with automatic anomaly detection, and discover bottlenecks by mapping service dependencies. Datadog ingests all of your logs from any source, helps you optimize front-end performance, and secures your production environment with real-time threat detection. See inside any stack, any app, at any scale, anywhere. Join thousands of customers who rely on Datadog for full stack visibility. Start a free trial today.
All right, before we get going on the next speaker, our next platinum sponsor is AG Charts. AG Charts is a high-performance JavaScript charting library from AG Grid, supporting all major frameworks and is available as both a standalone tool and integrated with AG Grid. You can learn more about that at ag-grid.com/charts. And another reminder to don't forget to ask your questions during the talk on Slido. And we will ask them to the speaker after the talk. The code is 0612. Our next speaker is Alex. Alex is a partner program manager on the Microsoft Edge team and Blink API owner. His talk is Front-End's Lost Decade and the Performance Inequality Gap. This talk digs into the network and device reality we must confront and why our future as web developers depends on what we do here and now. Alex, the stage is yours.
Thanks, Scott. Hi, I'm Alex Russell. I am a product manager, which is all weird to say. I do an engineering job. I did an engineering job before I joined the Edge team for 12 years on the Chrome team at Google. And before that, I spent a decade on TC39, building JavaScript frameworks and libraries. And when I joined the browser side of the world, I went to try to make sure that the trailing edge could move up to meet us at the front of where the web was being developed. We want experiences to be made out of the best stuff because a lot of the stuff in the ecosystem is hard to move, right? It's hard to get people to change their devices. It's hard to get people to change their operating systems. And in many cases, the easiest thing you can possibly do is to get people to update their software. And so I joined the Chrome team to build something called Chrome Frame, where we shoved Chrome as a plugin into IE. Don't ask. All that is to say that all of that work since I sort of switched jerseys to work on browsers has been an attempt, working on TC39, helping to lead teams that designed async and await and promises and service workers and classes and Project Fugu and all that kind of stuff. All of that has been about trying to bring us closer to what native developers expect a platform to do, not because there's some sort of envy, but because what winning looks like for a platform is for users to spend more of their time using applications that are built in that platform, right? We are all connected here under this roof as an ecosystem, even if we don't know each other individually. It is the success of our peers and the products that are to the left and to the right of us that make us more successful or less able to deliver. And to do a good job of that, we have to apply the principles of engineering. Right? We have to understand what the constraints are that we're going to build to, and then we have to build solutions to the problems that people come to us with, and use what we know to build to those constraints. Which is to say that anything that you might see in a survey, a popularity contest effectively, is immaterial to the question of whether or not you are doing a good job as an engineer, because the fitness function for engineering isn't whether or not your tool is popular. The fitness function for engineering is whether or not the result works well for end users, the people that you're actually building and designing for. Okay, so let's take that as the North Star. That's what we want to do. We want to do engineering. How do we do it? Well, we have to understand our limiting factors. What are the things that we are building underneath? What is the environment that we're building in to solve the problems? Because that should determine, for instance, what materials we use, what properties they should have, how much of it we can afford, right? There's going to be a budget. All of those things are important in sort of other kinds of engineering, and they're just as important in our engineering. So what are our limiting factors, and are we actually building to them? Yeah. Let's find out. So we have a couple of constraints. The first is, of course, the amount of CPU graphics performance and storage performance that we've got on any specific device. That is a shared resource on the web. We're heavily sandboxed. I always say that web developers don't send edicts down the wire, they send hopes, right? It's influence-oriented programming. You send something from the data center and you're very lucky if it comes out the other side in any of the ways that you expected it to because of different browser runtimes, extensions, browsers mediating your content in ways that you don't expect, and the huge diversity of devices that the web targets, right? We're not targeting a single narrow ecosystem of a specific set of users, we're targeting all users on the web. So the set of all users that you would like to address, the properties of their devices turn into a big problem for us, as do the networks that they connect over. And that is a huge diversity. That is not sort of a narrow target. And of course, the browsers that users use define the software ecosystem that we can program to. We can only target the APIs that we believe are available. And so these are the three things that I think we should be keeping in mind when we sit down to try to solve a problem for a user. You'll note that there's nothing in here about frameworks, right? This is about what the platform does. This is about the hardware and the networks that the platform is operating on. These are the actual constraints. Nothing about what you prefer to write or how you'd like to spell your angle brackets has anything to do with these properties. So, what does failure look like? Unfortunately, we've got some very punchy and front and center examples of that failure mode. These are the pass rates for Core Web Vitals, Google's Chrome User Experience Report derived set of histograms, which you'll know as interaction to next paint, large contentful paint, and cumulative layout shift. And so only 38% of mobile sites are passing Core Web Vitals, right? Like, this isn't a passing grade in any course I ever took, right? I would be surprised if it was for you. And that is to say, even on secondary pages where large amounts of hopefully the first top-level content are cached because you use the opportunity of going to the top page to get to the second page, only half are passing on mobile. And mobile is where users are. I put together some of the data from the Web Almanac last year to try to understand why is it that popular tools, or what is it that popular tools are doing in terms of helping us out? Are we getting what we expected from our investments in the tooling that you will see heavily marketed and therefore showing up at the top of the surveys that you heard about this morning? And the answer is that many of the tools that are most heavily funded, most heavily used, and most heavily marketed specifically, left their users in the lurch the most. That is to say that the developers and the sites that adopted those tools specifically, the popularity contest winners, found themselves with the worst results when Core Web Vitals moved from first interaction delay to INP, which is to say the more honest the metrics got to what the actual end user experience was, the worse the sites looked, right? These tools were gaming the user experience in the metrics, and when the metrics got more honest and tried to reflect more accurately what the users see all day, it turned out that the people who had invested in these tools found themselves in more trouble than folks who had invested in simpler stacks. This is tough to swallow, and I think it leads to a couple of things. First, it's obvious now that people are spending not as much time as I think it would look like to succeed on the web on their mobile devices. This is a competition. Platforms are competitions, and the web is currently losing dramatically. You can see it from space, right? This is data from the United States, and this is to say that web usage as a fraction of time on device is low and falling. At a base rate, it is stable in terms of absolutes, but time spent on devices is not absolute, right? If you're a web developer, this should scare the shit out of you. Right? This is what it looks like to have your ecosystem be eclipsed by something else. This is what losing looks like. Okay, so let's step back. We're not necessarily succeeding. What should we be doing? Well, if you want to build to a good target, for users at the margins, which is where every market is made, right? You always make your market at the margin. You cannot be building to the latest MacBook Pro, right? The limits of this device are stratospheric compared to what most people have, most because what it costs is stratospheric related to their budgets. The same is true for mobile devices. The real target looks something like this. This is a Surface SE. This is a device that my company sold to schools primarily. It features either the $250 version sold with an N4020 Celeron chip, which is a 2-core, 2-thread, 4-gigabyte device with very slow eMMC, all encased in polycarbonate, so the cooling sucks. You're always thermally throttled on this device. The top-selling laptop, frequently on Amazon, is this device, which was launched in 2022, about the same time as the Surface SE. This is the HP Stream 14. It uses the same chip, the N4020 or the 4120. The 4120 will get you 4 cores and 4 threads. It has very little cache, right? Like, because dice space that you allocate to cache, which is to say making things go fast, is very expensive compared to other kinds of things that you would put on the same chip. And it also features very little memory and a very, very, very slow eMMC. I have both of these devices on my desk at work because it's important for us to be testing on these real devices, because that's the only way that we can really understand where the market is. But most computers today are phones, right? Most of the things that can run a web browser today are phones. There's no legacy browsers on phones. They just, to a first approximation, don't exist. Right? Like almost everyone has a browser that was built within the last 3 years on a phone. You don't have to think about IE on a phone. But you do have to think about the hardware and the software, because this device has 8 cores nominally. They are Cortex A73 and A53 cores, which is to say they blow chunks. Mostly, those cores are not spun up. Right? The big lie is that you're going to keep those cores powered up, and that's why your system is going to be fast. That never happens. The battery in that same polycarbonate case has to power the dang thing all day. So yeah, we're not keeping cores spun up. We're not actually. You don't get 8 cores. If you're lucky if your website gets 1 or 2, maybe 4 if you're in the loading phase and we're doing things like image decoding. And this brings us back to understanding the economics that feed into the questions of what does the actual device landscape look like. Average selling prices for phones worldwide, new unlocked, have been hovering between $270 and $350 for a decade. That is to say, the median device, the device sold at the average price, because the average and the median are actually very close in these cases, has not accelerated in price the way the device that you probably carry has. If you are a wealthy developer, it is very likely that your phone used to cost about $500 and then about $600, and then you got a $1,000 phone, and then you got a $1,200 phone, and that's what you carry now, right? You pay for what you get in many cases. And for laptops, which is the dominant form factor for PCs, the average selling price is hovering about $650. But it's worse than that, because most of these devices are old. Right? Most of the landscape that you're deploying your software into is not comprised of devices that were sold this year or in the last 6 months. The lifespans of these devices define where the median actually is, or where the 75th percentile or the 90th percentile, which is what we actually care about, 90th, 95th. Those devices have lifespans, which mean that the median phone was sold at $350 2 years ago. Right? The median laptop was sold about 5 years ago for $650. Are you building or testing to that? Because that's what your users are carrying. So we have good telemetry from Edge. We can see a lot of metrics. We're the inbox browser on Windows. And so something like a third of the fleet that we get telemetry from have spinning hard drives, or they have 4 gigabytes of RAM or less, or they have 4 cores or fewer, right? This is our low-end bucket, and this low-end bucket is not draining nearly as fast as you'd like it to. This same test set has only decreased by 7% over the last 2 years. Okay. So what you need to understand about the world that you're actually putting your software into is that most of the devices are old, much older than the ones you probably carry. They're mostly phones, and they're not running Mac OS or iOS. That's just not reality. So if you would like to do a good job to solve problems for users and society under these constraints, you need to understand how to build for them. Okay. I know that there's a big risk of me getting up here and doing my blog in 20-minute form on stage. But I will say that I started paying attention to this because when we built PWAs, when the team that I was leading built PWAs in 2013, 14, and 15, we started working with lots of partners, lots of folks who wanted to build good competitive mobile experiences. And what we were finding over and over and over again was that they were taking the tools and frameworks that made sense in the old desktop consensus, and they were trying to apply them to mobile. No other ecosystem tried this. And it has been an absolute disaster, a total debacle. It has not worked. Because most phones, then and now, are acceleratingly cheap Androids. Okay, now you may be saying to me, Alex, but we get Moore's law's death is greatly exaggerated. And to a technical extent, that's true, in the sense that we get more transistors every 18 months or so. And the trend continues, especially in places like the data center where we're getting full utilization out of these cores. But that's not the story that matters, because most phones, most computers are running off of batteries, and power is now the limiting factor for those devices. Having more transistors, if they're not able to be lit up, doesn't matter for performance, right? No matter what your threading model is, they just don't matter. And Dennard scaling ended more than a dozen years ago. What this means effectively is that while we get more transistors, we don't get to light up more transistors, and they don't go faster, right? The gigahertz stopped, right? What you see at the top there is that, your total, number of gigahertz for die shrinks didn't go up, which means that the same program that used to reliably get faster every year because Dennard scaling meant that our same single-threaded program would go faster on the next generation of hardware, that's over. Doesn't happen. And our entire JavaScript ecosystem was effectively built under the premise that this was going to continue to happen, because it had happened all the way through the 2010s. It's done. It's over. So what we've got now are more dark cores. They're not lit up. They're powered down. They're in the lowest power state most of the time, because that's what batteries require of us. They're slower, right? I keep trying to construct these charts, and the research is actually quite difficult to get a hold of in aggregate, but it's my strong expectation that peak CPU performance probably was hit in 2017. We've probably been on a downward trend at the median ever since, because phones have exploded while the PC and desktop market has effectively been a fixed function. Okay. There is good news, which is to say that browsers got the message. We adapted pretty heavily. We moved to mobile, we threaded everything. When you hand us a workload that is designed to work the way the web works rather than the way maybe JavaScript works, we thread the snot out of things today, right? Your image decoding is off thread, your scrolling is off thread, your parsing is off thread. Actually, a lot of the compilation in the background for your JavaScript now is off thread. And this matters because we're getting a lot more cores, but we're, in most of the market, not getting faster devices. You'll see that I'm focused here on single core scores because this is what defines the performance of your JavaScript, right? This is where your code as a web developer is running on the main thread. That Galaxy A25 in the third slot down on the right, that is the $350 device, the $300 device today. You'll note that it is, what is that? About a third as fast as an iPhone. Okay, so if you carry an iPhone, what's in your pocket is not real life. And part of this is because when you pay a lot for a phone, what you're getting is a lot of cash today, right? Like 40 megabytes of cash. It's ridiculous. What Apple has done with Silicon is totally ridiculous. And that is because they sell to a wealthy cohort of folks, which is to say not most people. Okay, that's our limiting factor. Our limiting factor is the fact that we live in an extremely chatty, interpreted or JITted environment in which data locality is hard to reason about, and that means that your JavaScript will run very fast on devices with a lot of cache. They don't have to spend a lot of time stalled out waiting for main memory. But on most phones, ain't no cache. Every time we fail a branch predict, every time you're de-opted in V8, woe is you, because you're probably stalled out. This means that every time you bet on JavaScript to deliver your experience, you're making a bad bet. OK, well, I've got bad news and good news. The good news is that networks are improving, and the bad news is that they're starting from a very bad baseline. Again, the predominant story of the last 15 years of computing is not whatever was marketed to you as someone who's relatively wealthy. It is that folks got their first smartphones in large portions of the world. Billions of people got computers for the first time. And those phones were Androids, cheap Androids, $100, $150, maybe $200, new unlocked. And so the network situation in growth markets, in the places where the margin is actually made, is still pretty rough. In a lot of places, it's highly variable, but in growth markets, it's still improving rapidly, but it is improving from a 3G to slow 4G baseline. OK, what I want you to understand at this JavaScript conference, and from someone who spent a decade on TC39 working in the language to give you promises and classes and arrow functions and that sort of thing, is that JavaScript has always been and will always be the slowest way to do anything on the web. Making a fast JavaScript program requires that you think about it the way you would make a fast Python program, right? You dish off to the C++ libraries that are sitting left, right, and center, and you spend as little time in your language as possible, right? Your job as a plumber, you're connecting the input from some parser to some other system that is going to be handling it out in C++ land, which is to say, every time you're running code in the critical path of a user interaction, you fucked up. And this matters because you're going to hear a lot over the next couple of days about tools that are popular. And a lot of those tools have been sold on the idea that either their popularity means that they're good, or that you don't have to worry about the factors that I just talked about. And that's bullshit. It's bullshit because it isn't focusing on the question of whether or not we're solving a problem effectively for users, specifically users at the margins, because that's where the business is. The business is always at the margin. So if you're not building your own mental model, and you're not building your own testing environment to understand how you're going to be able to deliver well for those users, deliver the experiences that you think are the best quality product for your business or for your enterprise, then you're kind of deluding yourself. OK. This is all stuff you can find on a bajillion blog posts. You don't need me to tell you how to go fast on the web. You send less code, you run less code, you let the system underneath you do most of the work. You spend as little time in your own code as possible, specifically in JavaScript, because JavaScript, again, is the slowest way to do anything on the web. And so if it is the only way to do anything in your stack, you've failed by default to reach users at the margins, or you need extreme discipline, one of the two. And you have to go try to reach for the marginal user, otherwise you're letting down your business. That is what it means to do a quality job in our profession. So if we don't care about quality, then none of this really matters. But if we care about quality and we expect people to pay us to do a quality job, then it does matter. And we can't wish away these factors, but we can do well. So this is from a transition that we're going through internally in Edge. We're calling it WebUI 2. A bunch of the browser today is built out of web stuff. It's built out of, in the case of Edge, a lot of React and a lot of all the data systems that you would have imagined. And this is the settings page. On the left is the old system that was based in React, and on the right is a new system that's been totally rebuilt to be built on what the platform can do. I could tell you about the stack, but it doesn't matter. The thing that changed here in this rebuild that made it a good 40% faster, and that's roughly what we're seeing across the board as we rebuild these surfaces and get rid of React and all the abstractions that were built for 2011's web. What we're seeing is that we're improving the user experience because we decided to care about the user experience. The most important thing wasn't the tool. It was the focus. We decided to focus on quality for users at the margins, and that has shaped every decision that on the other side. Don't accept anyone's idea of what your tooling and stack should be. Pose a test. Is it good? Are the results good? That's the only thing that matters. Thank you.
Thank you so much, Alex. That was super good. Let's get into the Q&A.
Okay.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
With Datadog, you can monitor your infrastructure, apps, and security posture in one place. Instantly visualize your ever-changing infrastructure. Follow request traces through distributed environments, and get code-level visibility with always-on production profiling. Cut through the noise with automatic anomaly detection, and discover bottlenecks by mapping service dependencies. Datadog ingests all of your logs from any source, helps you optimize front-end performance, and secures your production environment with real-time threat detection. See inside any stack, any app, at any scale, anywhere. Join thousands of customers who rely on Datadog for full stack visibility. Start a free trial today.
What will I build today? Whatever it is, it has to be smart and connected. An app, an experience, a company, my company. Whatever it is, I'll need the right tools, all the tools. I don't want anything holding me back. What will I build today?
AG Charts is a modern open source charting library built for TypeScript, React, Angular, and Vue. Get started by simply providing your data, defining your series type, and then creating a chart. AG Charts provides over 25 different chart types, enabling you to visualize your data in any way you need to, from simple to complex. Learn more and get started for free at aggrid.com/charts.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
With Datadog, you can monitor your infrastructure, apps, and security posture in one place. Instantly visualize your ever-changing infrastructure. Follow request traces through distributed environments, and get code-level visibility with always-on production profiling. Cut through the noise with automatic anomaly detection, and discover bottlenecks by mapping service dependencies. Datadog ingests all of your logs from any source, helps you optimize front-end performance, and secures your production environment with real-time threat detection. See inside any stack, any app, at any scale, anywhere. Join thousands of customers who rely on Datadog for full stack visibility. Start a free trial today.
What will I build today?
And now we'll have a quick coffee break. And I'd like to remind you about the sticker collection you can enter in a raffle for a big prize.
I hope you enjoy your coffee break, you have some fun, and you connect with some people. Now let's just start talking about some of our sponsors for the day. Today we have TinyMCE. TinyMCE is a world-class open source reset editor for developers and businesses in every industry. So if you need a reset editor, just try it out. Now, don't forget, as always, to go to Slido in order to ask some questions to the speaker. We will just answer them after the talk. So go and check the code 0612, as always. Now, let's talk about our next speaker. Our next speaker is Thomas. He's an engineer at Google, and he's focused on web AI. I think you will be interested about this talk that is about AI right in the browser with Chrome's built-in AI APIs. In this talk, Thomas will dive us into the various built-in AI APIs that the team is currently exploring, so they are pretty new. Now, Thomas, the stage is yours.
Hello, super nice to be here. Amazing stage. I'm here, Thomas Steiner. Well, Google Germany is no longer true. Google Spain now, I just recently relocated. But anyway, so AI right in the browser with Chrome's built-in AI APIs is what I want to talk about. If you have questions after the talk, there's obviously the Q&A, but you can also reach me at Tomayak on all the social networks, except X. I refuse to be on X anymore. So, so yeah, if there's anything you have after the talk, just feel free to reach out. There's ways to find me on the other social networks or just email. Everything works. All right, and with that, let's get going. I want to tell you that there is actually a polished version of this talk. So at Google I/O this year, I had a pre-recorded talk with practical built-in AI with Gemini Nano in Chrome. And as a pre-recorded talk, I'm not sure if anyone of you ever has had the pleasure of doing a pre-recorded talk. They make sure that everything is right. There's no glitches. There's no, no AMs. There's a few, but like they cut them out. If you want to see the polished version of this talk, this is the QR code that you want to scan, and I highly recommend you do. But this JSNation version is like the uncut, rock and roll, rough cut. So there will be glitches, there will be AMs, there will be things that might go wrong. At Google I/O for the live talks, they established a rule this year where if a demo works, you applaud. If a demo doesn't work, you applaud harder. So if anything goes wrong, please applaud harder. And with this, I just actually want to leave the slides and jump right into my live demo here. So I built a little site, JSNation-rocks.glitch.me. It's probably one of the last glitch demos that I have because glitch is dying. It's super sad, but yeah, luckily it's still up today. And yeah, like I just took my bio that I used for the presentation here. So you can see who I am and blah, yada, yada. So I want to show you some of the APIs that we have in Chrome now. You can test them. They're in origin trial, so you can test them on actual real users. And the first thing that I want to show you is, well, let's assume we don't know what the language of this is. Let's assume this was just some user-generated code, content that we got in. So we need some sort of language detector. Language detector equals a wait language detector dot. Great, so we just create us a language detector. So we can see what we can do with it. So it has expected input languages. It has an input quota, which is infinity. So we can throw as much as we want at it. So let's actually do something with this language detector. So language detector dot not destroy, but detect. And then I give it my bio. And the bio is really just this diff here. So I just made it a global variable. So whenever I say bio, it's the contents of this diff. And this is all async, so we need to await it. And then we can see we get back an array with 2 entries. And if you open the first one, we can see with 99% confidence, the detector thinks that this is English. And then the other entry is, well, with the remaining whatever 000, it thinks that this is not determinable. So that's great. We have our first demo that worked. So let's actually just store this in a variable. So we have const lang equals this, and we need to await this and make it the first entry. And then we take the detected language. So hopefully this works. So now in lang we have English. All right. So first demo worked. That's kind of boring-ish. So what can I do with this? Well, of course, you can translate. And we in Chrome now have a translate API. So we have const translator, translator equals await translator dot create. And I can't just create a translator. Here, I need to give it some additional parameters. So I need to tell it what is the source language. And it's, of course, the lang that we had before. And we need a target language. And, of course, we are here in the Netherlands, so we make it NL. So now we have a translator for our detected input language, which was English and Dutch. So now we can, of course, translate something with it. And again, I give it my bio.inner text. And again, this is async. And I will not try to pronounce this, but hopefully you can see that it is something like Dutch. And it's using the same models that we have in Chrome for the browser native level translation. So the same neural network translation models that we have for many years. So yeah, you can see this is super easy to use, just 2 lines of code, and you have a translation API directly powered in the browser. All right, so this is yeah, thank you. This is the second API, and now I want to show you one other third API. So here, my bio, that's like 2 paragraphs. But some of you are Generation TikTok, so 2 paragraphs, oh my God, that's super complex, right? So can we just summarize this and make it bullet points? And turns out we can, because in the browser now we have the summarizer API, so we can say like summarizer.await, and you can see already the pattern here, summarizer.create. And now we have a summarizer. And you can see already there's, well, let me actually expand it. You can see already there's the format, which is markdown. There's the length, which is short by default. There is the type, which is key points. So let's actually try it and hope that it summarizes my text here. So summarizer.summarize bio.inner text. And as always, we need to await the result. And if this works, we should get a summary of this. It was slow in the last demo that I tried, so let's see. All of this is running in Chrome Canary today, so hopefully they didn't break it today, but let's give it a little bit more time. Come on, summarizer, summarize quicker. Yes! So it's hanging. Sometimes it works if I just reload. So let's actually do this. So let's go back to what we had before. So summarizer and then summarizer inner text. Let's see, still nothing? Come on. Okay, You know what, let's just restart Canary. This also sometimes works. And you can see I made the switch to Tahoe, so hopefully there's no thing that interplays here with macOS Tahoe, or macOS 26 as they call it now. Okay, so let's see. Now with a completely fresh session. So we need to create the summarizer and then summarize. One last chance to work. No, it refuses to work today. Okay, so. Oh! That's amazing. Okay, so it took a lot longer than usual, but it did work. So thank you very much for clapping harder. This really makes it a lot easier. So let's see. This is actually Markdown, so it's not super easy to parse, but we can see there's bullet points, and the first bullet point goes from here to here. Then we have a new line, then we have the next bullet point that goes from here to here. and then the last bullet point. So it has summarized my 2 paragraphs into 3 bullet points that are easily to digest for people who don't like reading complex text like 2-paragraph bios. All right, so with this suspension moment here, moment of tension, everything has worked, but eventually, but there's more. So I want to show you another API that we are working on in Chrome, and it's the prompt API. And for this, I can actually close my developer tool, so I have a little bit more space here. So I can see down there, there's a field where I can enter stuff. So I can say like, I don't know, what can I do in Amsterdam if I have one day? And you can see the LLM does the LLM thing. Well, it's not formatted properly, so you can see it starts with a heading and then some content and then some bold text in Markdown and so on. So that's kind of interesting, but like you've seen this before. What I want to show you is something that makes this a little bit more useful, but before we go there, let me actually show you how all of this works internally. We have HTML here, no framework. I listened to Alex's talk. So it's all vanilla, JavaScript vanilla, HTML vanilla, CSS in CSS, not CSS in JS. And yeah, we have a basic form, we have a basic label, an input, a button that is of type submit, and we have an output here. Okay, and then this simple HTML is hooked up to, for now, script basic. So what we do in script basic is we get references to the DOM, so form, input, and output. Then we have an event listener submit. So some of you might see this code for the very first time. So that's how you have an event listener in JavaScript. So we listen for the submit event, prevent the default, and then comes the actual secret here. So we have the input, take the value, trim it. If there's something left, sorry, if there's nothing left, so if there's an empty input string, is essentially we return. But as we continue, reset the inner HTML of our output, and then comes the actual AI code. So here we have the language model .create, and you've seen the pattern before. So the thing .create gives you the language model in this case. And then before I showed you the non-streaming variants, so I showed you translate instead of translate streaming. I showed you summarize instead of summarize streaming. But here I want to show you the prompt streaming method, which gives you a readable stream. And you can then just iterate over each of the chunks of the stream and then just append them to the HTML. So that's super easy to use, and you've seen the result here. But next, I want to slowly develop this talk and make it, as I said, something more useful. So I want to work on making this a multimodal detector of images where I could ask questions about the image. And not just ask questions about the image, but also have a really true or false classifier. So let me hook up the next script, which is this guy here, JSON schema. Let me just take the file name and then go here and put that over here. So what we have now is we've introduced a JSON schema. So everything from here to here is the same, but now we have a response constraint, and the simplest possible JSON schema is just this object that can say my response should be true or false. And then you can see everything else is the same, just here. For the prompt streaming, we give it the response constraint. So now, instead of having a long text, the model will be forced to just respond with true or false. So let's actually try this now. So I can ask something like, is Amsterdam located in Europe? Answer with true or false. And then I can submit that. And the model thankfully responds correctly with true down there. So you can see, well, this is starting to become useful because now instead of having this, oh yes, Amsterdam is located in Europe, blah, blah, yada, yada, LLM kind of response, you boil it down to just a true or false value, which of course is a lot more easy to digest and to parse if you work with generated data. All right, so that's okay useful, but next I want to show you how you can make this really useful. And you can see this image here. So this is my usual avatar that I have on most pages. So let me hook up the final script here, which is this one. Go back to here. And we take that script now. And let's have a look at what is happening here. So now we get a reference to the image. We still have the response constraint from before. But now our prompt becomes a little bit more complex, because now what I'm doing is I'm combining a text prompt with an image prompt. So you can see here I've just renamed my variable from prompt to text prompt, but it's essentially still the same. But then down there you can see my prompt is now a little bit more complex. So this is the entire prompt. You can see it's an array with an object that has a role of user, and then a content, which is an array again. And then we have the two prompts here. So we have the text prompt, so type text, and the type image. And we just give it the reference to the image from the HTML. Everything down there is the same. You can see for now I have commented out my response constraint. So now I can ask questions about this image. So I can say things like, what do you see here? And then submit. And if everything works, the model should hopefully respond with something. Yes, now it starts. So it says, this is a selfie of a man standing on a beach looking at the ocean. He has short brown hair. Well, that's a compliment. And a beard. Well, I was not well shaved that day. But yeah, you can see already it has understood what is on the image. So that's kind of cool. But now let's bring our response constraint back in. And now we force the model to just respond with true or false. So now we can go like here and say, I need to reload. And now I can say like, is there a person on this image? Question mark. I submit. And the model says true. So yes, you can see, well, this is useful. I've built a little classifier here that just tells me, is there a person in this image, yes or no? But of course, I can make this more complex, like, does the person on this image wear a hat? And we can see what the model says. It says true. So yes, amazing. It's down there, a little bit hard to see, but you can see how this can be useful. So if you work in any kind of space where you need to, let's say, before people upload an image, classify, does this show, I don't know, a driver's license, you can ask the model, hey, does this depict a driver's license? And then respond with just yes or no. So before verifying manually that the picture is a driver's license, for example, if you need to verify people, you can just have this LLM do the work client side for you. And yeah, you can see how this can be actually very useful. But yeah, response constraint in combination with multimodal input, that's pretty cool. I took the prompt API and built something a little bit more complex. So it's like a mini Gemini or ChatGPT or what you will in your browser. And it's an installable PWA, so we can actually just install it. So Chrome is doing the install thing. So now it is installed. And I can create a new conversation now. And I can add an image. And I happen to have prepared one. So this is just Google making sure that I'm not uploading anything illegal. So you can see this is the I Amsterdam sign. So I can see, what do you see here? And the AI will look at the image and think about it. And yeah, you can say, this image shows the Amsterdam sign, blah, 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 Rijksmuseum, and so on. So it has understood that this is the image. I can say, what is the building in the background? And you can see it continues with the session, so it has the context of this. All right, so this is kind of neat, but let's actually kill this. So I close the application, it's entirely away. Let's actually turn off Wi-Fi, which is a scary thing to do. So like I'm shaking, like my Wi-Fi is off now. Okay, so you can see it's off. Let's relaunch the PWA. And it has restored where I was before. And I can continue my conversation. I can say, what is being exposed there? And you can see it continues. Well, it's not super catching up with the context here. What is exposed in the museum? Well, it still sort of is hanging on in the picture, but you can see, well, it does finally give me some Dutch art, Dutch history, other art. So you can see I've completely closed the application, reopened it, I was offline, and I could continue the conversation here. And then, of course, if you go up here, you can see I can close this and then create a new conversation. So tell me a joke. And you can see how it updates the conversation in real time. And then I can go back here, switch conversations again, and is it open today? And it tells me it actually doesn't know. So it switches conversations easily. I can go back to my joke conversation here. Let's close this one, open that one, and I can just say like, another. And all of this entirely offline. Well, amazing. Gemini's humor is just great. So yeah, I'm entirely offline, everything working with an installable PWA that I have on my browser, and it's like my private, completely running local AI right in the browser. So with that, let's actually go back to there. So this was that demo, so let me go back to here. And I think I need to turn on, oh yeah, I need to turn on Wi-Fi again for the presentation to let me enter presentation mode. Reconnecting, let's go here. So this is public, you can access the demo here, JSNation rocks, glitch.me. This is also public. I give you a little bit of time to take the QR code, but I also share my slides, so no need to take individual pictures if you don't feel like. And yeah, so you're asking yourself, how can I use all of this? Well, we have tons of documentation, developer.chrome.com, docs AI built in. Scan this code to see all of it. So there's, on the left-hand side, a lot of links about all the different APIs that I've showed you. There's some more that are also still in development. And above all, please, if you're interested in this, join our early preview program. So there's the link for that. There's a simple Google form. You fill that out. It's mostly for us to get information about the users of this. Like, what are the possible use cases that you would have for this? So we will be sending out surveys. We will be asking you, like, how does this feel? Do you think this is the right way to address the problem? And this is in Chrome today. Microsoft Edge also has an implementation not based on Gemini Nano, but based on 5.4, so a Microsoft model, but the same API essentially. So you can already today test on 2 different browsers, and some of those APIs are actually right now already in Origin trial. So Origin trial is a concept that we have in Chrome. Edge also has a similar concept where you can say like, I get a special token for my website. I put the token in my meta tag or as a link header. And then Chrome, if it sees that token, unlocks the APIs for users. So you can test all of those APIs, sorry, not all of those, the ones that are in Origin trial with actual real users and get a feeling of how they would react to all of those APIs. Those APIs are mentioned and some partner use cases, again, in the talk. So if you want to see the polished, non-JSNation rough cut version, again, think about the talk. And with that, bedankt. It was a pleasure to be here. The slides are here. The slides are here. So Google, goo.gle, JSNation built-in AI. If you want to get the slides, so this is your one link that you want to get, and then everything else is linked from the deck. And I think we have time for some questions now. Thank you very much again.
Well, thank you, Thomas. Let's go now to the Q&A spot here.
Okay.
So we can have some questions from the audience. The talk was amazing, so we have so many questions from.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
With Datadog, you can monitor your infrastructure, apps, and security posture in one place. Instantly visualize your ever-changing infrastructure. follow request traces through distributed environments, and get code-level visibility with always-on production profiling. Cut through the noise with automatic anomaly detection, and discover bottlenecks by mapping service dependencies. Datadog ingests all of your logs from any source, helps you optimize front-end performance, and secures your production environment with real-time threat detection. See inside any stack, any app, at any scale, anywhere. Join thousands of customers who rely on Datadog for full-stack visibility. Start a free trial today.
What will I build today? Whatever it is, it has to be smart and connected. An app, an experience, a company, my company. Whatever it is, I'll need the right tools, all the tools. I don't want anything holding me back. What will I build today?
AG Charts is a modern open source charting library built for TypeScript, React, Angular, and Vue. Get started by simply providing your data, defining your series type, and then creating a chart. AG Charts provides over 25 different chart types, enabling you to visualize your data in any way you need to, from simple to complex. Learn more and get started for free at aggrid.com/charts.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
With Datadog, you can monitor your infrastructure, apps, and security posture in one place. instantly visualize your ever-changing infrastructure. Follow request traces through distributed environments, and get code-level visibility with always-on production profiling. Cut through the noise with automatic anomaly detection, and discover bottlenecks by mapping service dependencies. Datadog ingests all of your logs from any source, helps you optimize front-end performance, and secures your production environment with real-time threat detection. See inside any stack, any app, at any scale, anywhere. Join thousands of customers who rely on Datadog for full-stack visibility. Start a free trial today.
What will I build today?
One of our gold sponsors again, Sentry. Probably you all know Sentry. It helps every developer detect, understand, and fix broken code really fast. So if you are not using it, I encourage you to use it. And now, let's remind you that if you want to have more questions for the next speaker, don't forget to pass your questions via Slido with the code serial 612. And now, our next speaker is Tobias. Tobias is the creator of Webpack and TurboPack, and he will talk about TurboPack persistent caching, of course. So now, Tobias, the stage is yours.
Hi, my name is Tobias Koppers, and I work for Vercel at the TurboPack team. And I want to talk to you about the story about persistent caching that we implemented for TurboPack. So when we started working on TurboPack, we wanted to build something for the next 10 years. So we first reflected on the last 10 years of web development, and we noticed that web applications have grown really much. Like 10 years ago, some people even used normal script tags and didn't even use a bundler on WebDev, or used Grunt or Gulp to concatenate stuff. So now we extrapolate that for the next 10 years, you will see web applications will be enormous size, and that will be a problem. And we made this thing basically started with that 2 years ago. And now if you look at this retrospectively, it makes much more sense, because now you see AI is writing all of the code, and you can expect AI will write a lot of more code in the next 10 years. So it kind of makes sense. But we also had this goal of instant builds for TurboPack. So we had this vision that nobody should ever wait for a build to finish. You basically should push your code, and instantly you can directly share that code in the preview deployment or the finished build with your coworkers. Or even AI pushes code and want to directly share it with you in a kind of feedback loop. So this is a little bit in contrast with each other, and there are even more problems with that. We can't even control all of the build process. We want to allow custom plugins, custom transformations like Webpack loaders, or we can't even control the user code and all the NPM libraries they throw at us. So with all of that, we can still use Rust to write native code, use parallelism to use all the cores, but that won't help us with all these problems, because if there's something slow in a custom plugin or in a Webpack loader or in anything we don't have control of, that will break our goal of instant builds. So we need to rethink that. We need a different approach. if we have to accept that something of the build is slow, how could we still achieve our instant build goal? So our approach was we wanted to change the focus. Instead of focusing on raw build performance, we wanted to focus on incremental build performance. So even if we have to maybe have to accept that some stuff is slow in the initial build, but we can at least make sure that we don't ever re-execute it again. We basically make it fast on all the other builds, all the incremental builds. And in fact, in practice, nearly every build can have a cache. On local development and dev server or something, you can have access to a disk. We can store stuff there. We can cache stuff, and even on CI builds, we can use nearly all good CI providers have the ability to the infrastructure to provide you with some caching capabilities. So we can use a cache. That's great, and so we came up with this two-part motto for our vision or motivation for TurboPack performance, which is make incremental builds fast and make every build incremental. And our idea was that maybe this kind of approach has the potential to fulfill our goal of instant builds, even with stuff that is slow or stuff that we don't have control of, or even the size of the web applications in 10 years. So let's look into what we need to achieve that. I want to look at the second part of the motto first, make every build incremental. So for making every build incremental, the first thing we need is some kind of persistent caching. In-memory cache is maybe good enough for development because there most of the builds are within a single process and you not restart your dev server that often. But to get the full story, we need to be something that is persistent. We want to restart your dev server and still have an incremental build on restart. And for CI builds, we don't even have a process running. We need something that is working across restarts of the process. So we need a persistent cache. You might think, okay, now the cache is persistent, though every build is incremental, at least everything is possible, but not that fast. There's a problem, which is the user. Because the user can delete the cache, it can disable caching, and they will actually do that if they don't trust the system. If they are not 100% sure that their changes are reflected correctly by the build system, they might clear the cache just to be sure that it's not their fault, or it's maybe it's a bundler fault or whatever. So we really want to build something that is really trustable. We want to build a trustable system so that users have the confidence that their changes are reflected correctly and caching is not the problem. So we basically want to avoid all the hacks, workarounds, or even trade-offs for better performance that are not 100% correct from caching perspective. We can't even trust ourselves to write correct cache invalidation logic because that is also a common source of errors. So these two ingredients, persistence and confidence, are what we think are the main ingredients to make every build incremental. But also we also want to look at the first part of the motto, make incremental builds fast. And if I need to sum up that kind of motto in a single ingredient, it would be granular. So we want to, granular means we only touch stuff that is affected by a change and not touch everything just because we can. So for cache invalidations, it could mean we only want to invalidate and therefore recompute work that is affected by the change. That means in practice, we really want to do the minimum amount of work that is needed to apply the changes or make an incremental build. Because doing work fast is great, but doing no work is even better. So that's kind of the motto of that. That might be simple for simple changes like changing some line of source code, but we also want to make it work for all kinds of changes. That means you might make complex changes, like changing a dependency or changing your configuration, or that kind of changes should also be reflected by be in a granular way. That could also be more interesting with production builds, where you have this kind of optimizations that work on the whole application, like shared chunk or something like that, where a simple change, like changing some imports, can have wide-ranged effects on the compilation on the output application. So we want to handle all of that. We never want to be in the scenario where we need to invalidate whole cache because somebody changed the config option or something like that, or not even changing a large part of the compilation because some changes happen. But granular granularity is also important in other areas, like for cache access, we basically only want to have granular cache access. We never want to restore the whole persistent cache just because a simple comment was changed or something like that. We want to access only what we really need from the cache. So in the kind of only access what is affected by the change. So now we have these ingredients or the requirements for that. What developers do when they have some kind of challenge, they usually build a framework. And basically what we did, we built this engine called Turbo Engine, which is like the caching engine which powers TurboPack. And the idea of that is we want to enable us, or the developer of TurboPack, able to work with use caching in a fearless pattern and without caring about all this complex tasks about cache invalidation, incremental builds, and all that stuff. So basically this framework gives us the primitives to opt into caching on per function level, so we can build really granular caching system and really granular invalidation stuff. But the real magic happens in regards of cache invalidation in the system. So it doesn't allow you to write cache invalidation code, or it basically does it automatically for you. So it tracks whatever you read in a function, which kind of external stuff you read, what kind of values from other functions you read, and it builds up a dependency graph of all these execution of basically the dependency graph of the execution of the compilation. And with this dependency graph, it can make incremental builds really efficient. So everything in this example is a really simplified version of the dependency graph. It's like billions of nodes in practice. But in this simplified version, it might start with a file has changed. So then one of these nodes, we call them tasks in this case, is invalidated and recomputed, and that might cause more stuff to be invalidated. An example, when the file has changed, the module.js has changed, parsing might need to be re-executed because the content has changed. So basically this change bubbles up the graph. It follows the dependent edges, and that might invalidate more stuff. But it could also happen that we read some existing cached unchanged data, or something doesn't have any effect on that. If I only change some kind of line of code without touching the imports, maybe the chunking does not have any further updates, so it cancels out there. But in the end, the whole stuff finishes and recomputes, make an incremental build by only touching the parts that are affected by the change. And that's what I mean with granularity. So we make an incremental build by only touching and only reading and only accessing nodes of the graph that are affected by the change. And that has a lot of benefits. It's really great for performance because we only recompute what's actually needed, and we don't touch all the other stuff at all. And it's also great for persistent caching because we only need to restore stuff from the cache that is accessed, and we don't have to touch all this grayed out stuff in grayed out nodes in this case. And usually the stuff that is affected by the change is much, much smaller than the whole graph at all. This also gives us the benefit of having incremental builds performance independent of application size. So the graph could be really large, but if the change only affects a bunch of nodes, it's still really fast. So now we have the engine for incremental builds. We want to add persistent caching on top of that. So let's look into how the cache looks in this engine. So the cache is not basically this graph you see on this picture here. It's basically the cache in this kind of system. So the state of the graph is what is cached, and the node stores the data. So if we want to add persistent caching, we basically want to persist this graph on disk. And that's actually not that complicated. So we can just use a simple key value store, for every node, store the data, store the edges, and that stuff. And so basically we need a database to store that. And the database mainly functions as dump everything to disk and then access it from the database again. So basically what databases do. So great. So we started out with, we need a simple key value store. We use a simple database. We used LMDB in this case in our first iteration. That kind of works. So it worked for the incremental build part. So we stored everything to disk, and then we accessed only the parts that are needed. Storing a few keys from the database is cheap. That works. So incremental builds were really fast. So the whole architecture of incremental builds works for persistent caching. kind of makes sense because we already tested that for like in-memory caching, and that worked too. So that works. But there was a big problem with that. The initial builds were really slow. And yeah, the problem is like we basically have to dump the whole initial graph to this, and that is like millions of nodes, and dumping millions of keys into the database. It's not the fastest thing you can do. It also has the problem that the disk size was really large because, yeah, a big graph stored in the database created a big database. So we iterated further on that. We tried a better database. Maybe we thought like maybe the database is not the perfect thing. We used a really simple embedded database. So let's use a production-ready proofed database, RocksDB in this case, from Meta. And that solved a few stuff. Like it has compression built in, so that solves this disk size problem. It also is much faster than LMDB, so it also kind of solved the initial build problem. The initial build was like now in an acceptable speed. Basically, like it adds 50% overhead to the build. Not okay, but might be acceptable because in the end, most of the builds will be incremental anyway, and that's fast. Sounds good. Yeah, but we didn't want to stop there. We wanted to work further into that, and we noticed that our database pattern is a really unusual access pattern. Usually databases are optimized for, I write a few things and read a lot of stuff, so read heavy workloads. And our workload, at least for the initial build, was like we had no reads at all because there was no database at all at the start. And then we write like a gigantic amount of data into the database. And for incremental builds, it's only a tiny amount of data that we read and write that worked well, but initial build, problematic. So we wasn't able to find a database that has this different access pattern. So we ended up writing our own persistent layer. It's not a complete database, it's more like a simpler version, specialized for a usage pattern, and made a lot of trade-offs that is optimized for our usage. Like we don't have parallel writes and that stuff, so we can optimize a few things. And that basically solved that overhead of the initial build and made it much smaller. So that was not now in an acceptable performance. We also stole a lot of stuff from the existing database, like compression and that stuff. Yeah, we also benchmarked that for a large-scale customer application, which has like 1 minute build time. And if you look at the numbers here, we started with LMDB. For this 1 minute build time, it adds 3 minutes persisting time. That seems like really large, and it's like was kind of unacceptable for us. And then RocksDB improved on that a lot. It's like 6 times faster for persisting. So like now the 1 minute build, the 1 minute build was only like extended by 50% of the build time for persisting. And with our custom layer, we was able to improve even further, like by improving it by another factor of 3x to make it better performance. You also see like memory, it was improved by that because RocksDB stored everything in a memory table in addition to a disk, and that's not the optimal thing to do. It also has problems like it allocates everything in a write batch first before committing it. And so we made a lot of improvements towards that. And you also see like the incremental build performance. That was always good because it's more good by design because we don't read a lot from the database. It's not so much dependent on database, but we was able to like improve it a little bit by not using LMDB but RocksDB and our own solution. So that's great. So we basically, that's how we implemented persistent caching with like our database. Like there are a few other layers on that. We have some snapshotting mechanism to like take snapshots of the compilation while you're working on it, because we never want to stop like the dev server process just to persist something. We want to like atomically take some snapshot of the graph and then persist it in background, so you're not stopped, or your HMR is not affected by like doing a background or like doing a snapshotting or storage of the persistent cache. But if you look into this like in a wider scope, persistent caching also adds a lot of a few more problems or like new challenges. Like now you have process restarts, which adds like much more different changes to that. Before, like most of the changes were like changing a file and that stuff. Now you have like process restart, which changes environment variables could change, configuration could change. So like all these new challenges we have to make our white TurboPack in a way that is granular to apply these changes. Especially envars are really problematic because envars could be inlined into every module. So we don't want to invalidate every module because like some envars have changed. So that was a little bit tricky. So there's also these production optimizations which I already talked about, which are challenging to apply like changes on a granular level. There are more things to consider, like network fetches during the build. Maybe you fetch something from Google Fonts, like font file. When to invalidate that? Do we have to invalidate all? Like caching and that stuff is relevant when you can't restart the dev server. Because like persistent caching adds a lot of new challenges to that. Because usually you can fix all the problems by restarting the dev server, but now everything is persistent. So we can't accept any of these problems that cache are not cleared correctly or invalidated correctly. So because everything is persistent, and we don't want you to delete the cache. There's also the complete new challenge when it comes to CI, when you have actually spend some time uploading and downloading the build cache, which could also like affect your total time. And overall, it's also important to look at the whole deployment lifecycle, not only on the TurboPack build, because usually TurboPack build is often the largest part of the deployment. But there, like when we have incremental builds for TurboPack, then it might not be the case anymore. Like then TurboPack build is really fast, but then we have all the other challenges which also need to be made incremental. Like we want to make git clone incremental, build cache download maybe incremental. No, we only download what we need from the build cache. We have package management style. We can make that incremental too, like using a cache for that. There's this whole pre-rendering step, pre-generation step happening usually after the build, which can be cached, cannot be cached. Yeah, it depends. So a lot of other stuff you have to consider when adding going with this incremental build route. And we group up with other teams to like make this happen, so we can all benefit from that. So thanks for having me. I hope it's was interesting too.
Well, thank you so much, Tobias. Let's go now for the Q&A. We have a lot of questions from the audience, actually.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
With Datadog, you can monitor your infrastructure, apps, and security posture in one place. Instantly visualize your ever-changing infrastructure. Follow request traces through distributed environments, and get code-level visibility with always-on production profiling. Cut through the noise with automatic anomaly detection, and discover bottlenecks by mapping service dependencies. Datadog ingests all of your logs from any source, helps you optimize front-end performance, and secures your production environment with real-time threat detection. See inside any stack, any app, at any scale, anywhere. Join thousands of customers who rely on Datadog for full stack visibility. Start a free trial today.
What will I build today? Whatever it is, it has to be smart and connected. An app, an experience, a company, my company. Whatever it is, I'll need the right tools, all the tools. I don't want anything holding me back. What will I build today?
AG Charts is a modern open source charting library built for TypeScript, React, Angular, and Vue. Get started by simply providing your data, defining your series type, and then creating a chart. AG Charts provides over 25 different chart types, enabling you to visualize your data in any way you need to, from simple to complex. Learn more and get started for free at aggrid.com/charts.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
With Datadog, you can monitor your infrastructure, apps, and security posture in one place. Instantly visualize your ever-changing infrastructure. Follow request traces through distributed environments, and get code-level visibility with always-on production profiling. cut through the noise with automatic anomaly detection, and discover bottlenecks by mapping service dependencies. Datadog ingests all of your logs from any source, helps you optimize front-end performance, and secures your production environment with real-time threat detection. See inside any stack, any app, at any scale, anywhere. Join thousands of customers who rely on Datadog for full stack visibility. Start a free trial today.
What will I build today? What will I build today? Whatever it is, it has to be smart and connected. An app, an experience, a company, my company. Whatever it is, I'll need the right tools, all the tools. I don't want anything holding me back. What will I build today?
AG Charts is a modern open source charting library built for TypeScript, React, Angular, and Vue. Get started by simply providing your data, defining your series type, and then creating a chart. AG Charts provides over 25 different chart types, enabling you to visualize your data in any way you need to, from simple to complex. Learn more and get started for free at aggrid.com/charts.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
Datadog, you can monitor your infrastructure, apps, and security posture in one place. Instantly visualize your ever-changing infrastructure. Follow request traces through distributed environments, and get code-level visibility with always-on production profiling. Cut through the noise with automatic anomaly detection, and discover bottlenecks by mapping service dependencies. Datadog ingests all of your logs from any source, helps you optimize front-end performance, and secures your production environment with real-time threat detection. See inside any stack, any app, at any scale, anywhere. Join thousands of customers who rely on Datadog for full-stack visibility. Start a free trial today.
You can ask your questions in Slido with the code 0612. And now, our next speaker is Leo. Leo is a software engineer at Dino, and his talk is talking about JSR, building an open registry for the JavaScript community. Let's hear about recent developments of JSR, including the establishment of its governance board, ongoing projects and initiatives, and how these efforts directly benefit the JavaScript developers. Now, Leo, finally, the stage is yours.
Hello, and welcome to JSR, building an open registry for the JavaScript community. So, first off, I'm Leo. I work at Dino, and I'm also a maintainer of JSR. So, I want to quickly see a sea of hands. How many people know what JSR is? Oh, OK, about a third, fair. Good, good. So, for the others that don't know, first, let me introduce you. What is JSR? So JSR is a new JavaScript registry. It's similar to NPM, but it's not NPM. It supports TypeScript out of the box, which is not just a feature. It was a foundational technical decision that we wanted to have, because TypeScript is everywhere now, and publishing TypeScript to NPM is a bit of a drag. I'll get into that in a bit. And then, well, as I said, it does not replace NPM. It lives alongside it. So you can still use your NPM packages when having dependencies in JSR. And it's compatible across different runtimes. So you can use it with Cloudflare Workers, Dino, Node.js, Bun, and anything else that supports Node modules directories. And it also has built-in support by Yarn and PNPM as recent, but not NPM, which we would like to change. And another feature point is that JSR is completely free and open source. So why did we build JSR? Well, the first reason is complexity. Again, publishing to NPM can be a bit too complicated. You have to set up tsconfig, you have to find the right settings, the target, etc. It shouldn't be like that. It's way too complicated, and we just want it to work. Oh, whoops. Then we have innovation. NPM has stopped adding any new features, really. I mean, have you ever seen any recent changes to NPM? No, like the most recent feature, I think, was like 2 years ago, it was something. But anything recent, there hasn't been, because they have stopped innovating. And the JavaScript ecosystem doesn't suit for that, because the JavaScript ecosystem constantly evolves. There's a new framework like every week. And the ecosystem itself is moving fast, but the registry it lives on is not moving whatsoever, which is completely unacceptable. And then our values. Unlike NPM, which is owned by Microsoft, JSR is completely open. And it's open source, it's driven by a community, and it has open governance as a core principle. So some additional features are tokenless auth, so you can just publish from GitHub Actions without having to set up any tokens. It will just use OIDC and check with your GitHub user. Provenance, so it can prove that the person that published it actually is the person that published it, so it can prove that it was that individual. And documentation generation. It generates documentation for you automatically based on your typings and JS doc comments, etc. And also there's many more features that I'm not necessarily going to go into details, but like it has very detailed download metrics and a few more things that we can maybe take a look later. Now, the governance. JSR is open for the reason that, well, JavaScript is not controlled by a company, by a committee, aka T39. Then all the implementations of JavaScript are open source, like V8, JS Core, etc. And then NPM is closed source. The only open source part is the CLI, I believe, but the actual registry is completely closed source, and there's paid tiers for having private packages, etc. And it's run by a company. And that does not fit with the rest of the JavaScript system. And so the JavaScript registry needs to be open source and governed by a community and open to innovation and be run by a committee of some sort. So who is running this? Well, we have a few people, and to run a project like this, you have to build trust. And a huge part of what it takes was convincing respected independent leaders from across the ecosystem. I mean, you need to have a foundation to convince more people to be able to make this something actually that works out. And as such, we have a few people that joined the governance board. And this demonstrates our commitment to being really a community project. So the people are Evan Yu, the creator of Vue.js and Vite, and founder of Void Zero. Then we have Isaac Schluter, the creator of NPM and co-founder of VLT.sh. Then we have James Snell, who is a Node.js TSC member and a principal system engineer at Cloudflare. Then we have Luca Casanato, who is a colleague of mine that works at Dino and also a member of TC39. And finally, we have Ryan Dahl, who is the creator of Node.js and Dino. And that encompasses our current board members, but in the future, I might get more on the board, but the board really only does a few things, which are overseeing that JSR moves to a foundation. I'll get into that in a bit. And then setting the general direction of the project. Making decisions on behalf of the project when necessary. So really this is when there is any conflict of interest or there is a drastic decision change that we want to move to a different provider for our infrastructure, etc. And determining how governments elect in the future. So if we want more people, this has still not really been decided on just because we're currently happy with the 5 people we have. And then determining how open source contributions to the project are made. Currently, we don't really have a policy. It's more like, yeah, this looks good. I'm going to merge it, but we don't have any strict rules around how we want to run this project, as in what type of contributions we want to accept, what not. It's really currently just on case-by-case basis that I decide, yes, let's merge this, or any other of the maintainers, that is. So we also have a moderation group. So again, JSR is public, and it's a public infrastructure. So like many other public spaces, not NPM, for example, but in the case of JSR, it needs maintenance and safety rules. So we have a group of people that handles any kind of human side of things. So reacting with people having issues, there's a name dispute, there is security reports, policy enforcement, stuff like that. It's really moderating the entire system. And this obviously is quite important, but people usually don't care about it. It's not very thankful job. It's relatively thankless and part of what it takes to keep the registry running safe and reliably for everyone. So for that, we have Oliver Medhurst, who is a creator of 4.4, which is another JavaScript engine. Then we have Augustin Mauroy, who is a contributor to Node.js and JSR as well. And then we have Dr./Blackest contributor to JSR and Dino. These are relatively people that we trust. It's not really about getting people that are popular or famous, but really people that are willing to do the gnarly job of responding to support tickets and having to deal with any kind of problems. Then, as I was mentioning, we're talking about moving to a foundation. So what is this foundation? Well, ideally, we want to move to an open foundation where because currently JSR is owned by the Dino company, which goes against what JSR stands for. We want to move it to an open foundation that can take care of it, take care of the costs as well partially, and just have as a platform that shows that we actually are open and not owned by private ownership. So we've been talking with OpenJS quite a bit, and that's going a bit well, but we'll see what happens. And also ECMA seems to have some interest, but overall, it's a slow process, so we'll see what happens. Now, an alternative would also be that we just have our own foundation, so a rather open, non-profit company. That's also an approach we've been thinking of doing. It's a bit less defined and not entirely sure if we're going to do that. It has its different problems, like you have to take care of legal stuff yourself instead of like OpenJS taking care of all the legal shenanigans. So we'll see exactly what we do, but creating our own nonprofit technically is the fastest approach and not having to wait on processes from these other organizations. But we'll see exactly what's going to happen. It's a slow process overall, regardless of which approach we do, and we'll try to push this forward, but yeah, it will come as it comes, but it's already being treated as an open thing. Then let's see some of the recent and upcoming features for JSR. So I mentioned a few of the key features at the beginning, but some additional features that we recently added was relatively detailed download metrics. So when you go to NPM, the most you see is like the weekly downloads on a relatively tiny bit. With JSR, you can see actual breakdown of all the versions of how long they have been having downloads. So you can switch between daily, monthly, and weekly. And at one point, we'll also add yearly, but that's currently irrelevant. And then we also have recently added dark mode. I mean, that's just people have been asking for it, so we just did it. It was quite a while, but it's not a key feature really, but people asked for it, so we give it. And then we changed a bit of a package archiving infrastructure because on JSR, everything is, you cannot change things really, or rather, you cannot delete existing packages. We cannot have a left pad situation again. So the idea is that it's immutable. So if you publish to JSR, your package is there. We will only take things down in case of legal disputes or any other relatively similar type of situation. Or we are working on it to adding also the capability of being able to, yourself being able to delete a package version if it has like less than 10 downloads and was published like less than 2 hours ago. We want to give people the flexibility to delete the packages under certain circumstances. But not always, because again, left pad, we don't want to repeat. So anything cannot be deleted, but we have archiving. So like on GitHub, you can archive a package, and that will just remove it from the search, will not make it visible, but it's still there. It still can be downloaded. And that's relatively it for the most recent features. And then we have some upcoming features, which is a revamped search. So this goes also from reworking our current search to be a bit more easier to use and a bit nicer, but also this adds a scope level symbol search. So in JSR, every package is under scope, unlike NPM, where that's relatively optional. And currently, you can search for symbols, aka function, classes, etc., from a package in a package. But there is the use case. For example, we have the @std scope, which is a standard library scope that provides various functionality. But you don't want to go through every package and find which one has the right functionality. So we're going to add search that will let you search for every function, every class, every interface in that scope, But then we're going to also one-up that, and we're going to add functionality to search for any function, any class, anything across the entire registry. No matter which scope, which package, you can just search in a global search and you'll get results. Similar to Go, from what I believe. And then also one more feature we want to work on soon is changelog generation and diff. Now, this sounds quite boring, that would just generate like a changelog as you see on GitHub. But no, this would actually give you like a nice diff between recently changed, like previously changed functions. So let's say version 1.0 and 2.0 have some signature changes. It will display that as, oh, this changed, and you will see a nice diff being able really to compare what the changes were, making migrations to new versions a lot easier. And that's pretty much it that we are currently working on and want to land soon. So I guess we can take a really quick peek at JSR. Let me see if I can get this to work. There we go. So we want to go to, oh God, my laptop is being very slow. There we go. So this is the JSR website. Seems relatively boring. There's not much to see. We have a few blog posts here. We have featured packages, which we manually select which packages we want to be featured, recently updated, and new packages to JSR. Then we have basically similar top points that I mentioned earlier, but we can take a look at a popular package. So I can go to at STD, again, as I mentioned just now, it's a standard library scope where we provide various standard functionality. This is maintained by the Dino company, and we can just jump into collection, and we'll see some interesting things. It's big enough, okay. Well, we have this works with, which shows what runtimes it's compatible with. This is decided by the maintainers, not automatically, because detecting that automatically is relatively tricky. And then we also have a score. So JSR scores your package because people love gamifying stuff. And the scores are based on various different pieces of information, like do you have documentation on your symbols? Do you have a description for your package? Did you pick any runtime that's compatible with, et cetera, et cetera. And we are going to add more over time. The goal for the score is not about really, oh, this package is better than that, but it's more about making people use good conventions and making better packages for the whole ecosystem. Then we have the weekly metrics. As we see, this is very similar to NPM, but I can click on that, and you will see a nice graph for, this is on a weekly basis for this package. You can change this to monthly if you want. And okay, that's my laptop is being extremely slow right now. Anyhow, and one more feature I can quickly show off is not in this package, but we have a list of dependencies, but in addition to a list of dependencies, you can generate, we generate for you a dependency graph. So I think a cert depends on one package. Okay, that's useless, but we can go that, for example, and you see a list of dependencies, but you can also go to a dependency graph, and it will generate a graph, usually. Yes, there we go, which generates all dependencies for internal files of the package, but also in yellow, it highlights packages like external dependencies to a different package. And in red, it also will highlight any NPM packages. Now, I don't have a direct example for that, but yeah, that's that. And then I guess we have 1 minute left that I can quickly give an overview of the docs generation. So here we have the cert library. It has various symbols. We have a default entry point, and we have the cert function. And this is generated, this content is generated by the JS comments, or via the JS comments, and generates type, like what it accepts, some documentation, examples as defined, parameters, return types, etc. So it gives a full breakdown, and it also shows you on how to use this. So you can run a command to add it, or you can select whichever system you want. It will remember it for you. So you can go like to PMPM, and it shows you how to use it with PMPM, etc. And yeah, that's pretty much it for JSR. And yeah, we have weekly, bi-weekly meetings, open meetings you can join. You can go to the link. There will be a calendar invite. And you can go to jsr.io to use JSR. And we also have, well, it's open source, so please contribute. There's a lot of simple fixes that are marked as good first issue. So we will love some contributions to the project. Thank you.
Well, thank you so much, Leo. Let's go now to the other side of the stage.
Yes.
So we can have the...
Start a free trial today.
What will I build today? Whatever it is, it has to be smart and connected. An app, an experience, a company, my company. Whatever it is, I'll need the right tools, all the tools. I don't want anything holding me back. What will I build today?
AG Charts is a modern open source charting library built for TypeScript, React, Angular, and Vue. Get started by simply providing your data, defining your series type, and then creating a chart. AG Charts provides over 25 different chart types, enabling you to visualize your data in any way you need to, from simple to complex. Learn more and get started for free at aggrid.com/charts.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
With Datadog, you can monitor your infrastructure, apps, and security posture in one place. Instantly visualize your ever-changing infrastructure. Follow request traces through distributed environments, and get code-level visibility with always-on production profiling. Cut through the noise with automatic anomaly detection, and discover bottlenecks by mapping service dependencies. Datadog ingests all of your logs from any source, helps you optimize front-end performance, and secures your production environment with real-time threat detection. See inside any stack, any app, at any scale, anywhere. Join thousands of customers who rely on Datadog for full stack visibility. Start a free trial today.
What will I build today? Whatever it is, it has to be smart and connected. An app, an experience, a company, my company. Whatever it is, I'll need the right tools, all the tools. I don't want anything holding me back. What will I build today?
AG Charts is a modern open source charting library built for TypeScript, React, Angular, and Vue. Get started by simply providing your data, defining your series type, and then creating a chart. AG Charts provides over 25 different chart types, enabling you to visualize your data in any way you need to, from simple to complex. Learn more and get started for free at aggrid.com/charts.
Don't panic, get Sentry. Speed up slowdowns and prevent crashes in React Native with just 5 lines of code. So your customers can actually buy your product and you can get back to whatever it is you do for fun.
With Datadog, you can monitor your infrastructure, apps, and security posture in one place. Instantly visualize your ever-changing infrastructure. Follow request traces through distributed environments, and get code-level visibility with always-on production profiling. Cut through the noise with automatic anomaly detection, and discover bottlenecks by mapping service dependencies. Datadog ingests all of your logs from any source, helps you optimize front-end performance, and secures your production environment with real-time threat detection. See inside any stack, any app, at any scale, anywhere. Join thousands of customers who rely on Datadog for full-stack visibility. Start a free trial today.
What will I build today?
This has been a great day. Once again, thank you so much to all of our speakers and sponsors and the audience who's joined us today as well. And thank you to the GitNation team, of course, for organizing this fantastic event year over year. All the recordings from today will be published on the GitNation portal within maybe 1 or 2 weeks, fingers crossed, as soon as possible in any case. Your feedback is incredibly important to us. It helps us make sure that we improve the event year over year. We have a form available for you on JSNation.com/feedback. So please make sure that you leave any and all feedback and thoughts there for the team. And we see you all on Monday for our remote day of JSNation. Bye.
What will I build today? Whatever it is, it has to be smart and connected. An app, an experience, a company, my company. Whatever it is, I'll need the right tools, all the tools. I don't want anything holding me back. What will I build today?
AG Charts is a modern open source charting library built for TypeScript, React, Angular, and Vue. Get started by simply providing your data, defining your series type, and then creating a chart. AG Charts provides over 25 different chart types, enabling you to visualize your data in any way you need to, from simple to complex. Learn more and get started for free at aggrid.com/charts.
Mother